Hello everyone. Welcome back to Let's Revise by Vidyashri Kadlibuddi, your one-stop destination to learn, revise and succeed. Have you ever wondered why are the Himalayas so tall? Why do volcanoes suddenly erupt? Or how are beautiful beaches, waterfalls and river valleys formed? Or why do earth shakes so terribly during the time of earthquakes without any warning? Believe it or not, all these amazing natural wonders are connected by one fascinating story, the story of our living planet. So, in today's video on Let's Revise, we are beginning an exciting journey into Chapter 2, Shaping of the Earth's Surface, where you will discover the Earth's beneath our feet is not still, it's constantly changing. Most people think that Earth is solid and unchanging, but that's not true. The Earth is like a giant puzzle made up of huge pieces called as tectonic plates. These plates move very slowly over hot layer beneath them. Although we cannot feel this movement, it has been shaping our planet for millions of years. Because of this movement, mountains rise, volcanoes erupt, continents shift, and earthquakes occur. The Earth's surface is always changing because of the powerful forces acting from inside on Earth and on its surface as well. And trust me, by the end of this chapter, you will start looking at every mountain, every river, and a valley with a completely different perspective. So, what are we going to learn in this chapter? In this chapter, we are going to study 5 exciting questions. The first one is what shapes the Earth's surface? We will understand the internal and external forces that continuously change our planet, which is in connection to our second question, where we explore about plate tectonics, one of the most important theories of geography, which explains us why earthquakes happen, how volcanoes form, and how mighty mountain ranges like the Himalayas came into existence. So that is our topic number 1. You can see here. So plate tectonics will explain us about in which we initially start with Earth's layer, then we start about different types of tectonic plates. We also concentrate on what are the causes of movement of plate tectonics. We study about plate boundaries, then we study about lithosphere and asthenosphere, and then we study because of the plate movements what are the effects that we are supposed to bear upon. This is our topic 1, question number 1, and question number 2, that is we are going to explore. In the next question, we will discover how different landforms are created. We will study about mountains, plateaus, plains, valleys, deserts, coastal landform, and even river landforms also. These are different types of fascinating landforms which are formed because of different processes that occurs on the Earth's surface. Okay, so that is our topic number 2, where we study about landforms like mountains, plateaus, plains, valleys, and all other things. Moving ahead, the fourth most important topic that we will study here would include 3 concepts. That is, we will understand the important processes of weathering and erosion, where we will learn of how rocks slowly break down and how rivers and wind, glacier, and sea waves reshape the Earth's surface over thousands of years. So, uh, concept number 3, concept number 4, and concept number 5 is our fourth most important topic that we are going to study. So, we are going to study about what is weathering, what is erosion, what are the agents of weathering, and due to this process, what are the different types of landforms that are created is the main aspect of the chapter number 2 of geography in class 9 of shaping of Earth's surface. And finally, we are going to study how these landforms influence our daily lives. Why do people settle near rivers? Why are fertile plants called the food bowls of a country? Why do beaches attract tourists? And how do natural disasters like earthquakes and floods affect human life? This chapter this chapter beautifully connects geography with human life. So that's our point number 6 and point number 7. That is the final question of the chapter. Importance of different types of landforms to human beings, like how they can bring economic importance, and what are different types of natural disasters that we face, and how we can manage ourselves during the time of these natural disasters. So in this chapter, we are going to connect complex concepts of geography with human life and understand how different processes that happen on the earth's surface affects human life in a positive aspect as well as in a negative aspect. And don't worry, here on Let's Revise by Vidyashri Kadlibuddi, we will learn every concept with simple explanation, real life examples, colorful diagrams, and easy tricks to help you remember everything. So, this chapter is much more than just learning definitions. It's about understanding how our amazing planet works and why every mountain, river, beach, valley, and volcano has its own incredible story. By the end of this chapter, you will not only score well in your CBSE exams, but also look at the world around you with completely new eyes. If you're enjoying this learning journey with Let's Revise by me, don't forget to like, share, and subscribe. Press the bell icon so you never miss any class videos that I post. So, are you ready to explore the powerful forces that shape our Earth? Let's begin chapter 2, Shaping of the Earth's Surface. Before we begin, tell me in the comment section, if you could visit just one natural landform, which one would you choose? A volcano, the Himalayas, the waterfall, or a beautiful beach? Comment your answer below. I'll be reading and replying to your comments. See you in the next video on the lesson of shaping of the earth's surface, only on Let's Revise by Vidyashri Kadlibuddi. Bye everyone. Hello everyone. Welcome back to Let's Revise by Vidyashri Kadlibuddi, where we learn, revise and succeed. Imagine waking up one morning and seeing a brand new mountain outside your window. Sounds impossible, right? But did you know that the mountains, valleys, rivers, beaches, and even continents we see today weren't always like this? The earth has been changing continuously for billions of years. And in this chapter, we are going to uncover the powerful forces that shape our planet and answer five very important big introductory questions that form the foundation of this geography lesson. So let's begin our exciting journey with chapter 2, Shaping of the Earth's Surface. And to begin this chapter with, they have given you five very big questions, introductory questions to think upon. Now, these questions enhance your critical thinking and force you to have a study on the basis of inquiry. Right? We had this topic in the introductory part of this entire textbook in your previous chapter number 1. So, the first critically thinking question to you all, the biggest question is, what shapes the Earth's surface? Okay. Have you ever wondered why every place on Earth looks different? There are certain places that have mountains, there are certain places which have plains, there are places with deserts, beaches, rivers, and even deep valleys also. So, what creates all these different types of landforms? Now, let's answer this question. The Earth's surface is shaped by two powerful forces. Okay. The surface, the one is called as the internal force. Okay. These forces originate inside the earth. The force that comes from inside the earth is called as internal force, and these internal forces causes earthquakes, volcanic eruption, and mountain formation. Next force is called as the external force, and these work on Earth's surface like wind, river, glacier, sea waves, and rain. Slowly wear and tear away rocks and reshape the land through weathering and erosion. And together, these forces constantly keep on changing our planet. So remember these 2 points. There are two forces, internal and external forces. Internal force that comes from inside the earth, external force that comes from outside the earth surface. Togetherly, they change the surface of the earth. Moving ahead with the second question. What is plate tectonics and what are the effects of the plate movement? This is the topic that is very much important in this chapter. The earth is not one solid piece, remember this. Its outer layer is divided into huge pieces called as tectonic plates. Now we know that this is the earth's surface, then we have three rings inside it, which we call it as crust. Then inner surface is called as mantle, and then inside that we call it as core. Now we usually see Earth as a very big solid piece, but it is not. Whatever crust we have, this crust is divided into multiple pieces, and those multiple pieces is what we call them as tectonic plates. And these tectonic plates that are the part of the crust, they are always floating on what? They are floating on the hot mantle which is there, and they keep on moving very slowly, like very few centimeters, like for example 1 centimeter or 2 centimeter every year. And when these plates move, they collide or they move away, because of which mountains are formed. When they move away, when they slide next to each other, ocean floors or volcanoes are created. And when these plates move away from each other, then earthquakes occur. And this entire concept is basically called as plate tectonics, and it explains why our earth is always changing. So we earth definitely looks to us as a solid ball, but it is not a solid ball, it keeps on continuously moving. So, going ahead with the third most important question, how are landforms formed and how are they classified? So, whatever landforms we have, these are all natural features created on its own without any human interference, and they are found on Earth's surface. They are formed into two major ways. Some are created, like I told you, Earth has two forces, one is internal force and the other one is external force. So, some of these features are created because of internal forces like mountains and volcanoes, whereas some of other land features are created because of external forces like rivers, wind, glacier, groundwater, and sea waves also. So throughout this chapter, we are going to study about mountains, plateaus, plains, valleys, waterfalls, beaches, deltas, sea caves, and all, and many more fascinating features. And every landform has its own story of formation, which we are going to study in this exciting chapter of geography. Moving ahead with question number 4. How are humans and other living beings connected to these landforms? Landforms are not just beautiful, they are essential for our lives. Like plains are fertile, they help farmers to grow food. Rivers provide drinking water. Mountains influence the climate. Beaches and waterfalls attract tourists. Glaciers are a source of fresh water. And all our settlement, our occupation, transportation, tourism, everything is closely connected to the landforms. In simple words, if I have to say, landforms shape human life, and humans are completely dependent on different types of landforms on every single day basis. Moving with question number 5, which talks about how do disasters associated with different landforms impact human lives, right? So, different landforms cause different types of disasters, and different disasters definitely affect the human life. The same forces that create beautiful land masses like internal and external forces, these same forces are the reason. Okay, remember this. The same forces are the reasons that also cause disasters. Earthquake can destroy buildings, volcanoes can bury villages, floods can damage crops, coastal erosion slowly eats away beaches. This chapter will teach us not only how these disasters happen, but also why understanding geography help us to prepare for them and reduce the impact. So in this chapter, we are going to discover answers to all these 5 questions in a very detailed manner. So, by the end of this chapter, you will understand that Earth is not a lifeless rock, it's a dynamic planet that is constantly changing and shaping the world we live in. So, if you found this introduction helpful, don't forget to like this video, share it with your classmates, and subscribe to my channel for complete CBSE Class 9 Geography explanation. Press the bell icon so you never miss any upcoming lessons. And before I end the video, I have a question of the day for you. Which natural landform fascinates you the most and why? Volcano, mountain, waterfall, or a beach? Write your answer in the comments below. Until next time, this is Vidyashri from Let's Revise. Keep learning, keep revising, and keep succeeding, and keep visiting my videos again and again. Bye, everyone. Hello everyone, welcome back to my YouTube channel Let's Revise by Vidyashri Kadlibuddi. In my previous video, we had an introduction on the concept of plate tectonics of your chapter number 2, shaping the shape of the Earth's crust over there. In today's video, we are going to have a detailed study on the concept of plate tectonics. We are going to study what is the theory of plate tectonics, how do these plates move, what are the different types of landforms that get created because of these plates and all is the basic concept that we are going to study in detail in today's video. So without wasting much of our time, let's dive deep into the concept of plate tectonics. Okay, so plate tectonics is an important theory which was given by a geophysicist named as W.J. Morgan in Earth Science, where he explains the movement of Earth's crust. So the plate tectonics is a concept which has been given in the form of a theory, and this theory was generated by a person called as W.J. Morgan. And this scientist or geophysicist, what we call him as, explains us about what he explains the movement of the Earth's crust. So theory of plate tectonics is nothing but the movement that is observed in the Earth's crust region here. So what does this theory tries to prove? The theory, let's understand that according to this theory, the outermost layer of the Earth is not one single piece but is broken into several large and small pieces called as tectonic plates. So what does W.J. Morgan tries to explain in plate tectonics? He explains the movement of the Earth's crust. And in this theory, he tells us that the outermost layer of the Earth is the crust layer, and it tells that this crust layer is not one single piece of land which is available, but this crust is actually made up of several large and small pieces of land, and those several large and small pieces of land, according to the terminologies of W.J. Morgan, are called as tectonic plates, or we can call them as plate tectonics also. So what does he try to prove in his theory? He tries to prove that the Earth's crust is not one single piece, but it is broken into several large and small pieces. This is the most important part of the theory, the first and the foremost part, where he tries to prove that Earth crust is not a single slab, it's a multiple slab of large and smaller sizes here. He also further adds that these plates move slowly over the semi-molten layer beneath them and are responsible for major physical features and natural phenomena such as mountain, earthquakes, and volcanoes. So the first part of the theory is this, where he tells that the Earth's crust is divided into several large and small pieces of land called as tectonic plates. And the second most important part of his theory is that he tries to tell us that all these tectonic plates, what are they are moving slowly. Okay, how are they moving slowly? Because they are present on a semi molten layer, and this semi molten layer which is present below the layer of the crust is responsible for the movement of the plate tectonics. And whenever these tectonic plates move, they form major physical features or these natural phenomenon where they lead to the formation of mountains or the occurrences of earthquakes or the occurrences of volcanoes. So remember children, whenever you write or whenever you are asked a question in your examination to define the theory of plate tectonics, then you have to tell that plate tectonics is an important theory that tells us two important things. One is the Earth's crust is made up of several large and small pieces called as tectonic plates, and second most important part is that these plates move on semi molten layer that is present below the crust and which cause the formation of major physical features and natural phenomena such as mountain, earthquakes, and volcanoes. This entire thing is the proper definition of plate tectonics. Fine. Let's understand this very concept with the help of the image that I have put up in the slide. So I have put the image of W.J. Morgan. You might be asked as a picture paste question in your examination by your teachers here. So this fellow is called as W.J. Morgan here, who is a geophysicist, and he is the person who gave the theory of plate tectonics that we are studying today. And according to him, he tries to suggest that the crust of the earth, so the blue line and the green parts that you're seeing in this image here, he tells us that the earth's crust is not one single slab. Instead, it is a crust which is made up of several large and small plates, and these plates are floating on semi-molten layer which is present below the crust. So you can see there are certain cracks here. So these cracks resemble that they are different pieces which are combined together, and these different pieces, they might be small or they might be large, they are togetherly called as plate tectonics here. And every plate tectonic has names. Like for example, the region that covers the area of North America is called as North American plate. The area that covers Europe, Asia and all, it's called as Eurasian plate. The region that covers the Indian Ocean is called as Indian plate along with the Indian subcontinent. Then the area that covers the African region is called as African plate. Then the area that covers the South American region is called as South American plate. The ocean bed or the crust of the ocean present below the Pacific region is called as the Pacific belt. Likewise, the region covering the Antarctic area is called as the Antarctic plate over there. So W.J. Morgan gave the theory, and according to his theory, the Earth's crust is not one single whole large piece of land that we find. Instead, it is divided into several large and small tectonic plates, and these plates are floating on semi-molten layer of the earth. So let's understand the next slide. Now this slide is the second part of theory of plate tectonics. Okay, now here you can see, I'll just change the color for you guys. Okay, now here you can see this is the smaller portion of earth image that I have generated for you. Now in this one you can see this small portion is called as the crust region, and this is called as the mantle region. Fine. Now crust is basically solid in nature, but whereas mantle is semi-molten in nature, and this entire crust is present and is present on what? It is present on the mantle layer. So because there is movement that happens in the mantle layer, whenever any movement happens in the mantle layer, the plates that are present above the mantle, the crust layers, are also going to move, but this movement is going to be very slow. But whenever they move for millions of years, they generally cause major physical features and other natural phenomena. So major physical feature that it creates is it leads to the formation of different varieties of mountains, and natural phenomena that occur which cannot be avoided by us is the earthquake, and the other one is the volcanoes. This is one thing that happens because the crust moves. Why it moves? Because it is present on a semi-molten layer, and that semi-molten layer is called as the mantle. And why does mantle move? Because there is huge amount of chemical reaction that is going on, because of which excessive heat is generated, about which we study in the next part of the concept of plate tectonics. Remember two important parts of theory of plate tectonics as suggested by W.J. Morgan. The first part is the Earth's outer layer is broken into several large and small pieces which we call them as tectonic plates. And second most important part is that these crust or these tectonic plates are present on semi-molten layer called as mantle, and they move slowly because of that, and whenever they move they create mountains, earthquakes and volcanoes. So these are the two most important parts of theory of plate tectonics that you have to remember. So as I told you that they cause different varieties of major physical features. One is the mountains, which we know Himalayas. Earthquakes are very common and volcanoes are also very common whenever the movement of plate tectonics happens here. You can see certain arrows that has been shown in the Earth's crust here. One is moving ahead, then some are moving towards each other and all. So about which we'll study in the next portion of this video here. So I hope the theory of plate tectonics is clear to you all. So in the comment section, comment me the answer to a very simple question. Who is the geophysicist who gave the theory of plate tectonics? I want you all to answer this question in the comment section, and I'll be replying to each one of you here. Moving ahead with the next part of the topic of plate tectonics, where we have to understand two very important things, that is the layers of the earth here. So the earth is made up of, let me change the color for you guys. Yeah. The earth is made up of three main layers: crust, mantle, and core. The crust is the outermost layer on which we live. Below the crust lies the mantle, which is very thick and hot. The core is the innermost layer and is extremely hot and heavy. The crust, along with the upper part of the mantle, forms the lithosphere. This lithosphere is broken into different tectonic plates. Beneath the lithosphere lies the asthenosphere, which is semi-molten and allows the plates to move. Now, this is a very important part to understand about the earth. Okay, so we know that whatever earth surface we have, whatever earth we are living on, this earth is divided into how many layers? It's divided into three layers. The first one is the crust, the second one is the mantle, and the third one is the core. So the outermost layer is the crust on which we are living in, and below the crust is the presence of mantle, and this mantle layer is very thick and hot, and below the mantle layer is the presence of core, and this is extremely hot and very heavy. Now, what is the crust layer? Crust layer is also called as lithosphere. Okay, so what is this lithosphere that we have to understand? Fine. Now imagine this is the crust layer, below which is a small thin layer of the mantle. Now imagine this is the entire region of the mantle, but this small crust region along with small region of the mantle togetherly is called as the lithosphere. So the upper part of the mantle and the crust togetherly are called as what? They are called as the lithosphere here. And below the lithosphere is the presence of a very small layer which is extremely semi-molten, and because of this layer, which is also the part of the mantle, but it is called as asthenosphere, which is extremely semi-molten in nature, and this asthenosphere allows the plates to move. So this is the textual part that I wanted to tell you. Moving ahead to study the same topic with the help of the picture over here. Now this is the picture that I have modified it a little, but it is the same picture that has been given to you in your textbook. So one part of the textbook explains you the structure of the earth or the layers of the earth. Okay, so this part is the crust part, then you have the mantle part, and then you have the outer core part, and then you have the inner core part. So when we talk about the crust layer, its thickness is between 30 to 40 kilometers and under continents, and but if you go deep into the ocean, the thickness of the crust is generally between 5 to 7 kilometers only. Then we have the mantle layer. The mantle layer Then we have the mantle layer, and the mantle layer is actually solid layer between the crust and the earth's outer core, but it is semi-molten in nature, not completely solid. Then we have the outer core region and inner core region. Outer core region is a fluid area. Inner core region is hot spinning metal ball, that is densest part of the earth. Now in between them we have two more other parts which we call them as lithosphere and asthenosphere. Now this image is a cross section, a small portion of the earth's crust which has been given. Now when we talk about the earth's crust, I have told you in my previous video, it includes the ocean beds as well as the continents. Togetherly is called as the crust part. So when we talk about the distance of the earth's crust from the continent region, its distance or its total height would be around 30 to 40 kilometers. But if you go deep dive into the ocean, and from the bed if you try to measure what could be the distance over there, then you can see that the distance or the height of the crust is generally 5 kilometers. Fine. Below that is the presence of what we call as the mantle layer. This is the complete region of the mantle layer here. Then we have the core region, which is divided into outer core and inner core. But among these two, there are two other important regions of the earth here. What are those two important regions? The first one is lithosphere. Okay. Now, what is this lithosphere? Lithosphere is a connection between the crust layer and the mantle layer. The upper part of the mantle layer and the crust layer togetherly is called as the lithosphere. And below that is the presence of yet another layer, which we call it as the asthenosphere. An asthenosphere extend up to 200 kilometers in the mantle layer, which is the uppermost part of the mantle. And this is a region which is extremely hot, and moreover molten or semi-molten liquid kind of composition is what is found in the asthenosphere, and this region is extremely continuously into movement, and because of that, whatever reactions happen or whatever heat is produced in the regions of the mantle, that affects the lithosphere and the crust, leading to the movements in the crust region or the movement in the plate tectonics. So to study about the concept of plate tectonics, we have to understand the structure of the earth in whole, as well as we have to understand the two other important aspects of the structure also, which includes the lithosphere as well as the asthenosphere. Moving ahead to the next slide. Now in this one, we are going to study about different types of plates that are found on the earth's surface. Fine. So tectonic plates are massive slabs of solid rocks. What are tectonic plates? They are solid rock and slabs. Slabs are huge chunks of rocks, single rock or multiple rocks. So plates which are massive slabs. Massive means large slabs of solid rock. They are called as tectonic plates here. Okay, and these tectonic plates, which are solid rocks, move very slowly, usually a few centimeters per year. So, what is the distance that is traveled or moved by the tectonic plates every year? Only few centimeters, ranging from 1 centimeter to 5 centimeter on an yearly basis. But if this procedure continues for millions of years, then we can see a huge change in the movement that has occurred in the tectonic plates here. Now, whenever we talk about different types of tectonic plates, now in this concept, we are going to understand types of tectonic plates. Fine. So we generally see there are three main types of tectonic plates. So what are those three main types of tectonic plates? The first one is continental plates. Fine. And second one is oceanic plate. And third one is mixed plate. Now what are these? Let's understand one by one. So continental plates are the one which carry the continents. Oceanic plates are the one which carry the ocean floors. Then we have the third one, which is called as mixed plate, and in mixed plate, the plates that carry continents as well as the parts of ocean are called as mixed plates over here. And on the earth's surface, the entire crust region is divided into several number of major tectonic plates, which includes Pacific plate, Eurasian plate, African plate, North American plate, South American plate, Indo-Australian plate, and Antarctica plate. So, in this topic, we are studying two important things. One is types of tectonic plates, which includes continental, oceanic, and mixed. And then we studied different names of tectonic plates, major tectonic plates found on the surface of the earth, which include Pacific plate, Eurasian plate, African plate, North American plate, South American plate, Indo-Australian plate, and Antarctica plate. So let's understand this concept with the help of the pictures here. Fine. So the very first concept that we studied on the topic of tectonic plates is the different types of plates. Fine. So the first one is continental plate. Now here you can see the crust region which is carrying only the land mass or the continent is called as continental plates. Now the crust region which is carrying the ocean above it, we call it as oceanic plate. But the crust region which carries a part of the ocean, which can be seabed or something, along with the continent, we call it as mixed plate over there. Fine. Now, this is the picture This is the picture of major tectonic plates of India that has been given. Major tectonic plates that are found on the earth that are given over here. The first one is the region covering the North American plate is called as North American plate. The area covering the South American plate is called South American plate. Then the region carrying the Africa is called as African plate. Then the region carrying the Eurasian region is called as Eurasian plate, which includes Asia. Then Europe as well as India is called as Eurasian plate. And then we have the most important one, which is called as the Indo-Australian plate, and the Indo-Australian plate covers the Australian region and the Indonesian region. That's why it's called as Indo-Australian plate. And then the last one is the Antarctica plate, which carries the Antarctica portion of the earth. Now, among this picture, can you tell me which of these major plates are continental plates? Which of them are oceanic plates? Which of them are mixed plates in the comment section? Look at the picture that I have shared in this video, and according to your picture analysis, you have to tell me among these seven major plates, which of them are continental plates, which of them are oceanic plates, and which of them are mixed plates in the comment section. And I'll check in your comment section whether your answers are correct or no. Okay, so before you answer, I'll revise once again quickly to you different types of plates that we find in on the surface of the earth. The first one is continental plates carrying only the continents. Then we have the oceanic plates carrying only the ocean. Then we have the mixed plates which carries the ocean as well as the continents here. So for you to make it more easier to have a good guessing for the points, for the answers that I've asked the question here, I have given you a brief explanation on the concept, which all areas do they cover. And these explanations should help you to identify the continental plates, oceanic plates, and mixed plates thoroughly and put them in correct answers in the comment section. So make it more convenient for you, let me explain you about the Pacific plate. The Pacific plate covers what? The Pacific Ocean. Eurasian plate covers Europe and Asia. African plate covers African continent and surrounding seas. North American plate covers North America and surrounding areas. South America plate carries South America and adjacent ocean floors. Indo-Australian plate covers India, Australia and surrounding oceans. Antarctica plate carries Antarctica and the Southern Ocean. So this explanation should help you to identify among the seven which of them are continental plates, oceanic plates and mixed plates with the information that is given to you in this slide. So I'll be waiting for your comment section, children. So I hope the explanations so far are very clear to you. So let's move to the next concept where we study a very important topic called as the movement of plate tectonics. Now this is a very important concept that we have to concentrate on. Okay, so how does this movement happen? We know that any movement that happens in the mantle region leads to movement in the crust region, but there should be some phenomenon or some procedure that is occurring in the mantle region because of which even the crust also moves. So let us understand this concept in a clear way. Fine. So the movement of tectonic plates is caused by convection currents in the mantle. So what is the reason behind the movement of tectonic plates? There is some kind of current. Okay, current is nothing but movement. So which happens where? It happens in the mantle region. And those movements in the mantle region are called as convection currents. So these convection currents are the reason why the tectonic plates move. And where do these convection currents occur? They occur in the mantle region. Let's dive more into this concept. Heat from the Earth's core causes molten material in the mantle to rise, while cooler materials to sink. This continuous movement creates convection currents that push and pull the tectonic plates, causing them to move in different directions. Now, how do these convection currents come into existence? Now, we know that Earth's innermost region is called as core, and this core is one of the most hottest region. Now, whenever excessive heat is generated, what happens? The molten area or the mantle area near the core region gets heated up. And whenever something gets heated up, it becomes light. And when it becomes light, it rises above. So the mantle which is very hot, the molten mantle region which is hot rises above. And above, the upper layers of the mantle or core are basically cooler, and when this hot mantle comes up, the cooler mantle sinks down. That means it comes down. Now when this movement happens, the hot mantle goes up and the cool mantle comes down. It is a circular motion that takes place. That circular motion is what causes the convection current, and this convection current basically leads to the pushing and the pulling of the tectonic plates. And because of that, the tectonic plates move into different directions. Now, this is very much important for us to understand. So, let's understand this topic with the help of a diagram. Okay, so this is the same diagram that has been given into your textbook also. Fine. Now, this is just a representation about what happens in the regions of the inner regions of the earth's surface here. Fine. So movement of material below the crust. What is the below the crust? Below the crust is the presence of mantle layer. So heat from the earth's interior drives the movement of material beneath the crust through a process called as convection. So which is the most hottest region? The hottest region is the core region. Okay. Now what happens over here? There are three names which has been given how the heat transportation mechanism takes place in this region. So we have something called as magma zones. These are the magma zones that we see. Now what are these magma zones? Magma zones from the magma from the mantle rises to the surface through weak zones in the crust. Now this is very much important, which I'll tell you later when I come down to this topic. Now let's understand how does the heat transport mechanism happens within the layers of the earth's crust and the mantle region. Okay, so we know that the core region is the hottest region. So the heat comes from the core surface. Now whenever this region, the bottom layers is hot, the layers immediate next to that becomes hot. Right. Now, when this becomes hot, the same heat gets transformed, and that heat, when it moves up, what happens is whatever layers which are cooler or with less temperature present here, they try to sink down. Like this, what happens again, the heat moves through the materials through direct contact, and then again it reaches the upper mantle region. And when this upper mantle region happens, the hot mantle comes up and the cooler mantle which was present here, that sinks down. And when this sinks down, what happens? The temperature here goes on decreasing, but it again increases because of absorption of heat. But the temperature here increases, and there is a kind of circular movement that gets established. Because of this movement that happens in the mantle region, what happens is the crust area starts moving in different directions. Okay, so let's understand what are these different names. Advection means what? Heat is carried by the actual movement of the material itself. So this area becomes hot, so this material, the hot material from here, starts moving into the next layer, and that leads to the formation of convection current. Heat is transferred by the movement of hot and cool material in the fluid mantle. So how does the heat move from this area to this area? Because of the convection. So hot material makes space and moves up, and colder material comes down, and from there it leads to the conduction, whereas heat moves through materials by direct contact from hotter regions to cooler region. So from hotter region it moves to the cooler region, and when that happens, the cooler region also gets heated. That leads to a continuous convection currents generation in the mantle region, and because of this, the movement in the earth's crust is seen. Now, whenever this happens, there are some points called as magma zones that gets developed in the upper mantle region. So what are magma zones? Magma zones are nothing but magma from the mantle rises to the surface through weak zones in the crust. So there are certain weak zones in the crust, some porous regions in the crust. So whenever the hot magma rises, sometimes these do not form the convection current. A portion of the hot magma tries to come out through the crust layer, and when it tries to come out through the crust layer, we know what happens. Volcanic eruptions take place here. So this is the process of how the movement of plate tectonics generally takes place. So convection currents is the main reason why the mantle gets heated up from the core, and why the tectonic plates move, and how does the shape of the earth keeps on changing. So I hope this concept of movement of plate tectonics is very clear to you. The heat comes from inner core, moves to the outer core, then to the lower mantle, then to the upper mantle through a process called as convection currents. And that's how, when convection currents become more intense in the mantle layer, it leads to movement in the crust region, leading to earthquakes or volcanic eruptions, and finally leading to the formation of a major physical feature around us over the period of time. So moving ahead with next most important topic, which we call as where we study about different types of plate movements. Okay, so in this topic we are going to study about plate boundaries, which are nothing but different types of plate movement causes different types of plate boundaries. So we will be studying about three types of plate boundaries over here. So what are these plate boundaries? Let's understand that concept in depth. The edges where tectonic plates meet are called as plate boundaries. Fine. So if I have to show you this through a picture, then let's go to slide 2. Okay. Now in this you can see this is the ridge, or this is the gap where you see there is a kind of presence between one plate to another plate, a kind of a rift, but this rift is joined together. Like for example, if I have to talk about the African plate and the North American plate, the African plate and the North American plate are joining with each other. So there is some boundary which is present between the North American plate and the African plate here. So this zone is called as the plate boundaries. And in total, because of different types of movements in the plates that happen, we generally have three types of plate movements that we will be studying now in this topic. Okay, so the edges where tectonic plate meets are called as plate boundaries. So when one landmass meets the other landmass, so this gap, this middle joining that you see, that middle place where the two plates join or they meet is basically called as the plate boundaries here. And in total we have three main types of plate boundaries. The first one is called as the convergent boundary, where two plates move towards each other. When continental plates collide, they form fold mountains such as the Himalayas. When an oceanic plate collides with continental plate, the oceanic plate sinks beneath the continental plate, leading to volcanic activity and earthquakes. Now, this is very much important for all of you to understand. So, the first type of plate boundary is called as convergent boundary. Convergent boundary means what? When two plates meet with each other, they converge with each other. Okay, they collide with each other and they join together. So that is why this is called as a convergent boundary. So when one landmass meets the other landmass, they come towards each other. They're coming towards each other. Okay, they're coming towards each other. When two continental plates, that means when two landmass come towards each other, they collide. And when they collide, they lead to the formation of what we call them as fold mountains. Okay, so this is one landmass and there is another landmass. When they collide, a mountainous region gets erected and those mountains which are formed because of the folding of two main subcontinents or two main land masses, we call them as fold mountains. And one of the example of fold mountains is the Himalayan mountains that are found in India. Likewise, there is a movement, or even oceanic plates also collide. Okay, so when all oceanic plates collide with continental plate, now see, two land masses. Landmass A is oceanic plate and landmass B is continental plate. And when they come towards each other, what happens? When they come towards each other, the oceanic plate sinks beneath the continental plate. Means what? The continent is heavy. The continental plate is heavy. Its height is also more. Oceanic plate is weak and its height is also less. So the continental plates dominates over the oceanic plate. And because of this, what happens? The oceanic plate goes down. Okay, so if I have to be more clear, the oceanic plates go down and the continental plate dominates it. So this area of the oceanic plate is covered by the continental plate here, which means the ocean sinks down the continental plate, and because of which volcanic activities happen and earthquakes are very commonly found in such convergent plate when oceanic plate and continental plates collide with each other. Like this, we have yet another very important another type of plate boundary, and the second type of plate boundary is called as divergent. The name itself should suggest divergent means moving far from each other. So where plates move away from each other in case magma rises from below and forms new crust, creating features such as mid-oceanic ridges. And the example, the mid-Atlantic ridge is a good example. Okay, so what is happening over here? Now suppose this is one oceanic plate and this is another oceanic plate, A and B. Now when they are moving far from each other, what happens? The distance between them increases, and this distance, what happens? Two crust layers are moving away from each other, and when crust layer moves away from each other, below the crust is the presence of magma. So this magma actually rises up, and when the magma rises up, it leads to the formation of what we call it as a new crust. And one of the example of such a crust which has been formed because of divergent movement is mid-Atlantic ridge. Fine. And the third most important plate boundary is called as the transform boundary, where the plates slide past each other without creating or destroying the crust. This type of movement mainly causes earthquake, such as along the San Andreas Fault in the United States. Now, this is very much important movement that we have to understand. Now, suppose this is a long slab, huge slab of land which is present with some ridge between them. These are two plates that we find which are joined years ago or something, and now because of some mantle movement there is some kind of transform boundary that is taking place between them. Suppose a force on A is acting, a force on the slab A is pushing it up, then a force might be applied on B where it is being pushed in the opposite direction. Now, when the plates move in such a way, what happens is the A slides and form takes a new position, and there is a gap which is created here. That gap or such a type of movement is called as transform boundary, where there is no creation and no destroying of any crust. So such type of movement is called as transform boundary. Such type of movement is called as transform boundary, and one of the example of such a movement is the example of San Andreas Fault that is found in the United States. So there are in total how many types of plate movements? 3 types of them, and they are called as convergent, divergent and transform boundary that we see. And let's study the some concept with the help of images here. So the first movement is called as the convergent movement, which you can see in the image that has been given here. So in convergent movement, one continental plate and the other continental plate coming towards each other. What is happening? They are colliding with each other. So whatever land mass, small amount of land mass which is present between them, what happens? They rise up. And when they rise up, they lead to the formation of mountains. So when plates collide, the crust crumbles and that forms the fold mountains. In the convergent boundary, we have also have studied yet another type of movement which happens between the oceanic plate and the continental plate. So now this is the oceanic plate and this is the continental plate. Now because continental plate is heavy and thick, oceanic plate is not so heavy and very less in thickness, what happens is the force makes the oceanic plate to go below the continental plate. So the oceanic plates sinks down. Okay. Okay, so let's study the picture about divergent boundary. Now in this second picture, you can see in divergent boundary, one plate or two different plates which are close to each other may start moving far from each other. Okay, you can see the arrows are moving in opposite direction. So when the land masses move away from each other, it creates a space, and that space is occupied by the magma which cools down and forms a new crust. An example to divergent boundary is mid-Atlantic ridge. Fine. The third one is transform boundary, where you can see there is some kind of convergent movement, but at the same time they're sliding past each other. Okay, so they are not converging, they are not diverging, they are moving towards the same direction, but they might just cross each other or have a cross kind of movement in between them. So they there's a kind of a fault which gets created and there is no destruction of the crust at all. An example of that is San Andreas fault, which is found in California, USA. So we have to remember one thing: whenever plate movements take place, whether it is convergent movement or a divergent movement or a transform boundary, it leads to the formation of different types of land features like fold mountains, volcanoes, mid-oceanic ridges, and even earthquakes too. So this is about the plate boundaries that I wanted to teach you all. So moving ahead, about a very simple concept of plate tectonics. Now this is very much important to understand. In plate tectonics, we have something called as the oceanic ring of fire, which is generally found along the lines of the Pacific Ocean. Now, what is this ring of fire is what we study over here. Like I've told you, plate tectonics play a major role in shaping the Earth's surface. We have studied so far that whenever movements in the plates happen, they either lead to the formation of mountains, valleys, ocean basins, volcanoes, or earthquakes. Fine. Now, these are the pictures in reference to whatever different types of landforms are created over here. The most important concept in this slide is to study the ring of fire. Now, what is this ring of fire? Most earthquakes and volcanoes occur along plate boundaries. So, if we understand the plate boundaries, whether it is convergent, divergent, or a transform boundary, in such places, whenever movement takes place in such areas, there are usually two types of activities that are noticed. Either there is earthquake that happens or there is volcanic eruption that takes place, and this is very commonly seen along the line of the Pacific Ocean, on the Pacific plate and along the line of Pacific Ocean, which starts from this zone. Okay, I'm marking it with blue color for you all for reference, which starts from the region of Indo-Australian plate, goes to the Eurasian plate, then to the North American plate, and then to the South American plate. So along this line, as there is lot of convergent and divergent plate movement which is seen, there is frequent occurrences of active volcanoes or earthquakes that is generally seen. So as there is a lot of frequency in this movement of plates and occurrence of volcanic activities or earthquakes, so this zone is basically called as ring of fire because of the movement of the plate that happens and the features that are associated with the ring of fire. Fine. So moving ahead to understand this, concept. So plate tectonics play a major role in shaping Earth's surface. They lead to the formation of mountains, valleys, ocean bases, volcanoes, and earthquakes. It also explains distribution of continents and ocean across the Earth. Most earthquakes and volcanoes occur along plate boundaries, especially around the Pacific Ocean, an area known as the Ring of Fire. Now, this is very much important. So, whenever you have a question, where do you find the Ring of Fire? Remember, along the coastal lines of the Pacific Ocean, which covers the Indo-Austrian plate, Eurasian plate, North American plate, and South American plate. Fine. So moving ahead, the last part of the topic of theory of plate tectonics. So what is the conclusion of this overall topic? In conclusion, the theory of plate tectonics helps us understand how the Earth's surface is constantly changing. So what is the importance and why do we need to understand plate tectonics? Because it helps us to understand that Earth's surface is not constant. Instead, it is constantly changing every now and then. Second, it explains the origin of many landforms and natural disasters. So if we understand theory of plate tectonics properly, we can understand how different landforms have come into existence and what are the basic causes of natural disasters and how we can be prepared during those times. Now, this theory of plate tectonic is also very important for identification of earthquake zones, volcanic prone regions, and manage disasters arising from them. So to save ourselves during the time of disasters of earthquake and volcano, we need to understand the theory of plate tectonics, because of which we can save thousands of lives on the earth. So that is about the entire concept of theory of plate tectonics explained in detail to you all. If you have any doubts over the concept covered so far, you can put those doubts in the comment section. I'll be definitely replying to your doubts. And do not forget to answer the questions that I've asked in the middle of the videos. And anytime, do not forget to like my videos, share my videos, and comment any doubts that you have, and subscribe to my channel. Share my videos to your friends also, because sharing is definitely caring. So until I meet you next time in my next video, see you all. Bye everyone. Hello everyone. Welcome back to my YouTube channel. Let's Revise by Vidyashri Kadlibuddi. In this video, we are going to solve certain critical thinking and inquiry based activities that has been designed in this new syllabus for you all based on the topic of theory of plate tectonics. So we are going to solve questions like let's map, let's explore, and certain extra information where you are not supposed to miss them out at all. So starting with the very first activity that you are supposed to solve in your textbook is based on the concept of let's map, which has been given in relation to figure 2.3 of your textbook. So the figure 2.3 in your textbook is a map that shows major tectonic plates and the direction of their movement. For example, you have been given this map, and this map includes the name of major tectonic plates that are the part of the Earth's crust, which includes the Pacific plate, North American plate, South American plate, Antarctic plate, African plate, Eurasian plate, Indo-Australian plate, and the Antarctica plate. Now, based on this, you also see there are certain arrow marks that are found over here. These arrow marks are nothing but they show the movement of these plates. In which direction are they moving? Are they moving in convergent direction? Are they moving in divergent direction is what is shown over here. Now, on the basis of this map, the activity that you're supposed to solve is the small activity which is called as let's map. Let's map. So what is the question that you have been told to do here? You have to pick any two plates from the map above and complete the given table. And what all does the table include? The table includes the name of the plate that you're supposed to pick in. You're supposed to identify the continent it covers and the ocean that the plate basically covers. Now, in relation to that, out of the 7 to 8 tectonic plates that have been named here, you're supposed to pick any two that are more convenient for you all. So I'm going to give you two examples or two solutions to this, or you can pick any other also in relation to that. So in figure 2.3, you can find the first plate, if I have to talk about, if I choose the North American plate, then the continent that the North American plate covers is the North American continent, and the ocean that it covers is the Atlantic Ocean. So what are the details that you're supposed to fill in this table? Now, in the place of name of plate, you're supposed to write as, I'm just putting the abbreviations here, North American plate, and the continent that it covers is North America, and the ocean that it covers is Atlantic Ocean. Likewise, if you choose yet another plate, suppose if you're choosing the Indo-Austrian plate, fine, the continent that it covers is the Australian continent and parts of Asia, especially India over here, and the ocean that it covers is the region of Indian Ocean. So how are you supposed to fill the same detail again? So you're supposed to choose it as Indo-Australian plate, and the continent that it covers is the Australian plate and the part of Asia which includes India a lot, and the ocean that it covers is the Indian Ocean. Similarly, if you go ahead with other one, then suppose if you're choosing the African plate here, then the continent that it covers is Africa, and the ocean that it covers is the Atlantic Ocean, followed by the Indian Ocean. Similarly, another one, let's take another example for you. South American plate, the continent that it covers is South America, and the ocean that it is covering is the Atlantic Ocean. This is how you're supposed to solve the first activity, which is called as Let's Map. Fine. Moving ahead with the next activity, and the next activity is based on the concept of exploring. You are supposed to look at two figures and explain what is the correlation that you find in between them. For example, the question goes as, examine the plate map of figure 2.3 with the earthquake and volcano map of figure 2.4 and identify the correlation that you will observe over there. Now, the figure 2.3 explains us about the names of major plates and the direction that it shows. Now, this direction is actually very much important, right? But if you go to figure 2.4, the figure 2.4 is again a world map, but this is showing the places where you find the presence of earthquakes and volcanic activities. Now, looking at both the images, we are supposed to identify what is the correlation that we find over here. The correlation between, do we find any correlation is the first thing that we should be answering. Now, do you see any correlation between them? Remember, whenever plate tectonic move, we have studied in my previous video that wherever tectonic plates movement, there is either the formation of a new landform, or there is an earthquake activity, or there is a volcanic activity that happens. So we have to remember that there is a clear correlation that we find between the two maps, that is figure 2.3 as well as figure 2.4, which shows that most earthquakes and volcanic activities are concentrated where? They are concentrated in the regions of the boundaries of tectonic plates. Wherever there is the boundaries, whether convergent boundary or a divergent boundary or a transform boundary, in those areas we find the presence of earthquake activities, or we find the presence of what we call them as volcanic activities which takes place. And the highest concentration of this volcanic activity or the earthquake activity is highly seen along the regions of Pacific Ocean, and this area is called as ring of fire also, because there's always either an volcanic activity happening or an earthquake activity happening very frequently. This shows that plate movements are responsible for the occurrence of what? Earthquakes and volcanic eruptions. You have to remember this. So they might give you these two pictures and they will ask you what is the correlation that you find between the two pictures. So this is the answer that you're supposed to give, that most earthquake and volcanic activities are concentrated along the boundaries of plate tectonics, because as the plate movements happen, there is occurrence of earthquakes and volcanic eruptions which takes place, and the highest concentration is seen along the Pacific Ocean, which is also called as the ring of fire there. Fine. So let's move to the next activity. And the next activity which has been given is on the basis of figure 2.4 again. And the question that goes down here is, Observe the map showing the distribution of earthquakes and volcanoes, which is nothing but we have to observe the map of figure 2.4. And on that basis, we are supposed to identify which continents and countries are located around the ring of fire with the help of the atlas or a globe. Okay, so if you have atlas, very good. If you have a globe, very good. Keep them in your hands and let's solve this activity together. So now we are supposed to look at figure 2.4 and identify what we are supposed to identify two things. One is the name of continents and second one is the name of countries that are found along the ring of fire along this region. Okay, so let's solve the first one. The first one that is, let's identify the continents here. The continents that we see is starting from the down here. The first continent that we see is the continent of Australia. As we move up, we see the continent of Asia. Then as we go next, we see the continent of North America. And then as we go down, we see the continent of South America, which are present along the ring of fire. Okay, so that's the answer to our first question, identifying the continents around the ring of fire, which include Australia, Asia, North America, and South America. Let's move to the next one. And in the next one, we try to identify the names of countries that are found along this ring of fire. So it may not be possible for me to mark on the small screen the exact location of the country. So I'll be listing down the countries in the order of their occurrence for you all, which you can map down randomly in your textbook or note them down somewhere around there. Okay, so the list of countries that come along the line of this ring of fire includes the country of New Zealand. Okay, second one is the country of Papua New Guinea. I might be a little bit wrong with the pronunciation. Then the third country includes the region of Indonesia. The fourth country includes Philippines. The fifth country includes Japan. Fine. Then the sixth country is United States, the Alaska region. Then the seventh country includes the region of Canada. The eighth country that comes along this line is the region of United States, the coast, the western coast. Then the ninth country that comes along is the region of Mexico. The 10th country that is the part of this ring of fire is Guatemala. I might be wrong with my pronunciation, so please excuse me. Then the 11th country that is the part of this is the region of Ecuador. The 12th country that is the part of this ring of fire is the country of Peru. And the last country that is the part of this ring of fire is Chile. So these are the list of 13 countries that are found along the ring of fire around the Pacific region. So let's move with the next question of let's explore that has been given in your textbook. So the next explore activity is on the basis of a question, that is, does India have a risk of earthquake? Now to understand this, you have to go back to figure 2.3 to understand, do we have any kind of plate movement that is found along the boundaries of India in a country or no? Fine, so we'll explore the answer to this question. Before that, let's read a few pieces of information that has been given in your textbook. India has experienced some major earthquakes in the past, resulting in thousands of deaths. A large earthquake in a densely populated country like India can cause severe damage to life as well as environment also. So on the basis of the piece of information given and the picture shared here, with the picture that is shared over here is about a major earthquake that happened in the regions of Gujarat in the year of 2001. My simple answer to the question that begins this topic is yes, India definitely faces the risk of earthquakes within our country. Fine. Now, moving ahead, there are some questions that has been given down to us to identify. The question includes, can you find out which region is more vulnerable to earthquakes? Okay. Before that, let me give you a scientific answer to this question. Does India have a risk of earthquakes? For that, we have to move to the picture 2.3. Fine. Now we see that India is a part of Indo-Australian plate. Fine. Now, this Indo Australian plate was once upon a time the part of Africa. Over the period of time, for millions of years, this plate broke down and got separated, and a part of Indo Australian plate moved towards the Eurasian plate. So, we see that the Indian plate converged with the Eurasian plate. Okay, there was a convergent movement or a convergent boundary that formed between the Indian plate and the Eurasian plate. And whenever there is any kind of tectonic plate that happens between two tectonic plates, either in the form of conversion boundary or a divergent boundary, we usually find two types of activities taking place over there. Either there is earthquake or there is a volcanic activity. Now, as India is an example of a conversion boundary between the Eurasian plate and the Indian plate, definitely India faces earthquake risk here, especially in the zones that is marked in these areas. Let's find answers to more of the questions that has been asked in the activity which has been given to you. And the question that I am going to concentrate now is, can you find out which region is more vulnerable to earthquakes? So some of the answer to this question is, some of the regions in our country that are extremely vulnerable to earthquakes in our country is Himalayan region, which includes the states like Jammu and Kashmir, the Union Territory like Jammu and Kashmir, Jammu and Ladakh, then Himachal Pradesh, Uttarakhand, Sikkim, as well as Arunachal Pradesh. If we talk about the regions of Northeast India, I have already included one name in the risk areas along the Himalayan region. The rest of the states of Northeast India also face the earthquakes, which include Assam, Arunachal Pradesh, Manipur, Mizoram, Nagaland, Meghalaya, and Tripura. Then the Kutch region of Gujarat, certain parts of Bihar and North Bengal, as well as Andaman and Nicobar Island are the regions where we find the activities of earthquakes taking place more in these areas. Fine. Now, moving ahead with the next question that has been given here is, why do you think human lives are at risk? Okay, so what could be the reason why human lives are basically at more of risk in these areas? Fine. So one thing is, the states that we mention about, like the Union Territories of Jammu and Ladakh, Himachal Pradesh, Uttarakhand, Assam, Sikkim, Arunachal Pradesh, Manipur, Mizoram, Nagaland, Meghalaya, Tripura, Gujarat, parts of Bihar, North Bengal, Andaman and Nicobar Islands. All these areas are populated. So when human settlement is there, human lives is definitely at risk. There is collapse of buildings, there is collapse of bridges, roads, falling of debris causing injuries and death, landslides in hilly areas that occur because of earthquakes, fires due to damaged gas or electricity lines. And as these areas are, some of them are low populated, some of them are densely populated, especially in cities if we talk about, then human life is definitely at risk. Now, lack of earthquake resistant buildings in majority parts of India is one of the reasons why human life is always at risk in these areas. Fine. So this is about some information or some answer to the question on the activity Let's Explore, which has been given in your textbook. So moving ahead with some extra information that has been given to you in your textbook, which you're not supposed to miss out at all. So that has been given in the next page for all of you. So what is this extra information? Let's concentrate on that. In the early times too, earthquakes were known as bhukampa, meaning the shaking of the earth. In the Brihas Samhita, Varamihira dedicated a section to earthquakes, noting how changes in wind, rain, clouds, animal behavior, and planetary alignments could signal them. He attributed earthquakes to four element forces: Vayu, Agni, Indra, and Varuna.
each linked to specific constellations and regions. This reflects an early attempt to blend observation with cosmological reasoning and physical phenomenon in India. So now, is this concept of earthquakes and the volcanoes a new age tradition that has been developed? No. If you look into ancient India and certain books of ancient India, we see the presence of certain elements that we talk about today. What we call today as earthquakes was also observed by people years back by the name called as Bhukampa here. Okay, so a famous now Bhukampa here. Now we have a very famous text called as Brihat Samhita, which was written by a person called as Varaha Mihira. And this fellow or this person is a famous Indian astronomer, mathematician, and a scholar who lived during the 6th century. Okay, he is also considered as one of the Navaratnas or nine gems who lived in the kingdom of Vikramaditya's court. And he wrote this famous book, as I'm talking about, the Brihata Samhita, an encyclopedia on astronomy, geography, architecture, weather, earthquakes, and many other subjects. So it is not just the Englishmen or the foreign people who are so advanced. Actually, the ancient India and the people of ancient India were extremely advanced, who knew about all these geological processes that happened around them and studied those concepts and made notes about those concepts through different types of books that they had written. So what does bhukampa mean here? Bhu means earth and kampa means shaking. So in simple words, bhukampa here means what? The shaking of the earth. So what did Varamihira believe during those days? He observed that there are certain natural events that occur sometimes before earthquakes. So he said that earthquake is not a sudden activity that happens. Instead, he said that there are certain activities or natural events that happens before the occurrence of earthquakes. Like for example, there is change in wind, there is change in rain pattern, there is change in clouds pattern, there is change in animal behavior, there is change in planetary alignment. So these activities or these natural elements are the reason why some changes in them are the reason that signal that very soon an earthquake is definitely going to happen. So he also believed that the earthquakes are influenced by four elements, which includes Vayu. Vayu means wind, Agni means fire, Indra means rain or thunder, and Varuna means water. And he also believed that all of these are linked to specific constellations in different regions. So, what does this example reflect? It shows that these are certain early attempts where we see that people have observed the surroundings around them and they have tried to give cosmological reasoning and physical phenomenon attached to these activities in India. So we have not gained everything from the foreign people. We also had very good scholars who existed even in India during the time of ancient period. So how do we can relate this to modern scientific explanation? So today scientists know that earthquakes are not caused by these elements. They occur due to movement of tectonic plates and the sudden release of energy along the fault line. Varamihira's ideas are important because they show that ancient Indian scholars carefully observed nature and tried to explain the natural phenomena that were happening around them. So there are certain modern developments that we see in certain theories that were developed by ancient people, right? Like for example, Varamihira believed that it occurs because of change in fire, change in wind, and all other things. But we know that earthquakes are basically happening because of the movement of tectonic plates, right? But we can still establish a good connection. How could modern scientists do this? Because they had the ancient text through which they could refer and come down to a conclusion where they could prove certain theories wrong and certain theories to be right in existence. Moving ahead with the next, let's explore activity that has been given to you all here, and let's go to that. So the next explore activity is about a picture based question that has been given to us. Let's observe the picture first. So that is figure 2.6 that has been given to us, and this figure 2.6 shows deposition by volcanic eruption. So what is the figure 2.6 explaining? It's a photograph that shows us deposition made by volcanic eruption. I know the picture given is not that clear, but we can see certain debris and certain deposition that has been made by the volcanic eruption around the mountainous region. So let's understand what are certain questions which are asked on the topic over here, on the picture that has been given here. So the first question is, what do you think caused this situation? Now, what could be a reason behind a volcanic eruption? The situation or the deposition of certain debris here. So situation that they're talking about is that already a volcanic eruption has taken place and there is some debris deposition which has taken place in this areas, destroying the life and the livelihood over here. So they call this as a situation. What could be the reason behind such a situation? The reason is volcanic eruption that has taken place, and this volcanic eruption has released certain ash, gases and molten rock from inside the earth on the surface of the earth. Fine. So the second question is, what could the gray powder be? What could that gray powder be? So the gray powder is nothing but it is the volcanic ash, which is made up of tiny rock, minerals and volcanic gases. Okay, that's the answer to be given to the question. And the third question is, what does it tell us about the earth's internal forces? So this shows that earth has powerful internal forces. Heat and pressure inside the earth can force magma to rise to the surface, causing volcanic eruptions and changing the earth's surface. So in simple terms, the earth's internal force is extremely strong, and that keeps on changing because of the heat and pressure experienced in the molten magma region as well as the core region, giving rise to convection currents, because of which the magma rises up from inside the earth on the surface of the earth, creating either landforms or destruction of life and livelihood. Fine. So let's move to the next explore activity which has been given to all of us. Yeah, we have certain extra information that has been given to us in this activity, and the extra information is actually on something called as mud volcano. Now this is very much interesting topic to understand. Whenever we talk about volcanic activity, we see lava coming out, we see orange or yellow color fire coming out over there, but there is some interesting phenomenon that happens on the surface of earth where we see an occurrence of what we call it as mud volcano, which is also a very interesting phenomenon related to the natural events that occur on the earth's surface. So let's read a small piece of information which has been given over here. The mud volcano at Bartang Island is a rare natural wonder in India and a unique attraction to Andaman and Nicobar Islands. Unlikely the fiery volcanoes, here you will find mud bubbling out due to natural underground gases and pressure. Now, what is the major difference that we find between the fire volcanoes and the mud volcano? From the mud volcano, we see the mud moving out and there are some bubbles that come out of this. But when we talk about the fire volcanoes, the fire volcanoes are fiery, they are extremely fatal in nature, the orange color and the temperature is extremely very high. So let's understand more about this mud volcano that we find. So what is a mud volcano? A mud volcano is a natural feature where there are three elements that we find. One is mud, the second one is water, and the third one is gases are pushed out of the ground due to underground pressure. Unlikely ordinary volcanoes, they don't have lava or magma erupting out. Instead, it is a combination of mud, water, and gases, which generally tries to come out because of an underground pressure that comes within the earth's surface, pushing out the mud, the water, and the gases. That makes it look sticky and it appears like a volcanic eruption has been taking place, but it is not that fatal like we talk about the fire volcanoes over here. So where is one important location of this mud volcano? One of the most important location of the mud volcanoes is the Baratang Island, which is found in the Union Territory of India, which is called as the Andaman and Nicobar Island. And this is India's only active mud volcano, and because this is a very special natural event that occurs, it is one of the major tourist attraction in the regions of Andaman and Nicobar Island. So how is it formed? This is a very important thing to be understood. So natural gases build up beneath the earth's surface. Okay, let me show you it with a rough diagram. This is the earth's crust. This is the magma layer. Okay, now because of convection current and heat and all, there is some chemical reaction taking place. Sometimes gas gets trapped or gas is created between the magma and the crust layer, and this gas wants to come out. So the pressure forces the mud mixed with water to rise through the cracks. So there are certain cracks found on the earth's crust, and when pressure comes from within the regions of magma in the form of gases, that gas tries to move out through this mud and water. So when the gas is moving out, the mixture of mud and water also tries to come out over here. So the mud slowly, because the gas has the presence of the mud has the presence of water along with the gas. So when the gas is trying to come out, the mud starts bubbling out and forms a cone shaped mound, like you can see in this picture, and that is why we call it as mud volcano here. So what are certain special features of this mud volcano? These are not hot, instead they are cool. They don't have molten lava, instead they have mud, they have water, as well as they have the presence of gas. Now what is the color? They usually gray in color, or sometimes in certain regions, according to the type of soil found, they can be even brown in color. And when they try to come out, they usually form cones or small hill-like structure in the form of cones over here. Are they dangerous like the lava volcanoes? No, they are extremely less dangerous in comparison to the lava volcanoes here. If you have to understand the difference between the mud volcano or a lava volcano, the I have told you they're completely opposite to the lava volcano. We have studied the features of mud volcano, right? The opposite of the lava to the lava volcano, and your differentiations are basically done. But let me still give you a certain points of differentiation between mud volcano and lava volcano. Mud volcano erupts mud, water, and gas, but whereas lava volcano erupts lava, ashes, and gas. Mud volcano's temperature is very low, but lava volcano temperature is extremely high. Mud volcano's size is small cone. They are not big, but when we talk about lava volcano, they yield out large volcanic mountains. Mud volcanoes are usually harmless, but lava volcanoes are highly destructive. In mud volcano, magma doesn't reach the surface, but if we talk about lava volcano, magma definitely reaches the surface, leading to formation of new natural landforms on the earth's surface here. If I have to talk a few interesting topics about the Baratang mud volcano, as I have told you, it is the only active mud volcano found in India, where it helps the scientists to study underground gases and the internal flow processes that happens inside the earth's crust. And it is considered, like other phenomena that happens on the earth's surface, it is also considered as one of the unique geological attraction and an important tourist destination too. Yet another few more points if I have to tell you is, this is only one active mud volcano at the Baratang Island in Andaman and Nicobar Islands, which lies very close to the boundary of Indian plate and Burma plate, that is the Myanmar plate. Then this bubbling is mainly because we talked that mud volcano erupts mud, water, and gas. The gas that is found over here is the methane gas that is found in the underground, and this gas is trying to escape over here. So unlike the normal volcanoes, mud volcanoes do not produce lava or explosive erosions at all. So this is all about that extra information and extra let's explore activity, let's mapping activity which has been given to you in relation to the concept of theory of plate tectonics in your class 9 CBSE geography chapter, shaping of the earth's features, which has been given. So if this video was extremely helpful to you, then do not forget to like, share, and subscribe to my channel. and share my videos to your friends also, and help them also to understand the concept in a much better way. And note down these answers in your textbook for the let's explore activity, because these activities are not just given for showcasing the new textbook that has been developed, but these can be asked in your examination. So prepare well, share my videos to your friends, learn through my videos, visit my videos again and again, and keep preparing well. And if you have any doubts, like I've already always told you, put those doubts in the comment section. I'll be definitely replying to your doubts. So see you in my next videos. Bye everyone.
Have you ever wondered how huge mountains become smaller, how deep valleys are formed, or how caves and river deltas are created without humans building them? The answer to entire of all these questions lies in two amazing natural processes, weathering and erosion. Many students get confused between these two words, but don't worry, by the end of this video, you will never confuse them again. So let's explore the process of weathering and erosion with me in Let's Revise by Vidyashri Kadlibuddi. Weathering and erosion Weathering and erosion play a vital role in the development of landforms by continuously breaking down and reshaping the Earth's surface. Now, what does this actually mean? Okay, imagine you have a very big chocolate with you. First, you break it into small pieces and then you throw those pieces somewhere else. Nature does exactly the same thing with rocks. The Earth's surface is changing every single day, not because someone is digging it, but because natural forces are constantly working on it. And these two forces are weathering and erosion. Together, they create beautiful landforms like mountains, caves, valleys, as well as plains. So let's understand the clear difference between what we call it as weathering and erosion. Okay, so what is actually weathering? So weathering is a process of breaking down rocks into smaller pieces at same place without any movement. Now this is a very important point that you guys have to remember. What is actually weathering? Weathering is a process where the huge rocks breaks down into small pieces of rocks, but this happens only at the same place where the big rock is formed, and the smaller rocks which are formed out of it, they don't move anywhere. That is called as weathering. But in actual sense, what is erosion? Erosion is the process of wearing away and transporting rock materials from one place to another by natural agents. Now, what does this mean? This means that in erosion, the rock materials or whatever different types of materials are there, they are carried away from one place to another place with the help of natural agents. And these natural agents can be wind, water, glaciers, and even ocean or sea waters as well. So this is a clear-cut difference between weathering and erosion that you have to remember. Weathering is also breaking of rock, but erosion is transportation of rocks. Weathering occurs at the same place, but erosion makes the material to move from one place to another place. Agents are same. Fine. So this is a clear cut of differentiation that you have to remember between weathering as well as erosion, children. Anytime, anywhere, anybody else, remember this. Weathering is like hammering. Erosion is like transporting. These are two simple words that you have to remember. Fine. So moving ahead with the next part of the paragraph. Over long periods of time, weathering and erosion work together to wear down mountains, carve valleys, form plains, and create features such as caves, cliffs, rivers, river deltas, and gradually giving shape to diverse landscapes we see on Earth today. So, what does this mean? It means that creation of mountain or tearing down of mountain, carving of valleys, formation of plains, creation of features like caves, cliffs, and river deltas. All these changes don't happen overnight, not in 1 year, not even in 100 years. They take thousands or even millions of years. Think of nature as a very patient sculptor. Okay, just like an artist slowly carving a statue from stone. Nature slowly carves mountains into valleys, creates caves, build river deltas, and changes the landscape continuously. So this is a continuous process that keeps on occurring on the surface of the earth, and that all happens because of weathering and because of erosional activities. So let's understand this through a picture. So what do we see here? This picture represents what is the final things, or what are the activities done with the help of weathering as well as erosion. So togetherly, what do? They give shape to the earth's surface. Remember this simple funda. Okay, weathering breaks the rock and erosion moves the broken pieces, and togetherly they create new landforms. What are those new landforms? Like for example, now this is a mountain where rocks are broken into smaller pieces by wind, water, ice, and changes in temperature. So this broken pieces are eroded further. What are those? The erosion is nothing but transportation. Water, wind, ice, and gravity carry the broken rock particles away. So here the breaking is happening. Erosion is carrying these broken materials further away. Agents are same, but they are doing different activities. Remember this. Now, over the period of time, between the two mountains, valleys get created, formed when rivers and streams erode and the land over the time. Likewise, in the mountains, caves get formed. When does this get formed? It gets formed when water dissolves and wears off the material of the rocks in the mountains, leading to the formation of a hollow subject, which we call it as caves. Likewise, cliffs are formed. Cliffs are nothing but formed by erosion of rock by water, waves, or wind. Likewise, plains are they are formed by the deposition of sediments over a long period of time. Similarly, we have river deltas, and they are formed when rivers deposit sediments where they meet the sea or a lake. So how does all of these structures get formed? Because of weathering and because of erosional activities, and that leads to the creation of new landforms. And this process is a continuous process. We may not see this changes happening drastically, but it takes millions of years to create a new landform, and this process occurs slowly, but it is continuous in nature around us. Okay, so let's move to the next lines, where we in this video are going to understand one very important concept between the weathering and erosion, that is about the weathering. So in this entire video that we are going to study, we are going to discuss on the topic of weathering. Remember this. About the erosion, I'll be making yet another video. Fine. So let's move ahead with the concept of weathering. Weathering is a process through which rocks on the Earth's surface break down into smaller pieces due to various processes. What does this mean? It means that, let's understand this word itself. Let's break down what is the meaning of the word over here. Weathering. Now, among the word of weathering, let's break this down into two parts, weather and ing. Let's forget ing. Okay, let's understand the word here. Weathering comes from where? It comes from the word weather. And what is weather? Weather is nothing but change in atmospheric condition, right? So whenever changes in whenever there is changes in the atmospheric condition, we call it as change in weather. And whenever change in weather happens, it affects the rock. Okay, now how do you understand this concept in a simple way? Imagine dropping a biscuit. It breaks into smaller pieces. Similarly, huge rocks slowly break into smaller pieces. And when these big rocks break into smaller stones or smaller rocks, we call that process as weathering. And weathering happens because of change in atmospheric condition. This is something that you have to remember completely. Okay. See, I've shared a video picture with you over here. So what is weathering? Weathering is nothing but breaking down, but the particles don't move at all. And who all does the activity? Heat, water, wind, and living organisms all together break the rock. But does the broken material move? No, it doesn't. It stays in the same place there. So weathering is a process through which the rocks on the earth's surface break down into smaller pieces due to various processes. It does not involve movement of the broken material, only the breaking down. So weathering is what? Only breaking down. There is no movement. So how does weathering work? Remember this. Large rocks, cracks are formed, and those cracks lead to the formation into smaller pieces. Then those smaller pieces get broken furthermore into furthermore small rock particles. And that is how the weathering process generally takes place. Okay, so moving ahead with the previous topic here. Now we are going to understand the concept called as types of weathering. Okay, now we know what is weathering, but the way the rocks are broken, fine, the way the rocks are broken, on that basis, we generally identify three different types of weathering around us. They are called as physical weathering. Sorry, they're called as physical weathering, they're called as chemical weathering, and the third one is biological weathering. And in this next slides, we are going to understand about these different types of weatherings one by one. So let's understand what actually is physical weathering. Physical weathering in which rocks break into smaller pieces due to temperature changes. See, remember one thing, note, physical weathering is associated with change in temperatures. Fine. So think about a metal lid. In summer, it expands. In winter, it contracts. The same thing happens with rocks also. During the day, rocks become hot and expand, and at night, they cool and shrink. This happens again and again. And when this process continues for a very long period of time, eventually cracks start developing, and the rock finally breaks down. In okay, this is one way. Second way, in cold places, water enters the rock, it freezes. Frozen water expands, the crack becomes wider, and finally the rocks break apart. Similarly, strong winds carrying sand also slowly wear away rocks, and that togetherly is called as physical weathering. And in this, there is no chemical change that happens, there is change only in the size. So, as there is no physical change involved, we call it, sorry, as there is no chemical change involved, we call it as physical weathering over here. So, let's understand this process through a image. Okay. So when we talk about physical weathering, what is physical weathering? It is breaking down of rocks into smaller pieces. But here, who plays a dominant role? The dominant role is played by the temperature changes. And temperature changes, frost and wind, all of them are dependent on temperature changes. So the most important agent in physical weathering is the temperature experienced on the Earth's surface. So how does temperature change helps in breaking down the rocks? That is what we need to understand here. So during the day, what happens? Rocks heat up and expand. At night, they cool down and contract. So imagine a rubber band. Okay. Now, when the rubber band is new, it's compact in nature. You use it one day, you expand it, and then you again release it. You expand it and again you release it. Expand it and again you release it. Slowly on the rubber band, you notice some kind of tearing is happening on the rubber band. A similar process happens in rocks also, but here in the rubber band you're pulling it, but in the rocks the heat is playing the important role. So during the daytime, as we all absorb the sun's heat, similarly the rocks around us also absorbs the sun heat. When they absorb the sun heat, it becomes hot, and the particles in the rock move away from each other, and when they move away from each other, there is expansion that takes place. But at the same time, at night, the heat absorbed is lost, so the rock becomes cold. And when it becomes cold, all the particles come together and they contract over there. This repeated expansion and contraction in the rocks is the reason why the cracks develop, and slowly the cracks lead to the breaking down of the rocks into smaller pieces. You can see in the image, big rock, cracked rock, and then into smaller pieces of rock. That is called as physical weathering, which happens because of temperature. Similarly, we have another agent of physical weathering, which is called as frost. What is frost? Frozen water in between the rocks. Okay, water seeps into cracks in rocks. When the temperature drops, the water freezes and expands, widening the cracks. Repeated freezing and thawing break the rocks apart. Now, what is this thing? Now, see, in between the rock surfaces, at times in between the rock surfaces, water gets accumulated, and when the temperature is less, this water starts freezing, and when they start freezing, they occupy more space. At that time, they push the rocks away, and when the temperature increases, the frozen water converts into liquid, and when that converts into liquid, the expanded rock comes back to contraction again. So because of repeated freezing and thawing, what happens is cracks develop in the rock. So you can see water accumulation, freezing, then water melting and moving away, causing the rocks to break down here. Similarly, wind causes abrasion. Abrasion means the wind carries soil particles, and when these soil particles rub against a rock because of the pressure of the wind, what happens? Slowly, the parts of the rocks start cracking down and breaking into smaller pieces. So let's understand that. Strong winds carry tiny particles like sand and dust. These particles hit the rocks repeatedly, wearing them down and breaking them into pieces. So, this is the rock around which there is strong wind blowing, and this wind is carrying sand and dust. That sand and dust acts as a friction, does a friction on the surface. And due to that friction, the rock slowly starts breaking down into smaller pieces. So remember this, in physical weathering, there is only change in the size and shape of the rock. There is no change in the composition. There is no chemical change in the composition of the rock at all. So this is about all what we talk about is physical weathering. Moving ahead, we will study about chemical weathering. Now, this is yet another very important aspect. Let's understand what is chemical weathering. Chemical weathering in which minerals in rocks change because of reaction with water, air, or acids, leading to new substances. Now, this is very much important. In physical weathering, there is no change in the substance. The substance remains the same. Only the size and shape changes. But in chemical weathering, the substance also changes because there is reaction with either water, air, or acid. So, what we you can in simple words say there is a complete metamorphosis that takes place over here. Fine. So let's understand chemical weathering with the help of the picture study here. So what is chemical weathering? Chemical weathering is the process in which minerals in rocks change because of reaction with water, air, or acids. And the previous rock is now changed into a completely new substance. So how does chemical weathering work over here? Okay. So firstly, with water, minerals absorb water and swell, causing the rock to weaken and break. So, example of such rocks are clay minerals who swell up when they absorb the water, leading to the formation of cracks in the rocks here. Air, oxidation process. Oxygen in the air reacts with the minerals, especially with the iron, forming the rust iron oxide. So you can see certain reddish kind of deposition on certain rocks, which means that a rock is a composition of iron, and that rock is reacting with the air, which has the presence of oxygen in it. And the process of oxidation is taking place, due to which iron oxide is formed. So iron rich rocks develop rust and they start crumbling here. Similarly, acids. Weak acids like carbonic acid, especially in the rainwater, react with minerals, dissolving them. So, in certain rocks, you see certain holes, dissolved holes. That is because of their reaction with the rainwater, which has the presence of carbonic acid in it. So, example here is limestone dissolves in slightly acidic water, creating such cavities, which is an example that the rock has gone through a chemical weathering process over there. So what actually happens here? The mineral in the rocks react with water, air, or acids. These reactions change the minerals and form new substances, causing the rock to break. Understood? So what is the ultimate result? The ultimate result is the original minerals change into new substances and the rock breaks down over the period of time. So if this is the rock, because of water or because of air or because of acid, they start breaking down into new substances, and over the period of time their chemical composition completely changes. There's definitely change in size and shape, yes, but because they are either reacting with water or they're reacting with air or they're reacting with the acids present in the rainwater, what happens is a complete metamorphosis takes place. The entire chemical composition of the rock completely changes when it breaks down, and that is called as chemical weathering. Fine. So let's move ahead with the third most important weathering that happens here. The third most important weathering is which is caused by plants, animals, or microorganisms. For example, when plant root grows into cracks or rocks and splits them apart. Now here, when we talk about in terms of biological weathering, okay, it's very interesting how plants, animals, and microorganisms generally help in breaking down the rock. See, nature has tiny workers too. Look at a tree growing beside a rock. Its roots slowly enter tiny cracks. Every year, the root goes on becoming thicker and the crack becomes wider. Finally, the rock splits apart. Even ants, earthworms, and microorganisms contribute to breaking of rocks. So, when living organisms contribute in breaking of the rock, we call such type of weathering as what? Biological weathering. Okay, so let's understand biological weathering with the help of the image here. So, what is biological weathering? Weathering which is caused by plants, animals, or microorganisms. For example, when plant root grows into cracks of rocks and then splits them apart. Now you can see a image that I have put up over here. This is a rock. This is a rock, and a small plant is growing inside this rock, which has developed roots. And these roots have the capacity, they want to grow, so they have the capacity of creating cracks in the rocks. And when that crack happens, it never closes, and slowly the rock breaks down into smaller portions over there. So I have put four combinations of how biological weathering works. See, the first one is plants. Root grows into cracks in rocks. As they grow larger, they push against the rock and cause it to break apart. You can see in this image, as the root is growing, the crack is widening, and finally, because of the excessive growth of root, the cracks in the rocks becomes more huge, and finally the rock breaks down. Similarly, the second one is animals. Animals, especially like rodents, ants, earthworms, all of them burrow into rocks and soil. And when they try to burrow, they widen the cracks and breaking the rocks into smaller pieces. Likewise, we have microorganisms. Fine. So microorganisms like bacteria, fungi, lichens, they produce acids that react with the minerals in rocks and weaken them, causing them to crumble. You might have seen many rocks with patches like this growing on them. Either they can be bacteria, they can be fungi, or they can be lichens, or they can be algae. Over the period of time, they start releasing certain kind of acids on the rock. These acids help in breaking the minerals which are present in the rock. The rock becomes weak and slowly it crumbles into smaller pieces. Likewise, we have a combination type of weathering that happens in biological weathering, where living things often work together to break down rocks more quickly and turn them into soil, especially if there is growth of fungi, bacteria along with the roots in them. So in such cases, the process is quite faster, where the rock is broken down into soil particles. Fine. So what is the ultimate result of this? Rocks break into smaller pieces and eventually turn into soil, supporting new life on them. So this is very interesting topic that about the weathering. So what do we study so far? What is weathering? What are the agents of weathering? And what are different types of weathering? That is what we have seen so far. Okay. Before we put it down, weathering plays an important role in shaping the Earth's surface and forming soil. That is what you have to remember. Have you ever wondered where soil comes from? Soil doesn't appear suddenly. It forms when rocks keep breaking into smaller particles, and over the time, these particles mix with dead plants, animals, and organic matter, and that is how they become fertile soil. Without weathering, there could be very little soil, and without soil, plants could never ever grow. So, that is my explanation on the concept of weathering for this video. And if you liked my way of explanation, then do remember to like, share, comment, and subscribe to my videos. Share it with your friends, help them also to prepare with easy explanation that I'm giving you all. Um, Keep returning to my videos. I'll be posting videos to you. If you have any doubts, put them in the comment section. I'll be definitely replying to all the comments that you have been putting in the comment section. Until we meet next time, bye bye everyone. Hello everyone. Welcome back to Let's Revise by Vidyashri Kadlibuddi. In my previous video, we have been discussing about the process of weathering and erosion, in which I have already discussed the concept of weathering. And in today's video, and in this video, we are going to talk about the second process that is called as erosion. Okay, so let's dive deep into this concept of what is actually erosion, what are the types of erosion, and how erosion affects the human life around it. So, erosion is the process by which soil, rocks, and other surface materials are worn away and carried from one place to another by natural agents like water, wind, ice, or waves. Now, what does this mean? It means that in relation to weathering, okay, this is a second process. The first process in terms of breaking of rocks is always weathering, and after weathering is the work of the erosion that you have to remember. So weathering is the first process, whereas erosion is the second process after the weathering process happens. So what does erosion do? Erosion is a process in which soil, rocks, and other materials are broken and taken away from one place to another place with the help of water, wind, or waves. Now, how do you put this into simple thing? So remember, imagine erosion like sweeping your room, or and weathering like breaking a glass. Okay. Now, sweeping the broken pieces away is erosion. And that's the easiest way to remember. In weathering, you just do the breaking, but in erosion, you you sweep the broken pieces of glass and take them from one place, that is from your room, to another place, that is into dustbin. Likewise, what does erosion do is erosion carries soil, rocks, and other materials from one place to another place with the help of agents like water, wind, ice, or waves. And that process is generally called as weathering over here. So you can call this natural agents like water, wind, ice, or waves as transporting vehicles. They are the agents which pick up the broken rocks and transport them from one place to another place. Okay, so unlike weathering that only breaks down rocks, erosion involves movement of the broken material. This is very much important point to remember. One of the key difference between weathering and erosion is what weathering means to break and erosion means break plus move. If movement happens, it is erosion. If movement doesn't happen, then it is called as weathering. Fine. So let's understand this concept with the help of a image. Now, this is the image about the erosion that I have put up. Remember the tagline of erosion? The tagline of erosion is breaking down and moving away. So what is erosion, which I've already explained you, which means that carrying away the broken materials from one place to another place with the help of water, wind, ice, or waves. That is called as weathering over here. So how does erosion works? Remember this process. Rocks break down by weathering. Erosion picks up the broken pieces. Now here, to show the erosion, they have shown you the water moving. The materials are transported with the help of water, and the materials are deposited in a new location with the help of water. So, this is how the process of erosion actually works. So, what are the vehicles or the agents of erosion? Water, wind, glaciers, as well as waves. Now, because of erosion, what are the new landforms created? Definitely, yes. Remember, weathering and erosion together create new types of landforms. So erosion creates valleys, cliffs, beaches, as well as deltas too. So weathering and erosion together are responsible for creation of new types of landforms around them. So this is about the very simple definition and meaning of the concept called as erosion. Moving ahead, in terms of erosion, we are going to study about different types of erosion. And when we talk about erosions, we have several other types of erosion. Now, how do you understand that there are different types of erosion and how many types are there? Remember, the natural agents of weather erosion are water, wind, ice, and waves. So if erosion happens with the help of water, we call it as water erosion. If erosion happens with the help of wind, we call it as wind erosion. If erosion happens with the help of ice, we call it as glacial erosion. And if erosion happens with the help of waves, then we call it as coastal erosion. And we are going to study about these erosions one by one and how do they occur and what is the impact of them. Fine. So there are several types of erosion like I discussed, and the first one that we are going to study is about water erosion, which is caused by rivers, rain, and ocean waves. Okay, ocean also has the presence of water, so ocean also comes under this. So let's understand the concept of water erosion. So what is actually water erosion? Water erosion is wearing away, that is breaking down and transport of soil, rocks and other surface materials with the help of what? Moving water. And what all waters move? River, rain and sea water keeps on moving. Fine. Or sea waves and ocean waves, they are motion in nature. That's why we call them as moving water. So what are the agents of water erosion? Rivers, rain, and ocean waves are the most important agents of the water erosion here. So, how does water erosion works? This is very much important for us to understand. Water breaks the rock and soil, that is weathering. Water picks up the broken pieces, and water transports those sediments. And the sediments are deposited in a new location when the speed of the water actually decreases. So, what are the landforms that get created because of water erosion? Valleys, canyons, meanders, deltas, waterfalls, and sea cliffs and arches. So, this is the entire story about the water erosion. You don't need to write this entire story. This is some extra information that I am giving you for your knowledge. Fine. So moving ahead with the next type of erosion, the next type of erosion that we will study is wind erosion, which is common in dry and sandy areas. So especially in desert areas, we usually experience the wind erosion here. Imagine a desert. Strong winds carry tiny sand particles. These particles hit the rocks like sandpaper. Gradually, the rock becomes smooth or oddly shaped. So let's understand the concept of wind erosion with the help of an image. Now, wind erosion is highly found in the desert regions. Like I have shown you the image here, wind erosions are highly found in the desert regions. Remember that. Okay, so whenever the wind breaks the rock and carries the broken rock materials from one place to another place and deposits it in another place, we call it as wind erosion has happened. So where is it very common? It's commonly found in dry and sandy areas. Fine. Now, why in dry and sandy areas wind carries there? Because you can see there are less vegetation which are found over here. Whenever there is less vegetation, the hold on the soil is also very less. So what are the reasons? What are the agents that cause the wind erosion? The first one is strong air which is moving. Second one is dry and loose soil. And third one is little vegetation. All together basically do this. Fine. Now, how does wind erosion work? Wind blows across dry, loose soil, and when it blows, it picks up some small particles of soil and sand. The particles are transported over the long distances, and then these particles are deposited in a new location when the speed of the wind decreases and calms down. So, what are the different types of landforms that are created because of the wind erosion here? The first and foremost one is mushroom rocks. Second one is yardangs. Yardangs are nothing but ridges. You can see these ridges, soft rocks. Then sand dunes, desert pavements, and losses deposits. Fine dust is deposited forming a fertile soil around the vegetation found in the desert regions. Okay. This is all about the wind erosion. Moving ahead, we are going to study about the third one, which is called as glacial erosion, where moving ice scrapes and carries the rock. Now see, glaciers on the Himalayan mountains are also the reason for erosion. How? Let's understand that with the help of an image here. Okay, so what is glacial erosion? Remember, whenever we talk about glacial erosion, you have to remember that these glacier images are these glaciers are the reason. Glaciers are the ice sheets present on the mountains, and whenever these glaciers melt, they cause erosion. Okay, so let's understand the definition.
Glacial erosion is the wearing away and transport of rocks and soil by moving ice called as glaciers. As glaciers move, they scrape, grind and carry rocks across the land. So how does glacial erosion works? A nice interesting picture has been given. Now this, in the first picture you can see snow falls and compacts into ice. So on the surface of the land here, snow has been fallen and layers of snow has now turned into ice there. Now, as the temperature decreases, or sorry, as the temperature increases, the glacier slowly starts melting and starts to move down the hill. Now, as they start to move down the hill, what happens is the glacier starts taking away the rock materials which is present below it. And on its journey, it grinds and plucks the rocks from the ground, and the ice carries the rocks and drops them in new location, usually at the pyramid zone of the mountains. Okay, so the rocks from the higher elevation of the mountains comes and settle down in these regions. They might get further carried away to plain areas also. So what are the agents of glacier erosion? Only one, the glaciers themselves, otherwise nothing else. How do you identify that a particular mountain has gone through a glacial erosion or no? You find three types of structures. One is you find smooth and polished rock. Otherwise, you might find certain small scratches on the surfaces of the rock, or in that area, you might find the presence of U-shaped valleys between the rocks, between the mountains. So, what are the different types of landforms that get created because of glacial erosion? So, the different types of landforms include U-shaped valleys, arteries, horns, creeks, zones, and drumlins. These are the different types of them. Out of them, just remember only one, which is called as the U-shaped valleys, which is more than enough for you. And one of the example of glacial erosion that happens in our country is the Himalayan regions. Because of the erosion that has happened in the Himalayan regions, today we have the vast plain present in our country. So that is about the glacial erosion that I wanted to discuss with you guys. Moving ahead with the last type of erosion that we are going to talk, which is nothing but coastal erosion, where sea waves wear away the land along the shore. Now, this is very much important for all of us to understand. Okay, so let's understand it through a picture. A coastal erosion means what? Erosion that happens because of sea waves is called as coastal erosion. So now you can see in this picture, this is the coastal land. Now the sea waves hit these land or the rocks with great force, and that force breaks down the rocks, leading to erosion over them. So let's understand the definition. Coastal erosion is the process where sea waves wear away the land along the shore. They break the land along the line of the shore. So that includes waves, tides, and currents, which help in breaking the rocks and cliffs and remove the sediments and transport them to other places. So how does coastal erosion work? Let's understand that. Waves attack the shore with force. You can see here how forcefully the wave is coming on the land surface. And when this happens, the rocks break. And those broken pieces are carried by the wave. And those broken pieces are deposited in some other place as the speed of the wave or the tide decreases. And that's how coastal erosion happens. Fine. So what are the different types of landforms created by the coastal erosion? It includes sea cliffs, sea caves, sea arches, sea stacks, and wave cut platforms. Okay. So this is about the coastal erosion. Remember, whatever type of erosion it is, whether it is water erosion, wind erosion, glacier erosion, or coastal erosion, erosion shapes different types of landforms and can create and destroy features on the earth's surface. Now that is one important feature of erosion. It has positive impact followed by negative impact also. The positive impact is it creates landforms and gives shape to the landforms, but at the same time the negative impact of erosion is it destroys certain beautiful features of the earth's surface. Fine. So that's about erosion and different types of erosion. Yet another most important topic that you have to study in terms of erosion is this question.
how erosion affects human communities. Now, do human beings get affected because of the erosional activities? This is the important question that we understand here. Like I told you previously, erosion has positive impact also and negative impact also. The positive impact is it gives shapes to the landforms, but at the same time, this creates or this destroys the a lot of natural landforms and creates a lot of negative impact on the human beings also. Okay, so what are those effects? Let's understand them. So erosion affects many human occupations by changing the land and soil on which people depend on. So what does erosion do? Erosion affects human occupation. See, basically, the whatever type of job we do, all our jobs are dependent on the type of land we are living in and the type of soil which is available in that area, right? But because of erosion, what happens? There is change in the land, there is change in the soil, and when land and soil changes over the period of time, human occupations gets affected completely because we are totally dependent on the type of land and the type of soil which is available to us. So there are different type of people who are affected because of the erosional activities. Let's understand them one by one. So the first and the foremost people who get affected because of erosional activities are farmers. For farmers, erosion removes the fertile topsoil needed for crop growth, leading to lower yields. Okay, this is the first community. Second community is for those living near rivers and coast, erosion can wash away land, houses, and roads, causing damage and loss of property. People settled around rivers and coast. Third community is in construction and mining. Erosion destabilizes land, posing safety risk. Okay. Third one. Fourth one, even industries like tourism and fishing. Tourism is four, and fishing is six. Suffer since beaches, rivers, and fertile lands may be destroyed. So this shows that erosion not only shapes the earth's surface but also directly affects the human labor as well as livelihood. So let's understand each of these human communities one by one and try to understand what is the impact that happens on them because of the erosional activities. Okay, so the first community of human beings that we are studying would be the farmers. How erosion affects the farmers over here. So what does erosion do? Erosion basically does what? It removes the fertile topsoil that farmers need to grow crops, leading to lower yields and income. When we study about the soil profile, we know that among the four different layers of the soil, the topmost layer of the soil is extremely important because of its fertile nature. But because of wind or because of water, what happens is this topmost layer of the soil gets carried away, and when the topsoil is gone, the fertility of the soil decreases and the farmer is not able to get good yield out of it. And because of this, what happens? The income is less. So how does this happen? Rain and wind wash away the topsoil, nutrients and organic material get lost, soil becomes less fertile, crops grow poorly. When crops are growing poorly, income of the farmer also decreases. So what is the impact on the farmer? There's very bad impact on the farmer that happens here. You have to remember that. Loss of fertile topsoil, lower productivity, reduced income, and long term damage of the land over here. So, we have to protect the soil from erosion and protect the farmer's crop income and our future also. Likewise, let's understand the next community. The next community is the people living along the rivers, along the sides of the river. So what happens here is river erosion wears away the river banks because of heavy amount of water or high flow of water. The river banks are washed away, and we know that human civilization or human settlement has always been along the banks of river because of the water available there, right? Now they have built their houses, there are roads, there are bridges, all of them get damaged and lost. And because of this, what who is highly affected? People, because they lose their home, they lose their property and be forced to move from that place to another place. So fast flowing rivers erode the banks, soil is removed, homes and properties are basically lost. So who is mostly impacted here? The people. And what is the impact on people? They lose their home, they have to leave that place and move to new area, they lose their jobs, then there is damage to the infrastructure, and because of that economic development again comes down. So what are we supposed to do? We are supposed to protect our river banks. When we protect our river banks, it helps in saving lives, homes, as well as property too. But how can it be done? Think about this and put the answer in the comment section for me, guys. So moving ahead about the next community, the next community is the people living near the coastal regions. So what happens here is waves and currents wash the shore away. Again, lands, homes are built, they get damaged. Shoreline retreats, making the land unsafe and unstable. And the problems that they face are again the same. They lose their home, they have to leave the place, they lose their economic activities, then there is damage to infrastructure, and definitely there is economic loss. So we are supposed to protect the coast, which helps in protecting the lives and livelihoods for tomorrow. So there is huge amount of risk in staying next to the coastal lines as well. Moving ahead to the next community that gets affected is the construction and mining activity. So when the soil and rock are eroded, it causes damage, delay works, increases cost, and puts life and investment at risk. In terms of construction and mining also, let's understand in terms of construction first. So what happens in terms of construction? Erosion makes the land unstable, damaging buildings, roads, and foundations. So your cost of building also increases. So what happens here? Rain washes away topsoil, weakens the ground. Foundations become unstable, structure may crack very soon, and roads and slopes get damaged and become unsafe. What is the impact? Construction gets delayed, there is instability, and there is extreme amount of repair and maintenance cost goes on increasing. And the most important is, if the building starts developing crack, then there is risk of accident and loss of life also. Similarly, when we talk about the mining effects, we have to remember this. Because of erosion, soil and rock are removed, causing slope failure, land instability, and safety risk. What happens over here is, because of rain, erosion exposes soil and slopes in mining areas. Slopes become weak and they may collapse suddenly. Sediment is carried to river and water bodies, causing pollution. So what is the impact of this? Mining operations slow down or they stop. Loss of machinery and materials, cost increases of production, workers and nearby communities face health and safety risk. So, a simple activity of erosion has a great damage to the human community dependent on them. Now, how is the tourism industry? How is the tourism industry affected because of erosional activities? Now, this you have to understand. Now, one of the major tourist attractions are beaches. Okay. Now, when waves and currents wash off the beaches away, land is lost, natural attractions are damaged, tourist facilities like hotels, roads, and walkways get damaged, beaches become smaller and less attractive. And what is the impact on tourism? Fewer tourists, loss of income, jobs are at risk, communities face higher cost. So, what is the impact on the people? As if we have discussed, impact on the people is that they lose their job, income gets reduced, displacement, higher cost of living, and loss of beautiful nature which is present around them. Likewise, when we talk about yet another important community is nothing but the fishing community. Now we know that people living along the coastal line, their most important economic activity is fishing. And because of erosional activity, the fishing community also gets heavily uh, impacted because of erosion. The same process. Erosion washes away the coast region, land and fishing grounds are lost. Now you can see in this image. This is the coastal region. Because of erosional activity, this area is broken out. So fishing grounds are basically lost. Fishing areas become shallow or they completely disappear. So homes, boats, fishing infrastructure, everything gets damaged and destroyed. And what is the impact of this on fishing community? The amount of fish that they catch is less. If you're catching less fish, your income also decreases, and then it becomes hard to support even basic necessity of life, due to which stress and uncertainty happens, and you have to leave the place and go in search of job into other places. And how does this impact the entire other people? As we have discussed, poverty and hunger, migration, loss of property, and uncertain future, where people don't know what has to be done over there. So this is about the list of people or the communities of human beings that get impacted because of erosional activities. So more than benefits, erosion usually brings a lot of damages over here. So how can you conserve the soil? How can you reduce the erosion activities? We are going to study it in 3 pointers over here. The first one is called as contouring, second one is bunding, and third one is called as terracing. These are some highly suggested methods and adopted methods for conservation of soil from erosion completely here. So let's understand each of them one by one. First one is contouring. Contouring means what? The other name for contouring is continuous contour trenches along the contour lines. So what are these? Let's understand them. Trenches dug along contour lines slow down, hold and infiltrate rainwater, preventing soil erosion and recharging groundwater. Now, what is contouring? Contouring is if you are a person who lives on hilly areas, low hilly areas, okay, and you're practicing farming. Now, you cannot plow the land along the direction of the mountain, not from up and down or up or from down and up. If you do that, you are creating a way for the soil to get eroded, right? You're creating the way for erosion over here. So how are you going to do plowing in these areas? So in those areas, in these hilly areas, the plowing has to be done along a conical shape of the hills so that the speed of the water decreases. But one of the new method adopted today for conservation or for reduction of soil erosion in hilly areas is called as continuous counter trenches, which means you are plowing along the lines of the mountain, but along those lines, you're creating some trenches, some kind of digging. You're doing some kind of digging over here, and this digging that you have done, a kind of a gutter shape that you're doing, that is very much important because when the water flows from up the hill to the low the hill, the water gets trapped into these dug trenches and the water gets absorbed by the hill over there. Infiltration of rainwater happens into the ground, recharging groundwater. So here you have two benefits. One, it helps in conservation of water and recharging the groundwater. Second, it helps in reduction of soil erosion also. Similarly, we have yet another important what we call it as, yeah, we have yet another important method of soil reduction of soil erosion, that is called as bunding. Bunding is nothing but earth bunds built along the contour lines. Now here in CCT, you are digging the ground, creating a hollow structure for the water to be absorbed. But in the bunding one, what you're doing is you are creating a elevated embankments along the counter lines to slow down the surface runoff, which will help in reduction of soil and increase in water infiltration and soil moisture also. Okay. Now see what are you doing? This is also practiced in hilly areas only. In countering, you are trying to dig the land for absorption of water. But here you're not digging the land. Instead, you're creating a table-like structure. You can see here, you're creating a table-like structure. And when the water flows from one surface to the another surface, its speed decreases and it settles down on this bund. And as it settles down on the bund, what happens is soil erosion decreases, the water is settled, so the land also absorbs the soil and keeps the land also absorbs the water and keeps the soil in moisture condition. So what are the benefits out of this? One is it slows down the runoff, reduces soil erosion, increases water infiltration, and increases soil moisture, where the process of irrigation is generally reduced. What is the impact? Conserve soil nutrition, improves crop growth, help in crop resilience, and supports better livelihoods. Similarly, the third most impactful method of reduction of erosion is terracing, or which is popularly known among you guys as terrace farming, and it's also called as step farming in some textbooks too.
So what is terracing? Terracing is creating level or gently sloping steps on a hillside to slow down rainwater and prevent soil erosion. You can see the steps that are created. Now this is completely different from bunding. In bunding, you're not creating proper steps. You're just preventing the water. They are small steps there. But here you can see proper steps being constructed. What is the benefit here? When steps are created on a hillside, it reduces the speed of the rainwater, helps in preventing soil erosion, okay, and helps in retaining soil moisture along with groundwater too. So, what are the benefits of terrace farming? Slows down rainwater, prevents soil erosion, retains soil and water, creates level land for farming. And what is the impact? Increases the arable land. We usually know that in mountainous region, agricultural land are very less. But if hills are converted into terrace farming structures, then the land used for cultivation also increases. Crop yield is generally very high, better income and sustainable land use for future generation as well. So these are small steps that can be adopted in the present days for better future for ourselves and for the future generations as well. So these are some methods of soil conservation discussed in your textbooks, which include countering, bunding, as well as terracing. There are many other methods like afforestation, then planting of trees in the deserts, and all other things. And then we also have what we call it as shelter belts, where the trees are planted along the sides or the edges of the farms over there. All these are certain methods that can be adopted for erosional activities. But what erosions happen in due to glaciers, they cannot be prevented, and that's a natural phenomenon because of which the fertile soil comes to the plain lands and all. So these are some methods that can be adopted to reduce soil erosion at a much greater extent. Okay. So here is one of the most important golden takeaway from today's video. Even if you're still confused, even after the entire explanation of the topic of erosion and weathering, remember one thing: weathering is like nature's hammer, which is used for breaking the rock, and erosion is like nature's transporter, which is used for carrying those broken rocks away. But both together help in creating beautiful landforms that we are seeing today around us. And with this, if you found the my explanation easy and interesting, then don't forget to like, share, and subscribe to Let's Revise by Vidyashri Kadlibuddi. Learning becomes simple when we understand the concept. I am not here to make you memorize the concepts. I'm here to make you understand the concept. If you have any doubt on the topic of erosion so far, put them in the comment section and I'll be definitely replying to all your comments. See you in my next video. Bye everyone. Hello everyone. As we finish the topic of process of weathering and erosion, it's now time to solve the activities designed by the CBSE on this topic for you all. So without wasting much of our time, let's go to the first topic of activity, which is called as Let's Explore. And the question that is asked over here is: observe the photographs, figure 2.9, and also note the types of erosion, and also answer how are farmers affected by the erosion due to wind and water. So we are supposed to observe the figure 2.9 and identify what type of erosion they are, and also try to understand how farmers get affected because of erosion that is caused by water as well as wind. So let's explore and try to see what is figure 2.9 trying to depict here. Fine. So the answer to the question, after observing figure 2.9, we can see that there are two images which are given, image A and image B. Image A is erosion caused by water, okay, and image B is erosion caused by wind. Okay, now let's try to understand how erosion caused by wind and erosion caused by water actually affects the farmer over here. First, let me talk about how erosion caused by water affects the farmer. First thing, fertile topsoil is washed away. Second, crop production decreases because the topsoil is lost, so nutrients are gone. Then, due to this, cultivation becomes difficult
and farmers have to spend more money on fertilizers and soil conservation. And during heavy rains, crops may also be destroyed. As farmers are spending more money on fertilizers, their income actually decreases. This is this is a larger amount of impact that we see on farmers because of water erosion. Let's understand how wind erosion impacts or affects the farmer over here. So fertile soil is blown away. Crops may get buried under sand. Young plants can dry up due to loss of moisture. Seed germination becomes difficult. And ultimately, agricultural productivity decreases, especially in dry and desert regions. Okay, so this is about the first activity mentioned, and let's explore according to figure 2.9. Moving ahead to understand about the extra information that has been given in your textbook, that stresses out that we are not supposed to miss out this extra information. So let's see what is this extra information that has been given in the textbook. Okay. So the Sindhu Saraswati civilization employed sophisticated techniques, including contouring, bunding, terracing, dams, and canals for water management. This is very much important for us to understand. Our ancestors who lived thousands of years ago basically had ideas about water conservation and soil conservation and all, and they had the practices like contouring, bunding, and terracing, creating of dams for and canals for better water management systems. Let's understand what actually is contouring. Contouring is nothing but, suppose this is a hill, you want to cultivate crops on this land. You cannot plow the land up and down, so instead of that, on this hill, you're supposed to plow it along the conical shape of the hill over here. Such a plowing method is called as contouring method over here. Right? Now, how does this help? It slows down the rainwater, prevents the soil from being washed away, increases water infiltration into the soil. Along with that, it recharges the groundwater also. Now, this practice is still commonly seen in India, especially in hilly and slopey areas of Himalayas as well as northeastern India, northeastern part of our country too. Likewise, bunding is also yet another important strategy used by our ancestors for water conservation and soil reduction of soil erosion. So, what is the bund? It's a embankment, a kind of a structure created across the fields, a table-like structure created across the field. Now, this is usually again for the same processes to prevent the soil erosion and to stop the rainwater from being flown away, where it conserves the moisture and improves the crop growth also. Is this practice still seen in our country? Yes. In places like Maharashtra, Karnataka, Telangana, Rajasthan, and other semi-arid regions, we still find the practice of bunding. Likewise, we also have the practice of terracing, where we cut the mountains into the slopes of flat steppe like fields. The, the, the intention is the same: preventing soil erosion, making farming possible on the hills, conserving water, and reducing the speed of rainwater so that groundwater gets recharged over here. And this practice is again seen in hilly areas like the Himalayan mountains, like Himachal Pradesh, Uttarakhand, Sikkim, Meghalaya, as well as Nagaland too. The other important one is dams. They practiced, we still continue it. So, what are basically dams? They are small restrictions or barriers that are built across the streams or seasonal rivers. Now, what is the importance of constructing a dam? First and foremost thing is to store water for irrigation, for recharging groundwater, and to prevent soil erosion that happens because of the water by reducing the speed of the flowing water. Do we have dams in the present days? Yes, definitely. Not smaller ones, but huge dams which are used for multiple purposes. Okay. And then canals. Canals are again water diverting channels which are being created for storing water and for supplying the water in necessary conditions. Okay. Likewise, now this concept of using these methods is not something that is modern ideas introduced to us. They existed in ancient time. Like for example, multiple Sanskrit texts documents these practices, including the Vedas, the Krishi Prasahara, Kautilya's Arthashastra, and specialized treatises like Vriksha Ayurveda. These are the books where these practices have been documented. So we do have evidences to prove that all these methods are not modernized ideas, they are ancient ideas created by our ancestors for all the conservation of soil and conservation of water and all. Furthermore, the Arthashastra contains detailed guidelines on land assessment and categorization based on fertility and productivity also. See how clever and how smart our ancestors were. We talk about land assessments today, but this land assessment was basically done centuries ago, especially in Kautilya's Arthashastra book. It has proper guidelines on how you have to do land assessment and how you're supposed to categorize them into different categories according to its fertility and productivity. So these are not new concepts that have been introduced to us. They existed and we have gained inspiration from the existing information through these ancient texts that has been documented and maintained very well. Likewise, if we talk about one important practice that is seen in Nagaland, we have a system called as Zabo system. Okay. Now, what is this Zabo system? Let's understand in detail. The Zabo system in Nagaland represents an integrated farming approach using earthen bunds on hill slopes for soil and water conservation. So, what is Zabo system? It's a farming system on the hills. And here, with the help of the farming system on the hills, there are two intentions which are achieved over here. The first one is soil conservation and the other one is water conservation. So check dams were constructed across small streams to reduce water velocity, to prevent soil erosion and allow sediment deposition. These structures were designed to slow down water flow and enhance groundwater recharge. See, what are these Jabo system that we talk about? The Jabo system is a farming system where it basically means to impound water. Impound water is nothing but to stop the water from flowing so that you have water collected. It is stored in the ponds and soil is protected, and this soil is used for cultivation and water is conserved. It is used for multiple other purposes also. So in simple terms, Zabo system means impounding the water over here, which is generally practiced in the regions of what we call it as the areas of Nagaland. So, one simple way to remember the concept of soil and water conservation practiced even today and by our ancestors is to remember them in simple condition called as CBT. That is, C stands for contouring, B stands for bunding, and T stands for terracing. And purpose of all the three is the same: to conserve soil and water and reduce the erosion. So, if this explanation by me made you understand the concept easy, then do not forget to like, share, and subscribe to my channel and comment any doubts that you have, to which I'll be definitely replying. So see you in my next video. Bye everyone. Have you ever wondered who built the Grand Canyon, or who created the beaches, or how huge mountains have slowly become into plains? Was it humans? No. Nature has been doing this incredible work for millions of years. Today, we are going to discover the powerful natural forces called as agents of gradation that are constantly changing the Earth's surface. And don't skip till the end, because we will also see how these landforms shape the history of great civilizations like India. So let's begin. Agents of gradations are natural forces that wear down, transport, and deposit materials on Earth's surface, helping to level or smooth it over the time. First, let's understand the meaning of the word agents of gradation. Fine. So, agents here mean forces, And these forces are doing some work here. And second one is the meaning of the word gradation. Gradation means making the earth surface more level or even. So in together sense, agents of gradation means forces on the earth that are making the earth's surface more level or even. And these forces are doing three types of job over here. And what are those three types of job? The first job is to wear down, which is called as erosion, which is nothing but breaking down of materials. Second job is transport or transportation, which means that whatever eroded material or the broken pieces are there, they are carried from one place to another place. And the third job is deposition, which is called as deposit materials, which is nothing but dropping or settling the eroded materials from one place to another place is basically called as deposition or deposit of materials. Now, what is the benefit of all of these things? It is helping the earth's surface. How? It is helping the earth's surface to become level or smooth over the time. And this process doesn't just happen within few days or few months. It takes millions of years for these three processes to slowly make high mountains lower and lower areas into higher mountains and all. Fine. So the main agents of gradation are running water, glacier, wind, waves, and groundwater. So when we look into the agents, which are also called as the forces that help in leveling up the ground or making it smooth, there are in total 5 elements which we are going to talk about, or 5 important forces. The first force is running water, second one is glacier, third one is wind, fourth one is waves, which we call them as sea waves also, and then we call them, and the fifth one is groundwater. Each of these changes the earth's surface in a very different way. So let's understand each one by one. Okay. So running water erodes rock soils to form valleys and plains. Glaciers scrape and carry huge amount of materials carving U-shaped valleys. Wind shapes desert by eroding and depositing sand. Sea waves erode coastlines to form cliffs and beaches and bays. Groundwater dissolves rocks such as limestone, creating caves and sinkholes. Together, these agents are continuously modifying the landforms, lowering high areas and filling up the low areas. Let's understand these different types of agents of gradation one by one with the help of pictures that I have taken out for you guys. So the first agent of gradation that we are going to talk about is the running water. Now, what does running water do? Running water erodes the rocks and soils, and what does it form by doing that? It forms the valleys and plains. So let's understand this in a very simple way. Running water means rivers or stream. Now, as water flows, it slowly cuts through rocks and soil. And during this process, they form deep valleys in a hilly area. And whenever rivers reach flatter land, they deposit the soil and create plain, fertile lands, which are excellent for farming. So let's understand this very important topic through the image that I have put up for you guys. So running water with means what? Rivers and streams. And rivers and streams usually come from mountainous regions. And in the mountainous regions, when they flow from an higher region, what they do is they do the erosion activity, which means that the flowing water cuts away the rocks and soils from the mountains and highlands. So rivers usually arise from the mountainous region, and when they come down from the mountainous regions, what do? They break down the rocks and they carry the soil from the mountains and highlands along with the water. Now, after erosion, the next process is called as transport. Now, what does the river water do? As the river water is a flowing water, what happens is the water carries these eroded materials like stone, sand, and silt to lower areas. Lower areas means from hill to the areas of plain lands and all. And the third important process in terms of agents of gradation is deposition that we talk about. So what does the river water do or the stream water do here? These water drop the sediments in plains, forming fertile lands,
valleys, deltas, and floodplains. Now, what does this mean? It means that the river emerges from higher land, starts transporting the material from highlands to lower areas, and finally, as it reaches the plain area, its speed decreases, and as the speed decreases, the work of deposition starts. And when it starts depositing soil and the material it has carried down, it leads to the formation of fertile plains, valleys, deltas, as well as flood plains. So what does this mean? So what is the overall result out of it? The overall result is, over a long time, running water shapes the earth's surface by forming valleys in mountains and plains in lower regions. Now, as the river water is coming from mountains to lower areas, so when it is traveling between the mountain, it creates a gap between two mountains, which we call it as valley. Fine. And as it comes down and starts to deposition activities in the lower lands, it starts forming fertile lands or plain lands here. So because of the river or because of the running water, there are, in simple terms, there are many different types of landforms which are formed, and those are, one is in the mountainous region. If we talk about, it is forming deep valleys between two mountains. But if we come down to the lower lands where the river is playing a very important role, in such areas it creates fertile land, then deltas, as well as flood plains. See how a simple running water is helping in changing the landform that is present on the earth's surface. Likewise, let's move to the next agents of gradation, and the next agent of gradation is, the next agent of gradation is the glaciers. Now, this is a very important topic that we have to understand. Now, what are basically glaciers? Glaciers are huge covers of ice that melts on its own as the mass of it starts on increasing. So what do the glaciers here do? The glaciers scrape and carry huge amount of materials, carving U-shaped valleys between the mountains. So the activity of glacier, as the ice starts melting down, now this ice or the movement of the ice slowly starts changing the landform around it. So what do they do? It does scraping. This is a very important thing that you guys have to understand. It scrapes, and whatever scraped material is there, that is carried in huge amounts from the higher gradients to the lower gradients. So if I have to tell you it in simple words, remember, glaciers are what? They are large masses of slow moving ice. And where are they found? They are found in cold regions. And in India, the cold regions are the Himalayan mountains. When we go to the Himalayan mountains, you can see especially the greater Himalayas are covered with extreme amount of ice, which we call them as glaciers in our country. Now, as these glaciers move, what do? They cut the rocks. And as the rocks are cut, these rocks are carried in huge pieces of stones. Along with the rock, even soil and sand also comes down with them. And because of this, a gap between two mountains is created, which is not a deep valley. Instead, it is a shallow valley, and this shallow valley is in the shape of a English letter U. And that is why those valleys are called as U-shaped valleys. So the landform that is created because of the glacier movement or the ice movement is called as what? U-shaped valleys that is created. So let's understand this entire topic through the picture which has been given to us. Fine. So first thing is the first process, glacier movement. Glaciers move slowly downhill under their own weight, which means what? As the weight of the ice increases, it is not able to tolerate on the high peaks and all. So because of that, the layer of the ice slowly starts moving down the hill because the weight of that ice is increasing. Now, during that process, what happens? The scraping process takes place, which we can also call as erosion process takes place, which means that as glaciers move, they scrape the land beneath them, plucking and grinding stones and soils. Now, understand. Now, as these glaciers are moving from uphill to the downhill, they're coming down. During their movement, they do the erosional activities. They cut the rocks, they grind the soil, and they carry the
sand or soil along with them down, and transportation takes place. Glaciers carry huge amounts of rock fragments, stones, and sediments within, on, and under the ice. Now, you can see in this picture there are some amount of eroded material moving along the sides of the glacier. There is some amount of eroded material which is on the top of the glacier, and there is some amount of eroded material that is carried beneath the glacier. So this glacier's direction of movement is from up the hill to down the hill, and as it moves down or up the hill, what is it doing? It is carrying the eroded material, it is causing the eroded material, and it is carrying it also. Along with it carrying, it is carrying in three different ways: beneath the ice, next to the ice, and above the ice, because of which there is extreme amount of erosion that happens because of the glacier. Now, what about deposition might be a question, because here in the picture you have you have only about erosion and you have about transportation. Then what about deposition? Deposition happens when the glacier reaches to a certain height and its movement slowly decreases because of the height of the place over there. And as the movement decreases, what happens? Whatever eroded material is there, that eroded material gets deposited. And slowly, when this glacier starts melting into the river in the form of a river or a stream, that stream carries forward the activity in its rest period of time. Now, how does this glacier creates a U-shaped valley? The glacier creates a U-shaped valley like this. I have given you a picture here. Now, before glaciation, this is a deep valley present between the two mountains. A river cuts a narrow V-shaped valley, and then glacier widens and deepens the valley by erosion. So, as glacier deposition takes place or glacier movement happens in such a place where there is a V-shaped valley, its erosional activity is extremely very high, and slowly a broad U-shaped valley gets created after the glacier gets melted and moved away from those areas. So what is the end result of glacial erosion? The end result of glacial erosion is it creates deep, wide, and flat bottomed valleys with steep sides, which we call them as U-shaped valleys. Okay, so in the first picture you can see V-shaped valleys which is created because of rivers, and in the third picture you can see U-shaped valleys which is created because of the glacial activities. Okay, so I hope the topic is clear so far. So let's move to the next erosion, the agent of erosion, where we talk about wind as a major important agent of erosion whose activity is highly seen in desert regions. Fine. So let's understand the concept here. Wind shapes desert by eroding and depositing the sun. So what does this mean? If I have to conclude this entire picture in simple words, I would like to say that wind is a very powerful agent, and especially it is extremely powerful in desert regions. What does it do? It picks up tiny sands and carries them from one place to another place. Sometimes it removes sand from one place and deposits in some other place. This forms beautiful sand dunes and changes the shape of the deserts there. So let's understand the concept of wind erosion through this picture that we have got. Fine. So first thing is erosional activity, which we also call it as wearing away. So what does the wind do? Wind picks up tiny sand particles and blows them against rocks and surfaces, and over time this wears them down, which is called as abrasion or sand blasting. So what is the wind direction? So whenever the wind moves, now this wind is carrying the soil, that soil rubs against these stones or structures which are present, and slowly because of the activity between the wind, the sand, and the structures, what happens? This structure slowly starts eroding down, which is called as erosion. The second one is transportation, which is nothing but carrying. So what does the wind do? It lifts and carries sand and dust particles, and fine particles travel long distances because of the wind, whereas heavy particles
cannot go to a longer distances, and they settle down at a particular place, rolling along the ground. And then the third activity is deposition, which is nothing but dropping. So whenever wind slows down or its speed decreases, it drops the sand. This builds beautiful landforms, especially like sand dunes, sand ripples, and loess deposits. You can see in this picture. So sand dune are low hills created by the deposition of sand over the period of time. So what are few landforms that are created because of the wind erosion? The first one is sand dunes, second one is sand ripples, and third one is loess deposits, which means fine dust deposited by wind over long distances. So what is the key point that we have to remember here? The key point that we need to remember here is that wind in desert regions acts as a natural artist. It breaks down the rocks, carries the sand, and builds new landforms, and shaping the ever-changing desert landscape. So wind is a very powerful agent of gradation. Like the wind, we have yet another most important agent of gradation, which we call it as sea waves. Now, whenever we go to beaches, we see waves. We don't see waves, we actually see tides there, but we usually commonly confuse them into waves then. Fine. So let's understand how do sea waves act as agent of gradation here. So sea waves erode coastlines, and what are the structures that they form? They form cliffs, beaches, and bays. These are the three types of structures which are created by them. So you can see the picture of cliff, okay, then you can see the picture of beaches, and then you can see the picture of bays. So let's understand what are cliffs, what are beaches, and what are bays here first thing. So cliffs are nothing but they are formed by strong wave erosion that wears away the base of rocky coast. Over time, the cliff becomes steep and high. So what are cliffs? Cliffs are these mountainous areas along the lines of the beaches. So what happens is, because of the high force of waves and continuous friction that happens between the sea waves and the land which is present around it, what happens is the sea waves cuts off the areas of land, creating the cliffy regions. Likewise, it also creates what we call them as beaches. Beaches are nothing but they are formed by the deposition of sand, pebbles, and small rocks in areas where waves lose energy. These materials build up over time to create wide beaches. So we all love to visit beaches. But how are these beaches created? Beaches are created, whenever sea tides come. These tides carry sand, they carry pebbles, they carry small rocks. And as the tide from the sea, from the inner portion of the sea, approaches the shore of the sea, what happens is the intensity of the wave decreases. And as the intensity of the wave decreases, it deposits the sand, pebbles, and small rocks, because of which over a long period of time such a deposition creates the beaches. Likewise, we have the third type of landform that is created by the sea waves, which includes bays. Bays are nothing but they are soft rocks which erode faster, creating inlets of water surrounded by higher land. Now, this is an example of bay, what you can talk about, which are soft rocks, and these are easily broken down by the force applied by sea waves as well as tide. But these are a kind of higher land that are surrounding the water surface regions, lower than cliffs. This is one important thing that you have to remember. So in simple terms, if I have to tell you, is sea waves continuously hit the land near the coast, and over many years these waves break the rocks and change the shape of the coastline. Like I told you, it creates three types of landforms, which includes cliffs, beaches, and bays. So let's understand how does this happen. So waves are very powerful. They hit the coastline, break and wear the rocks and soil. Waves carry the eroded material like sand, pebbles, and rock fragments, and deposit the materials in calmer areas, building new landforms. So what is the key takeaway? Key takeaway is waves are very powerful natural agent that continuously erodes, transport, and deposits material, shaping beautiful coastal landforms that we would all love to see there. So like all other agents of gradation, what do we see? All of these togetherly create different types of landforms that we generally study about. let's study yet another most important yet unseen, I would like to say that unseen agent of gradation, which we call it as groundwater. Now we know that groundwater is very much important. We talk that the levels or the quantity of the groundwater is decreasing over the period of time. But this very groundwater is also a very important agent of gradation. Okay, how? Let's understand. So what does groundwater do? Groundwater dissolves rocks, especially like limestone or silica stone, and they create caves and sinkholes. Okay, so what is a cave? You can see this is a cave and this is a sinkhole. These are two different types of landforms that are created because of the groundwater, about which we will study in depth as we go, as we understand each of these gradation in my next videos. So if I have to conclude the entire topic of groundwater and how does it create different types of landform, I would like to add groundwater is water found beneath the earth's surface, and this water can slowly dissolve soft rocks, especially like the limestone, over many years, creating either caves which are underground or sinkholes where the ground suddenly collapses because the rock below has dissolved. So this portion is called as the sinkhole over here. So what is the process that generally happens in groundwater? So rainwater soaks into the ground, moves down the rock through the cracks and openings. So we usually see that the crust that we are living on has some small cracks through it, and whenever there is rain that occurs, this rainwater is absorbed by the groundwater through the cracks that are present on the surface of the earth. Okay, so rainwater absorbs CO2 from the air and soil, and it gets absorbed under the groundwater. Water dissolves soluble rocks like limestone, that the cracks and joints widen over the period of time. So what happens is, now as the water moves through this crack, it starts dissolving the stone which is present over here. Especially if the stone is made up of limestone, the limestone slowly starts dissolving in the water. And here erosion and transportation takes place, which means the water carries away dissolved rock, sediments, and enlarging underground spaces. So what does the water do? The water slowly starts eroding the material as it moves down the lines, and slowly it starts transporting the eroded material from one place to another place. Likewise, cave and sinkhole formation takes place. So caves are formed underground. When the roof becomes too weak, it collapses and forms sinkholes. So now this is a cave which is formed inside the ground because of the activity of groundwater dissolving the limestone. Now over the period of time, when the cave has no support left with it, what happens is it creates a sinkhole. Why sinkhole? Because the stone below it has been completely dissolved by the activity of the water, and there is some deposition which is present above the hole, and that has no support at all. And over the period of time, what happens is this material completely collapses down, creating a sinkhole in the underground surfaces. Okay, so this is an example of a sinkhole, and this is an example of cave which has been given to you all. So these are 5 agents of gradation that we have discussed about. So what do they do? Together, these agents are continuously modifying the landforms, lowering high areas and filling up low areas with them. Okay, so all these natural forces work all the time. They are not on rest, they are continuously working. They don't have holidays, they don't have any family function to attend, so their activity is to do the same thing over the period of time. So they are doing all these activities all the time. They break the mountains, they carry the broken materials, they fill the low lying areas, and this is the continuous process, keeps changing the earth's surface. So remember, earth and the nature is like a giant sculptor, slowly reshaping our planet every single day. And what are those natural agents of gradation? Those natural agents of gradation are running water, glacier, wind, sea waves, and the groundwater. And what are they doing? They are breaking down the high areas to fill the low areas, and low areas are filled up, creating new different types of what we call them as landforms. So this change is continuous and there is endless impact, and over the period of time, this doesn't happen in small few days, like weeks or months. It takes millions of years for this entire process to be completed. Okay, so I hope the very small introduction on the concept of agents of gradation is clear to majority of you. If you have any doubts over any concept so far, then you can text me down about the concept that we have been discussing. So this is one important information that was being given to you guys, which is abbreviated in your textbook as don't miss out, which means it's a very important information that has been given to you in relation to the topic discussed in the textbook, especially agents of gradation. Okay, so let's go through this topic one by one for you all. So, landforms have played a major role in shaping the history of human civilization. What does this mean? It means that landforms are not just physical features, they have influenced where people live, where do they do the farming activities, where they have traveled, where they have traded, how they have traded, what they have traded, and how all these things have help them to build civilization. So, in simple words, geography has greatly influenced the history that we proudly talk about and proudly learn from today. Rivers and fertile plains like those of Ganga, Nile, Brahmaputra, and Indus gave rise to agricultural societies and early cities. Now, what does this mean? It means that ancient people settled near rivers because rivers provided them water. And water is essential for human survival. It's an indispensable part of our daily life without which our existence is nearly impossible. So, what does the water do? Water is for drinking, water is for farming, and water helps in making the soil fertile. And that is why greatest of civilizations have been found near the rivers, like the Ganga, like the Nile River, like the Brahmaputra River, and the Indus River. And what is the major activity that they have been carrying out is agricultural activities. So, without rivers, farming would have been completely difficult. And this is the knowledge that our ancient ancestors definitely had about. So, mountains acted both as barriers and protectors. The Himalayas shielded India from invasions but also allowed cultural exchanges through passes like Khyber Pass. So, talking about the one landform, that is mountains. So, mountains have two important roles to play. One, they stop enemies from entering easily, and at the same time, they protect the people living behind them. So, mountains act as natural walls to any countries. So that's a very important landform, right? So, for example, if we talk about the Himalayas, the mighty Himalayas that we have, these have protected us from many invasions. However, some of these mountains have passes through which people could cross. Like, for example, one of the uh, passes is example is Khyber Pass, and through such passes traders traveled, travelers came, new cultures came, ideas came, religions came, goods entered India. So mountains protected India while also connecting it to the outside world. Now, what is a pass? Pass is nothing but these are two mountains, the gap between two mountains with no river, okay, which is an motile region or a mobile region which can be easily crossed, where there is no water source found over there, or even if a water source is there, it's a very bleak water source. Such a pass, such a gap between two mountains which connects from one world to another world is basically called as a pass here. Likewise, let's talk about the second landform. The second landform is deserts, such as Thar Desert, limited the development of large settlement but encouraged trade routes such as Silk Route, coast, and harbors. Sorry. Okay, so let us talk about deserts. Example is Thar Desert, which did not allow a lot of settlements to happen, but it definitely made sure that there are trade routes, especially the Silk Route that existed.
So, living in deserts is difficult because there is very little water, and water, as we know, is a very important, indispensable part of our life. So, large cities did not develop in the regions of Thar areas, but deserts became very important trade routes, especially if we talk about the very famous Silk Route that connected India and China to the worlds of Europe and America. Is an example where the Thar was also a part of the Silk Route here, which connected different countries together for the purpose of trading activities. Likewise, we have yet another most important land route or landform that we are supposed to talk about, which includes coast and harbors, supported trade, travel, and cultural contacts with distant lands, helping kingdoms like those in South India to flourish. So, what does this mean? It means that coastal areas which have natural harbors are nothing but parking areas, okay, parking areas for the ship to stop. So many of our coastal states, what are there, they have natural parking system for the ships to stop safely there, and these harbors have helped people with trading activities with other countries, to travel by sea, and to exchange ideas and cultures. And because of this, many South Indian kingdoms became rich as well as powerful. Even today, history shows that wars, settlements, trade, and cultural growth were all deeply influenced by the lands and their physical features. So, what does this mean? Even till today, geography continues to influence human life. Like, for example, depending on the type of land we are living in or living on, we decide what type of economic activity we should be carrying out, what type of trading activity we should be doing in. Can we construct city over there? Can there be settlement more than an expected number of people living over there? So there are certain lifestyle that we are involved in, but this involvement is decided by the physical feature of the land, which continues to play a very important role in our day to day life. So, remember one thing, history and geography are closely connected to each other. So, you cannot treat both these important elements as of social science as different topics over here. Whatever history we have is influenced by the geography. So, about the don't miss out, I have given you a picture based example for the rivers and fertile plains. This is one type of landform. So, rivers and fertile plains like those of Ganga, Nile, and Brahmaputra and Indus gave rise to agricultural societies and early cities. Similarly, mountains, they act as barriers and protectors. Then we have desert and trade routes. Deserts, especially the Thar Desert, influenced the trade routes, though it did not allow large settlements to happen. Similarly, coastal regions with great harbors influenced cultural contacts with distant lands as well as trades also. So, if I have to say, landforms have shaped human history in countless ways, if we have to talk about. It has led to war, it has led to settlements, it has led to trading activities, and it has also led to cultural growth as well. So if I have to tell you very clearly, even today history shows that it is influenced by geography and the physical feature that is found around it. Okay. So, and that's how nature has been reshaping our planet for millions of years and even shaping human history. If this explanation made the chapter simple and easy to understand, then don't forget to hit the like button, share this video with your classmates, and subscribe to my channel Let's Revise by Vidyashri Kadlibuddi. Learning geography doesn't have to be difficult. When concepts are clear, success becomes easy. So I will see you in the next CBSE Class 9 Geography lesson. Until then, keep learning, keep revising, and keep succeeding. Bye, everyone. What if I told you that something as soft as water can cut through mountains, create breathtaking waterfalls, build fertile farmland, and even create new land near the sea? Sounds unbelievable, right? Well, that's exactly what rivers do. In today's video, we are going to understand running water in the simplest way possible, I will explain every single sentence from your textbook so that by the end of this video, you will understand the concept perfectly and be ready to answer any CBSE exam question confidently. So let's begin to understand the very first agent of gradation, running water, as a very important agent of gradation that shapes the earth's surface around us. Okay, so rivers shape the land through the process of erosion, transportation, and deposition, creating a variety of landforms along their course. What does this mean? This sentence tells us that rivers are constantly changing the earth's surface. But how do they do that? They do it through three important processes which we have already studied, which includes erosion, transportation, and deposition. So the very first process is erosion, which means that rivers cut and wears away rocks and soil. Think of it like rubbing sandpaper on a piece of wood. Slowly, the surface gets worn away. The second process is transportation. Okay, transportation means the river carries the broken rocks, sand, and soil from one place to another place. And the third process is deposition, which means that the river drops these materials when it actually slows down. Because of these three processes, river creates many different landforms as they flow from the mountains towards the sea. Fine. At the upper course, rivers form V-shaped valleys, waterfalls, and rapids due to steep gradients, strong erosive forces. What does this mean? It means that the journey of a river is divided into different courses. Okay, there are in general three courses. The first one is upper course, second one is middle course, and third one is lower course. The place where the river actually starts originating, we call that as upper course, which usually happens on the mountains. So when the upper course is the area where the which is considered as the beginning of a river, which is usually found in the hills or mountains, and here the land is steep in nature. Okay, now because of that slope which is steep, the river flows very fast. And fast moving water has a lot of energy. And this powerful water cuts deeply into rocks, which leads to the formation of V shaped valleys. It leads to the formation of waterfalls, and along with that, it also leads to the formation of rapids. Rapids are nothing but these are fast flowing, rough sections of water which are moving in a very fast way. That's why we call them as rapids. Fine. So in the upper course, there are three types of structures formed: V-shaped valley, waterfalls, and rapids. Okay. Then coming down to the next course of river, which we call it as the middle course. So in middle course, the river starts to meander, forming oxbow lakes and floodplains as it loses its energy and begins depositing sediments. Now, what does this mean? It means that as the river comes from upper course to the middle course, what happens is the speed of the river decreases and it reaches the middle course. Here, the slope of the land becomes low. The steep is very less. So the speed of the river decreases. Since the speed has decreased, the river has less energy. Now it can't keep on flowing in a straight line. So instead, it starts bending from one side to another side, which we call them as meanders. Okay, it starts bending like this, and these structures, which are formed by the river in its middle course, is called as a meander. Sometime a bend becomes so large that it gets cut off from the main river, and that is called as an oxbow lake. The slower the river starts, it starts depositing more sand and soil on both sides of the oxbow lake. And these widen, flat, fertile areas are basically called as floodplains too. So in the middle course, what does the river do? It creates three types of structures. One is meander, second one is oxbow lake, and the third one is floodplains. Why? Because it loses in energy and starts deposition activities more. Similarly, moving ahead to the last course of the river, which we call it as the lower course. And in the lower course, the river slows further and deposits large amount of sediment, forming deltas, leaves, and alluvial fats. So what does this mean? Now, when the river reaches the lower course, which is the final stage before it joins the sea or an ocean. Now, here the land is almost flat, so the river flows very slowly. Because the river has very little energy, it cannot carry all the sediments any further. So, what it starts doing is it starts depositing those materials. And because of this, different types of landforms are formed, which we call them as deltas, leaves, and alluvial fats. Okay, so we will understand about all these different types of structures very shortly in this video as we go ahead. Now, these landforms are very much important, but how? These landforms are not only important for understanding river dynamics, but also play a vital role in agriculture, settlement, and ecosystem. Now, what does this mean? It means that the landforms that are created because of the river are very useful. How? The fertile soil helps farmers to grow crops, that is agriculture. Many villages and cities are built near rivers because water is easily available. These areas also support many plants, birds, fish, and animals. So, rivers are important not only for nature but also for human life. So, let's understand this paragraph with the help of pictures that I want to share with you all, guys. Okay, so talking about the first course of the river, which is the upper course. Now, as I've told you, upper course is the place where the river actually originates, and in these areas, it creates different types of landforms, which we call them as V-shaped valleys, waterfalls, and rapids. Why does this occur? Why does this happen? Because the river has a lot of energy and it is flowing with a greater speed. And because of that, it conducts a lot of erosional activity in the upper course of the river. Okay, so now these are the mountains that you can see, and in between the mountains there is a valley formed, a gap formed, which is because of the water which is flowing at a greater speed with a lot of energy here. Now, as the valley is formed in V shaped, so the name of the valley is called as V shaped valley. And because of the cutting of river or the elevation of the land, small waterfalls also gets formed at the upper course, and we call them as waterfalls. Similarly, as we come down, because of presence of large stones and fast flowing rivers, what happens? Rapids are also created in the upper course of the river. Okay, so this is about the first course of the river where the river actually originates. Then we come down to the middle course. Now, in the middle course, the speed of the river decreases a little because the slope also decreases. And in that middle course, the river starts bending, which we call it as meander. So instead of flowing straight, the river starts flowing in a curve shape. It starts flowing in a curve shape, and this curve shape flow of river is called as meander. Sometimes these curve shapes are so big enough and there's a lot of deposition, which leads to the formation of a lake, which we call it as oxbow lake, which are nothing but once upon a time this entire meander and oxbow lake was connected. But because of extreme deposition at these places during the time of flood and all, what happened is this portion this portion of the meander got cut off and has formed into what we call it as an oxbow lake, or it is in the form of horseshoe lake also, which we call them as oxbow lakes. Similarly, over the period of time, due to excessive rainfall and all, or excessive carrying of river or excessive water in the river, it starts creating floods, and floodplains also get formed because of excessive deposition that takes place. And what are deposited? Sediments, which are nothing but sand, soil, and the stones and rocks that are carried by the river from upper coast to the lower coast. So the first physical feature is meander, then second one is floodplain, and third one is oxbow lake. That is a very important physical features that are created by the running water in its middle course. Moving ahead with the lower course. So in the lower course, what is the activity done by the river here? Okay, so in the lower course, we see that, oh, I forgot presenting on the slide. Yeah. Talking about the lower course, in the lower course, the speed of the river completely decreases. It has very less energy. Why? Because the land over here is completely flat. Because of this, what happens is it starts depositing large amount of sediments, due to which what happens is great amount different types of landforms are created, which includes talking about deltas, leaves, and alluvial flats. What are basically deltas? You can see a triangular structure that you have already studied in your lower courses. Delta is nothing but flat landforms found at the mouth of a river where it splits into many distributaries. Now you can see here in this picture, this is the mouth of a river. Now from here, it is going to join into a sea or a ocean. Now here, as the speed of the river has decreased, what happens is sediment deposition is more. Due to that, the number of streams formed are generally more. So these are called as distributaries. Due to this distributary, what happens is sediment deposition is more. And this is a triangular landmass that is created by the river at its mouth before joining the sea, which we call it as deltas. Likewise, it also forms called as leaves. Leaves are nothing but embankments, okay, built along the river banks due to deposition. So over the course of time, because the river has kept on depositing a large amount of material, the height of the land goes on increasing, which acts as an embankment here, which we call them as leaves. Similarly, we have yet another most important landform that is created in the lower coast, which we call them as alluvial fans. Now, what are alluvial fans? Why we call them as fans? Because they are fan shaped deposit of sediments formed where the river emerges from mountains onto the plains. Now, fan shaped means like this. There is center, then there are wings like the fan that generally has. This usually happens where the low-lying mountains and the plains are very close by. In such areas, alluvial fan deposits are usually found. And one of the benefit of alluvial fan deposit is that many a times expensive minerals and more valuable minerals, non-corrosive minerals are found with the alluvial fans around us. Okay, so this is about the concept of running water creating different types of landforms from if in its courses of river, upper course, middle course, and lower course. So this is a pictorial representation of the benefits of different types of landforms that is created by the river. The very first benefit is the agricultural activity. Second one is it encourages settlement. Third one is it promotes ecosystem and ecological development. Fourth is it creates water sources. And fifth one is it provides natural protection and all. So you can include these points apart from the one that has been given to you in your textbooks. So this is about how river creates different types of landforms in its course, from the place of its origin to the place where it is going to merge with the sea or the ocean. It creates different types of landforms that we have studied so far. So moving further, we are now going to study about one of the most important landform that is created by the river, especially in its upper course, and that is a waterfall. Okay, so what is a waterfall and how does it work? Let's understand this entire concept. A waterfall is a landform where a river flows over a steep cliff or vertical drop, creating a dramatic fall. Now, what does this mean? A waterfall is a place where a river suddenly falls from a great height. It falls over a steep cliff or a vertical rock surface, because of which it creates a beautiful natural feature, which we proudly call it as a waterfall. Okay, in our local languages, and whenever there is rainy season, we all love to visit these waterfalls, right? Waterfalls form in the upper course of rivers where hard rocks resist erosion while soft rocks below are worn away, creating a sudden drop. Now, what does this mean? Waterfall usually are found in which course of the river? They are found in the upper course of a river. And when we talk about this course of river,
in that zone we find two different types of rocks. Okay, so they are, the upper rock is usually harder rock, but the lower rock is usually soft rock. Now, upper rock is the one which is found above the cliff. Soft rock is the one which is found at the below of the cliff. Okay. Soft rocks gets eroded faster by flowing water. Hard rocks doesn't wear away easily, which means that the soft rock which is present down at the waterfall gets broken away very easily. Okay. As the softer rock disappears, the hard rock is left hanging over it, which creates a steep drop. When the river reaches this drop, the water falls down, because of which a waterfall is formed. I'll explain you this entire topic with the help of picture that is given in your textbook and the picture that I have created for you all. They are not only beautiful natural features but also attract tourists, making them important for local tourism and economy. Now, waterfalls. What is the benefit of this, which is a physical feature which is created by the river? The waterfalls, one thing is they are extremely beautiful. People love to see that magnificent physical feature which is created by a river, waterfalls, especially in rainy season. So it is very beautiful, and people from different places come to visit these waterfalls. Tourists spend money on hotels, transport, food, and shopping, which creates employment for local people. So waterfalls, in short, helps in developing the local economy. Let's understand what are few more benefits of a waterfalls. Waterfalls are sometimes used for hydroelectric power generation, as the force with which the water falls can be harnessed to produce electricity. What is yet another most important use of waterfalls? The falling water has a lot of force, and this force can rotate large turbines, and the turbines can produce more electricity. And when we produce electricity with the help of water, we call it as hydroelectric power, which is basically a very clean energy and a renewable source of energy also, which reduces our dependency on non-renewable sources of energies like coal, petroleum, and natural gas, along with conserving the nature around us. Apart from this, let's understand what else are the benefit. In addition, they provide opportunities for recreation such as trekking and photography, and often hold cultural and religious significance in certain regions. Now, what does this mean? It means that many people visit waterfalls for fun and adventure. They enjoy trekking, they like taking beautiful photographs, and some waterfalls are usually considered holy places, and people visit them for religious purposes. So, waterfalls are very much important in many different ways. So, this is about one important physical feature that is created by a river in its upper course, which we call it as a waterfalls. So, let's understand this through a picture that has been generated here. Okay, so what are the different elements of a waterfall? Let's understand this. You can see a waterfall means water is falling from higher slope to a lower slope. Okay, that is why it is called as a waterfall, and it has different elements like hard rock which is present here. This is the water that is falling from the hard rock layer to the down over here. Then you have the soft rock which are present here, and the water plunges into a pool where it gets collected at the pool base, causing further erosional activity. So how does waterfalls actually form? So what happens here is a river flows over layers of hard and soft rock. Now this is hard rock and this is soft rock. Now the river is flowing on top of the river is flowing on top of a hard rock, and it is flowing on top of a soft rock also. What happens is soft rock. This is the part that gets eroded faster than the hard rock. Now, this is the hard rock, this is the soft rock. Now, when water starts falling, soft rocks, as they are soft, they start breaking down very easily. Now, the overhanging hard rock. Now, this is the overhanging hard rock, and the soft rock has been eroded completely. Now, that rock collapses, creating a steep drop. What happens is now, as there is no base support for the river to flow continuously or in a continuous way, what happens is the soft rock is completely broken down and the hard rock is hanging up. Now, as the water comes, on the hard rock, as there is no support for it down over here. It has to create a physical feature in the form of a waterfall. So this process continues, making the waterfall higher and deeper over the period of time, because the water flows with a greater speed, which creates erosional activities continuously. So the water, especially the waterfall carrying out the activity of erosion, is a continuous process that is generally seen. So what are the importances of waterfalls that we have discussed so far, which has been put up in the form of picture for you guys? The first one is recreational activities like adventure, outdoor activities, and trekking. Then photography, it's a very great and favorite spot for many photographers and nature enthusiasts. Many a times it has a link with cultural and religious significance. It has a lot of support to the local ecosystem and maintains the natural balance. It attracts a lot of tourism and supports local economy. Likewise, it also promotes hydroelectricity production. So these are importances of waterfalls that have been mentioned in your textbook. Apart from these, also you can include many other points in your examination. Likewise, let's move ahead with next portion of this is the picture that has been given to you guys in your textbook about the waterfall here. Now, as you can see, I've already explained you about how a waterfall is basically formed. Now, the first one is the river that is flowing on the surface of a hard rock. Okay. Now, this is a gap that is created. Now, why is this gap created? Because there was the presence of soft rock in the placement area where we have three. There was soft rock below over there, but because of the force of the river, the soft rocks have been broken down, they have been eroded down, creating a gap here. Okay. And then we have a plunge pool. The plunge pool is the area where the water crashes deep at the base, and in this area also it creates the erosional activity. And this zone is the river, which again continues to flow down the stream. So this is an example of a waterfall, a very famous waterfall found in India, which is called as the Dudhsagar waterfall that we generally see. So in near future, visit this place with your parents. Fine. So this is a picture about the waterfall that has been given to you guys in your textbook. So I hope this physical feature about the waterfall is clear to majority of you. If you have any doubt over the topic that I've explained so far, you can put those doubts in the comment section below, which I'll be definitely replying to you all guys. So moving ahead to one of the most yet another important landform that is created in, or a physical feature that is created by the running water in its middle course, which is called as the meander. So let's understand the concept of meander completely here. A meander is a winding curve or bend in the middle or lower course of river formed due to the lateral erosion or deposition of sediments. What does this mean? It means that a meander is nothing but it is a bend which is seen in a river. Okay, so river instead of flowing straight, it starts flowing in S shape. It starts bending. Such a bend is basically called as a meander. Where is it usually found? It's usually found in the either middle course or it is found in the lower course. So here the river is not flowing straight, instead it is curving from side to side. And these bends are formed because the river starts eroding from one side and starts depositing the soil on the other side. Like for example, suppose this is the direction. This is the directional flow of the river. Now here the river is doing erosional activity, and as it moves from one bend to another bend, it is doing the depositional activity. So it is cutting one edge and depositing at the other edge, because of which this bend gets created or the S shape gets created. And this is usually found in the middle course or it is found in the lower course, that you guys have to remember thoroughly. Okay. So as the river flows, it erodes outer banks of bends and deposits sediments on the inner banks, gradually creating large loops. What does this mean? Water flows faster along the outer side of the bend. Now this is the S shape. Okay. Now this is the outer bend and this is the inner bend.
The speed of the river here is more, but the speed of the river here is slow. So it erodes from the outer bend and starts depositing it in the inner bend. Okay, so the water moves faster on the outside bend. Because it is moving faster, it cuts on the outside bank, and on the inner side the water flows slowly. That is why it deposits sand and soil here, and for many years these bends become large, and these bends are generally called as meanders on the course of time. So meanders are important for humans because the fertile soil deposited along the banks support agriculture, making these areas ideal for farming. So what is the benefit of creating such a beautiful natural landscape or natural feature, what we call it as meander? This is important because it deposits rich alluvial soil at the cross of these bends, and as this alluvial soil is very fertile, farmers can grow many crops in these areas. That is why meanders are very important part of agricultural activities. Apart from this, let's understand what else is the significance of meanders. They also influence settlement patterns as villages and towns often develop on gentle slopes near meanders. So, apart from agricultural activities, people like to live near rivers, which means it also supports settlements. Why? Because it provides water for drinking, farming, as well as daily activities. That is why many villages and towns are usually found along the banks of rivers, especially very close to the meanders. Apart from this, in addition, meandering rivers can be used for navigation, irrigation, and in some cases tourism, as the scenic curves create attractive landscapes too. And this is very much important for us to understand. A majority of the times, rivers become wide and calm. Now, this can be used for navigation, where boats can be used for transportation and for movement of goods and people also, which we call it as navigation. River water is also used for irrigation, and these curves, meandering curves, what we talk about, they are very beautiful curves, because of which they become naturally a tourist attraction, also boosting the economy of that particular place. So one such example of a beautiful meander that we see in your textbook is the Great Anicut, also known as Kalnai in Tamil Nadu, is an example of use of rivers for irrigation. Now, what is this? Anicut is nothing but we call it as oldest dams. And where is it located? It is located in Tamil Nadu. And what is the other name apart from Grand Anicut? The other name is Kalanai. And the main purpose of this is to supply river water for irrigation, which has been helping farmers to grow crops throughout the year. Okay, so let's understand the concept of meanders with the help of picture that I want to show you guys. So, how are meanders formed? Usually, rivers flow straight from upper steep to the lower steep. Okay, but when they come down to a lower steep, their speed decreases and they slowly start bending, and here they start creating erosional activities, and whatever material is eroded here gets deposited in these areas. So outer banks and inner bank erosional and deposition start taking place, and over the period of time erosion increases, deposition also increases, widening and deepening this curve. Okay, and the bend becomes more prominent. Then, over the period of time, it creates large loops or meanders in the middle and the lower course. And if the deposition continues for a very long period of time, this meander gets cut and forms into what we call it as oxbow lake that we have studied already. Okay, so here is yet another real picture of a meander river. You can see the agricultural activities that is being carried out. So there is erosion happening here, there is deposition taking place, and this is creating a bend. And a bend in the river flow or the course of the river is what we generally call it as a meander. Okay, so remember what is a meander? A meander is a bend which is seen in the river because of erosional and deposition activity, as the energy and the speed of the river slowly starts decreasing. Got it? And it's extremely important and useful because it has fertile soil,
promotes agriculture, it creates settlement, it provides tourism, and it also creates human settlement here. Okay, so this is about one important physical feature that is created by the river in its course, especially in the middle course here. So that's about the concept of meander that I wanted to explain to you guys. Moving ahead, which we have already discussed about the importance of the meanders. Now, this is the picture of the Grand Anicut, which is seen in the regions of Tamil Nadu. And this is built across the river Kaveri in Tamil Nadu, which is an ancient structure which is still used to continue to support agricultural and irrigation activities even till today, which shows that how rivers are used for sustainable benefit for the people. Now, this was built across the Kaveri River during the time of 2nd century by the king Karikala Chola, and this this diverts the water into canals for irrigation and agricultural activities. It is also called as Kalnai, and it's a very good example of engineering, tradition, and sustainability, which we can usually talk about. So moving ahead, this is the picture of a meander that I wanted to show you, which is given in your textbooks for you guys. Okay, and it has been labeled also. Like for example, you see here, the first part is erosion on the outer bank. Fine. Now this is the picture of a oxbow lake that has been seen. The second part is deposition on the inner bank. Here erosion is taking place. Here deposition is taking place. So erosion, deposition, then formation of a meander, a bend in the sea, and the fourth part is a great loop that is created, which in further time might get cut off and form a separate oxbow lake that we generally talk about. So this is the picture that has been given to you guys in your textbook. Okay, so that's about the concept of meanders. Moving ahead to yet another most important physical feature that is created by a running water in its lower course, which we call it as deltas. So let's understand about the concept of deltas in depth. So what is a delta? A delta is a landform formed at the mouth of a river where it flows into a sea, ocean, or a lake and deposits the sediment it has carried from upper stream. Now what does this mean? It means that a delta is formed. Where is it formed? At the end of a river. And that end of river is called as mouth of river. This is a place where the river is now going to plunge or join a sea, join an ocean, or it is going to join into a lake, where the river completely slows down, and as its speed decreases, energy reduces. As energy is less, speed is less, whatever sediments it is carrying in the form of sand, silt, and clay, everything which has been carried right from the upper course and from the middle course, everything starts getting deposited in the lower course, which starts creating the delta that we talk about. And delta is a triangular landmass which is extremely fertile and usually found at the mouth of a river. Over time, these deposits accumulate to form fan-shaped or triangular area of land. What does this mean? It means that river keeps on depositing sediments year after year, and slowly these deposits goes on becoming larger, and finally they either become fan shaped or they usually become triangular shaped. Majority of the deltas that we have seen are basically triangular in shape, and that deposit is basically called as delta. Now, what are the benefits of deltas? Let's understand the benefits of deltas here. So deltas are highly fertile due to their rich alluvial soil, making them ideal for agriculture and supporting crops such as rice and jute. So what is the ultimate benefit of having deltas, which is a very important physical feature that is created by a river? Deltas are rich in the deposit of one type of soil, which we call it as alluvial soil, and this soil contains extreme amount of nutrients, which is very much good for farming activities, and that is used for growing crops like rice and jute. And these crops grow very well in the deltaic regions. Rice require a lot of water. Similarly, jute also requires a lot of water for their growth. Let's understand the other importance. They are also important for fishing as the mix of fresh and salt water creates diverse aquatic life. This is very much important. Now, as I've told you that delta is a place where the river mixes with the sea water. The river water mixes with the sea water. And we know that river water is fresh water and sea water is salty water. And this creates a perfect habitat for many fishes and other aquatic animals. So, fishing is yet another important occupation that is seen in the deltaic regions. Likewise, what are the other importances? Many deltas support dense human settlements and are centers for trade and transportation because rivers provide navigable routes. Now, that is also very much important. Now, see, as deltas have rich alluvial soil, there is a lot of potency for fishing activities and all. So, what do we see is it attracts a lot of economic activities. So, when there is a high potential for large amount of economic activities, it attracts more number of people to settle down or live near the deltas. So rivers provide easy transportation also. Boats and ships can carry goods from one place to another place. That's why deltas are extremely important for trade and business activities too. However, they can also be prone to flooding, which affects human life and activities. Now, see, when deltas have lot of benefits, at the same time, they can have extreme amount of disadvantages also. And that disadvantage is that they are easily flooded during rainy seasons or during storms. And floods can damage crops, it can damage houses, roads, and affect human life. That is why people living in delta regions must always be prepared for floods. So that's about the concept of delta. Let's understand it furthermore with the help of the picture that I have generated for you guys. So what are the key features of deltas that if we are talking about? The key features are, first thing is it is formed at the mouth of a river where it is now going to join into a sea. Then it is made up of lot of deposited sediments. Either it is fan shaped or it is triangular shaped, and it is extremely fertile because of which it is extremely good for agricultural activities. Now, talking about how delta is formed, let's understand it through a picture. You can see this, you can see meanders here. Okay, it's in the lower course. Now, this river carries sediments, and these sediments are coming from upper course and middle course. Now, as the river reaches the sea, this zone where it is now going to join the sea, the speed of the river slows down. And as its speed decreases, whatever sediments it is carrying, all these sediments are deposited at the mouth of the river. This place is called as the mouth of the river. Now, these are the sediments. These masses of land that you are seeing are sediments that has been deposited over the period of time. Over the time, these deposits build up and form what we call them as delta. So this is river and this is sea, and this place is called as the mouth of the river. What are some of the examples of deltas that we know? One is the Ganga Brahmaputra delta, which we call it as Sundarban delta, the Nile delta, and then we have the Godavari delta, which is formed by the river Godavari also. So this is about the delta topic that I wanted to discuss it with you guys. And this is the picture of delta that has been given to you in your textbook also. So if we talk about, this is the river, this is the distributaries. Now see, because of the deposition, the river is getting divided into small streams again, and those small streams are called as the distributaries that we talk about. Then the third one are islands or bars, which are nothing but the land, the sediments that has been deposited for a long period of time, which have been formed into islands. And the fourth part is sea. So this deltas are usually formed at the confluence of a river and a sea here. So this is the picture of the delta that has been given to you guys in your textbook. Why it is important? Because many a times your teacher might end up asking you a picture based question and ask you to label the parts of a delta also. So be prepared about the entire concept. And this slide shows you all the importances of delta. Like as we have already discussed, as deltas are extremely fertile, it supports agricultural activities and it supports special crops like rice and jute especially. And apart from that, today people grow variety of sugarcane and pulses too. It is extremely important because it gives rise to extreme amount of aquatic biodiversity and fishing activities, supports human settlements, supports trade and transportation. But the major drawback of this one is that it is prone to flooding activities and all. So that is about the topic of deltas that I wanted to discuss. Now, this one is a let's explore activity that has been given to you guys in your textbook, and let's discuss on this concept for you all with the answers that I wanted to give you on the let's explore concept that has been given to you. Now, talking about Sundarban deltas, right from your 6th standard, 7th standard, you have heard this word called as Sundarban deltas or Sundarban forest or Sundarban tigers or Bengal tigers and all. Now, the Sundarban Delta is considered as one of the largest delta in the world, which is formed by two most important rivers, which we call them as Ganga and Brahmaputra, and one important river called as Meghana River, which is nothing but a confluence of Ganga and Brahmaputra in the regions of Bangladesh. Okay. Then it is considered as world's largest mangrove. This is one of the most important uniqueness of Sundarban deltas if I have to talk about. It supports mangrove vegetation, a vegetation that grows in the combination of fresh and salt waters. And this area, Sundarban Delta, is a home for Royal Bengal tiger and a lot of variety of plant and animals. And this is also considered as a UNESCO World Heritage Site and a biosphere reserve too. And it has a unique mix of fresh and salt water, which creates rich biodiversity. And this delta changes with tides and seasons, forming many creeks and islands. Now, why is this important? Why this delta is extremely important? And why is it so popular with the tourists? Let's understand. One thing, there are a lot of boat safaris through the rivers and creeks. Wildlife sightseeing, especially people visit this place to see the magnificent Bengal tiger. It has beautiful natural landscapes and forest. Bird watching is one of the most important activity which is seen here along with natural photography and recreational activities. So remember that Sundarban Delta is unique for its mangrove wildlife, natural beauty, and making it a top tourist destination to be admired a lot. Okay, so that's entire thing that I wanted to explain you about running water, which is one of the most important agents of gradation. So who would have thought that a simple river could carve mountains, create waterfalls, build fertile farms, and even make a new land? That's amazing power of running water, am I right? So if today's explanation made this chapter easy, then make sure you don't miss the next lessons. Hit the like button, subscribe to Let's Revise by Vidyashri Kadlibuddi, and press the bell icon so you never miss any other easy explanation that I'm going to give you on. And before you go, answer me today's question in the comment section. Which river landform did you find the most interesting? Waterfall, meander, or delta? I'll see you in the next video. Until then, keep learning, keep revising, and keep succeeding. Bye, everyone. Have you ever wondered why beaches don't look the same every year? Or how a huge rock standing in the middle of the sea was once a part of the land? Believe it or not, the waves you enjoy playing in are actually powerful sculptors of the Earth's surface. And in today's video, we will explore how waves and ocean currents shape our coastlines, one simple concept at a time. So let's revise this chapter in the easiest way possible. And in today's video, we are going to discuss yet another most important agents of gradation, and that is the waves and currents. The sea waves and the ocean currents, which are the most important gradations or agents of gradation that are shaping the Earth's surface. Before I begin, I just want you to tell you that the ocean that seems to be still is actually never still. And the water, but why do I say this? Because the water is always moving, and these movements happen in the form of waves and currents. And waves are the up and down movement of water. Currents are large streams of water that flow continuously in a very particular direction. But both waves and currents play a very important role in shaping the land near the sea. So let's understand this entire topic one by one.
Waves and currents are constantly moving over the oceanic surface, which means that the water in the ocean is always in motion. It is never still. Waves rise and fall while currents flow like rivers inside the ocean. So remember, though the ocean might look still, you might feel there is no movement happening, but there is always the movement of water that keeps on happening. They work in coastal areas and reshape the land along the coastal zone. Now, what does this mean? It means that the coastal area is the land where the sea meets the land. And when the waves hit the coast again and again, they slowly change its shape. Some places lose land because of erosion, whereas other places gain land because sand gets deposited there. That's why the shape of the beach keeps on changing every now and then. The action of waves, currents creates a large number of landforms along the coastal line, such as beaches, sandbars, sea cliffs, sea caves, arches, and stacks, which means that because of continuous erosion and deposition activity that happens because of the waves and currents, there are different varieties of coastal landforms that are created, and some of these landforms are beaches, sandbars, sea cliffs, sea caves, sea arches, and sea stacks. And we will understand each of these one by one in the video today. Okay, so you will learn more about waves and currents in part 2 of this textbook, which means that this chapter is only introducing you the topic. And furthermore, greater detail regarding the topic of waves and ocean currents will be covered in the second part of the textbook that will be available to you very soon. So let's understand the concept of waves and currents. So what are waves and currents? These are constantly eroding, transporting and depositing large amount of material from one place to another place, and because of which it creates different varieties of landforms, which we talk as beaches, sandbars, sea cliffs, sea caves, sea arches, as well as stacks. These are the pictures that I have generated with the help of AI for you all guys. So this is the picture of beaches which we all visit. This is the picture of sandbar. These are sea cliffs, sea caves, sea arches, and sea stacks. And these are beautiful landforms that are created because of the actions of sea waves and sea currents that we have to remember thoroughly. Moving ahead to understand the concept of beaches over here. Okay, so let's understand more in depth about the beaches that we are going to learn over. A beach is a landform made up of sand, pebbles, or rocks along the shoreline of a sea, ocean, or lake, created by the deposition of sediments by waves. So, what is a beach? A beach is a sandy area or it is a rocky area very close to the sea or a lake. Like in terms, if I have to tell you, beside the sea or beside a lake, you find the presence of sandy deposition or rocky deposition, which is called as a beach. When does it get formed? It gets formed when the waves bring sand, pebbles, or small rocks and leave them along the shore. That is called as deposition. So, in simple terms, if I have to tell you, whenever sea waves come to the seashore, they bring sand, pebbles, and rocks. Okay, and they deposit them on the shore, which leads to the creation of beach. So, remember one of the important keyword here: deposition means the dropping or settling of materials carried by the water, wind, or ice. And here, in terms of beaches, who is doing the deposition activity? The water in the form of a sea wave. Beaches are constantly shaped by wave action, tides, and currents which move and deposit materials along the coast. This is very much important. This line tries to tell us that the shape of the beach are always changing. And why does this happen? Because of the activities of the waves. Now, waves keep on bringing new sand, or sometimes they take the sand from the existing beach and deposit it in some other place. Sometimes they also carry sand away, like I told you. Tides and currents also help move these materials from one beach to another beach. That is why the beaches never remain exactly the same forever. Sometimes it might feel, the beaches are looking the same, but no, constantly it is
keep on changing because of the activity of sea wave, tides, as well as currents. So let's understand how these beaches are extremely useful for human beings. For humans, beaches are popular tourist destinations for relaxation, swimming, and recreation, which boost the local economy. This is one of the most important economic importances of beaches. We all love to go to sea beaches, right? So we continuously keep on visiting beaches. Like us, there are many people who visit beaches during the holidays. They enjoy swimming. It gives a lot of tourist activity, adventurous activities to be done there: swimming, paragliding, walking, playing, and all. And as tourism is more, it creates jobs for local people in the form of hotels, restaurants, and all. And because of the tourists, there's a lot of economic boosting that also generally takes place. Apart from this, beaches also provide fishing areas, and some coastal communities rely on them for collecting sand and shells too. Now, what does this mean? It means that many fishermen use beaches to launch and park their boats. This is first thing. Why do fishermen are launching their boats or parking their boats there? Because the sea is a home for a lot of aquatic animals, and many communities rely on these aquatic animals for their survival. And apart from this, many people collect shells, they collect sand from the beaches for variety of purposes. So beaches also support the livelihood of coastal communities in the form of food as well as economic activities also. Additionally, beaches act as natural barriers against strong waves and coastal erosion, helping safeguard human settlements near the coast. Now, this is a very important concept to discuss about the beaches. They act as natural barriers and they safeguard the human settlement. How is that? Let's understand. Beaches protect the land from strong sea waves. They absorb much of the waves energy. You might have seen, if you have visited beaches, the wave emerges very strong and force, but the moment it approaches the seashore, its energy and its speed also decreases. This happens because the beach absorbs much of the energy of the wave there, because of which it reduces the damage to the house or villages which are settled down near the coast. So beaches work like a natural shield for protecting the human life whose life is settled on the, or whose life is completely dependent on the coastal areas that they are living around them. So let's understand the concept of beach through the photo here. So what is a beach? Okay, so beach is created because of wave action, tide action, or currents, like I've told you. So whenever the waves or tides or ocean currents bring sand, pebbles, and all, and they deposit on the shore here, it creates the beaches. So how are beaches formed? Let's understand. The waves break the rocks into tiny particles, and these waves and tides carry those tiny particles, and then when the water slows down, it deposits those sediments on the shore, and over the time, continuous deposition is what leads to the formation of the beach. And beaches are constantly reshaped by the nature again and again. So remember that beaches are not constant. Instead, they are dynamic landforms. They keep on changing and they're always beautiful in their appearance. Okay, so let's understand what is the importance. Yeah, different types of landforms that are formed because of the beaches or because of the waves and currents here. This is a picture which has been given to you in your textbook. Remember one thing, beaches are completely dynamic. They keep on changing and they're extremely beautiful every now and then. So this portion of the land is called as beach along the coastal line, which is sandy, pebbly shoreline formed by the deposition of sediments by the waves. The second one is a bay. Now, what is a bay? It's a curved part of the coastal line where the sea enters the land. Now, this is the curved line, and this region is called as a bay over here, and the sea water tries to enter the land in these areas. Then we have the third portion, which is called as the sea, which is the vast body of salt water. So sea has the presence of water which is salty in nature. Then we have the fourth part, which is called as the headland. Headland is nothing but land jutting out into the sea, nothing but the land that is extending itself into the sea here, that is called as headland. Then we have what we call it as sandbar, the fifth portion, which is nothing but a ridge of sand built by waves often parallel to the shore. Now, this is sand deposition that you see here. That sand deposition is called as sandbar. Okay, and this is parallel to the seawater. Then we have what we call it as free end. This is the portion called as the free end here, the open end of sandbar. This is the sand deposition, and this is an open end and continuously eroded and deposited by the sea. And the seventh one is river that carries sediments from land to the sea, helping build beaches and sandbars over there. So these are different parts which we see usually in a beach, and these are different types of shapes that you see along the coastal line. So next time when you visit a beach, try to find these physical features around the beach that whichever you visit. Okay. Moving ahead, let's understand what are the importances of beaches that we have already discussed. So I'm just revising and repeating once again. First and foremost is tourism and recreational activities. Supports fishing as one of the most economic activity. It is sources of lot of shell which is used for construction, craft and other local needs. It acts as natural barrier, saves local communities. It protects the settlements and supports variety of ecosystem as well. And that's the entire concept about the beaches that is formed because of the actions of waves and currents. Moving ahead, let's understand about yet another most important uh, erosion that happens because of waves and currents, and that erosion here is called as the coastal erosion. Coastal erosion occurs when waves, tides, and currents wear away the land along the coast, creating unique landforms. Okay, so what does this mean? It means that a gradual wearing away of coastal land is called as coastal erosion. Means the breaking down of the coastal land is called as coastal erosion. And why does this happen? It happens because waves keep hitting the coast again and again. And slowly the rocks break and the coastal line changes its shape. I'll explain you this through the image that I have generated for you all. Some common landforms of coastal erosion includes cliffs, which is steep rock faces formed as waves undercut the base of the coast, wave-cut platforms, flat areas left behind as cliffs retreat, caves formed when waves erode weak parts of the rock, arches created when caves on outside sides of the headland meet, and stacks isolated pillars of rock left standing after the arcs collapses. So there are different types of landforms that are created because of the erosion that happens on the coastal line. So as waves erode rocks, different landforms are formed. Like for example, sea cliff. What is a sea cliff? It's a steep rock, wave cut platform, then cave, sea arc, and sea stack. These are some of the beautiful landforms that are created because of coastal erosion that generally happens. These landforms are extremely beneficial to human beings. How are they? Let's understand that. These landforms not only shape the coastal landscape but also influence human activities, as some areas are important for tourism while others may need coastal protection to safeguard settlement. So, how are they beneficial? Now, these coastal landforms make the coastal line beautiful, making it as a most important tourist attraction, and many tourists visit them every year. But at the same time, some coastal areas face continuous erosion, and these places need protective measures like sea walls and barriers to protect people and their homes. So, let's understand this concept with the help of the picture. So, what is basically a coastal erosion? Like I've told you, coastal erosion is erosion that happens because of sea waves and currents along the coastal land that is present. And there are different types of physical features that get created. The first one is cliff, a large tableland next to the sea, and this is called as a cliff where the sea wave hits the land. Erosional activity takes place, cutting the portion of a land and creating a steep edges here, and that is called as a sea cliff. Then we have wave cut platforms, rockier bed streams hit by the sea waves, eroded continuously. Then we have sea caves. Okay, sea caves are formed when weak parts of the rock. Now, this is a sea cave which had soft rock, and that soft rock got eroded because of the activity of the waves and ocean currents. And then the next type of landform is arches or arcs, that we call them as. These are created when caves on opposite sides or a headland meet. Now, this is a headland. Okay. Now, in between the headline, this softer rock portion is cut because of the sea wave, creating a kind of arc. Okay, and this is an accessible area, and the soft rock has been completely eroded, which makes it look like a beautiful landscape. Then we have sea stacks, which are nothing but pillars of rock left behind after the arches have been collapsed. Now, how is this related? Now, suppose if now this arc is connected because of this headland. Okay, now if over the period of time, as the erosional activity continues, then this portion might get cut off and these two land masses might get separated, and the arc may not remain any longer. At that point of time, this two portions become what we call them as sea stacks, which are nothing but isolated pillars that have been formed out of the arcs. So how does coastal landforms influence human life, or how is that beneficial? First, like we have discussed, it creates tourism and recreational activities. It promotes settlements and livelihoods. And if we construct proper barriers, then it can be used for coastal protection, and it also maintains environmental balance. So now coastal landforms are nature's creation. They are beautiful, they are resourceful, and they are opportunityful also. But they have to be cared and protected properly with proper, safe, and sustainable future goals and all. So that's about coastal landforms. Now, this is a picture that has been given in your textbook to explain about sea arches and sea stack here. Now, you can see in this two diagram, this is an example of a sea arc, okay, and this is an example of a sea stack. Now, first portion is called as the headland. This is a sea arc, sea stack, high tide, and low tide. So over the period of time, how did they get formed? Now the waves start hitting the headland, because of which the softer rocks start eroding them. Now continuous erosion breaks the caves through and leading to the formation of a sea arc. And over the period of time, now imagine there was a headland here also, and over the period of time, because of extensive erosional activity, the headland got disconnected, leading to the formation of a sea stack here. So that is an isolated land, which we also call it as a sea pillar. And these landform makes coastal lines beautiful and attract a lot of tourism, but they also show how powerful is the work of a sea wave. And that's why sea waves are called as nature sculptors, with and very much important sculptors that we are talking about. So this is about the coastal landforms, which is again yet another important image that has been given to you guys. Okay, and this is the picture which has been given to you all about how waves constantly attack the coast over the time. They carve out amazing landforms along the shoreline. And this is the picture that has been given to you guys about yet another beautiful landform that is created by the sea waves and currents. So this is the entire headland that we are talking about. This is the image of a sea cliff. Then this is the activity of a sea cave. This is a cave that has been formed, and this is the area where the high tide has been hitting. Then this is the shore platform, and this is the zone of the activity of low tide which is happening. So real life example, waves start hitting the headline, creating the cave. So the base gets eroded, that forms the cave first, and then slowly the cliff gets formed, then shore platform gets formed, and then the low tide starts exploding this region. So coastal landforms are constantly changing, and understanding them helps us to protect our coast and live in the nature with the harmony here. Okay, so that's about the entire concept of waves and currents. which is a complete explanation for you all guys according to your class 9 CBSE new syllabus that has been designed by the NCERT. If my video made geography simple and interesting for you, don't forget to like, share, and subscribe to Let's Revise by Vidyashri Kadlibuddi. Learning becomes easy when we understand every sentence one step at a time. Until the next lesson, keep learning, keep revising, and keep succeeding. Bye, everyone. Can a giant block of ice carve mountains, create beautiful valleys, and even provide fresh water to millions of people? What if I told you that glaciers don't just sit quietly on mountains, they actually act like giant bulldozers of nature? In today's video, we will learn how glaciers shape the Earth's surface, what landforms do they create, and why these landforms are so useful for humans. And don't worry, I will explain every single textbook sentence in simple English, exactly the way you need it for your Class 9 CBSE exam. So let's revise without wasting much of your time. So, glacial erosion occurs when glaciers slowly move over the land, carving and shaping the landscape. So, what do these lines mean? First, let's understand what actually a glacier is. A glacier is a huge mass of ice that moves very slowly over the land. Even though it moves slowly, but it is extremely powerful because as it moves, it scrapes rocks, carries soil, and cuts into the land. Just like a bulldozer changes the shape of the ground, a glacier also changes the earth's surface. And this process is basically called as the glacial erosion. Common landforms made from glacial erosion include U-shaped valleys. Formed as glacier widen and deepen river valleys, creeks, bowl-shaped depression at the head of a glacier, artes, sharp ridges between valleys, hanging valleys which occur where the small glaciers meet larger ones, and zodes, deep narrow inlets created when the sea folds glacial valleys. So let's understand these different varieties of landforms that are created by the glacial erosion. Now, because the glacier keeps moving for thousands of years, they create many landforms, and let's understand them one by one. U-shaped valleys are formed as glaciers widen and deeper river valleys. Imagine a river that is narrow and V-shaped. When a glacier moves through it, the ice scrapes both the sides and the bottom. Slowly, the valley between the rocks becomes wider and deeper. Instead of looking like the letter V, it now looks like the letter U, and that is why it is called as U-shaped valley. Creeks are bowl-shaped depressions at the head of a glacier. A creek is a giant bowl carved into the mountain. It forms at the place where a glacier begins, and the moving ice keeps scraping the rocks until a deep bowl-shaped hollow is formed. And this landform is called as a creek. Okay, so let's understand what is artes. Artes are sharp ridges between valleys. Means sometimes glaciers erode both sides of a mountain and the narrow land between them becomes a very sharp edge. This knife-like ridge is called as an artery. Think of it as a sharp edge of a mountain. Then we have hanging valleys. What are hanging valleys? These occur where small glaciers meet larger ones. Like for example, imagine two glaciers flowing together. One glacier is big, the other one is smaller. The bigger glacier cuts much deeper into the land. When the ice melts, the smaller valley remains higher than the main valley. It looks like it is hanging above it. So it is called as a hanging valley, and many waterfalls are found here. Fords are deep, narrow inlets created when the sea folds glacial valleys. Sometimes glacier carve very deep valleys near the sea. After the glacier melts, seawater enters these valleys. This creates a long, narrow water body with steep sides. This beautiful landform is called as a forts. Countries like Norway are famous for forts there. We'll understand these types of landforms through the picture that I have already put into the video. Okay, let's understand what are the importances of these glacial landforms. These landforms are important for humans in several ways. Okay, so let's understand the sentence. the glacial erosion doesn't just create beautiful landforms, but they also are very useful in our day-to-day lives. And let's see how are they basically useful. U-shaped valleys and creeks often provide tourist attractions for trekking, skiing, and mountaineering. See, U-shaped valleys, what are they doing? They're promoting tourism activities, and thousands of tourists visit these places for beautiful sceneries every year. People visit here for variety of reasons, not just to enjoy the nature, but even for trekking purposes, for skiing purposes, and even for mountain climbing purposes. And tourism, as we know, creates a lot of employment opportunities, and it increases the income of the local people. Likewise, forts are used for harbors and fishing, while in some valleys are fertile glacial soil supports. So what are forts? Forts are deep enough for large ships. As we know that forts are found very close to the sea here. Whenever the glacier melts very close to the sea water enters, creating forts there. So forts act as harbors for fishing. So they make excellent natural parking areas for the ships, and many people earn a living through fishing activities in the regions of forts. Similarly, there are certain valleys created by the glacial erosion by glacial deposit of the soil, which is a fertile soil, especially like the alluvial soil, which supports the agricultural activities. Okay, so farming becomes possible in such valleys over here. So this is some important points about the glaciers that I wanted to discuss. Apart from this, glaciers are crucial sources of fresh water, feeding rivers and sustain human population downstream. This is very much important to understand. Glaciers are huge storage structures of fresh water. So during summer, when the glaciers start melting, they provide fresh water through the rivers, and rivers provide drinking water, with water for irrigation, water for industries, and that is why they are called as fresh towers of the world. And they support the human settlement, especially in the downer streams of the landscape where the glaciers are going to be a part of it. So in this slide, I have included the importance of glaciers, especially the landforms that are created by the glaciers. Like for example, it promotes tourism and adventure. They are acting as natural harbors and promote fishing activities. They create agricultural activities. They are the source of fresh water, and they support the human life on the surfaces around wherever they create different types of landforms. Let's understand more about the glacial landforms that are created. Talking about this picture is what has been given in your textbook, which I would like to explain you to all. So when we know that glaciers are basically large ice blocks that move down the hill because of its extreme increase in weight that happens. So in this picture, you can see this is what we call it as glacier, which is a huge ice block. And whenever this ice block moves down the hill, it does erosional activity in this area. It can carry stone, it can carry sand, it can carry silt, and it erodes and deposits in the areas wherever the speed actually decreases. During this process is when it creates different types of what we talk about landforms over here. So a few landforms that has been explained in your textbook through this images. The first one is an artery. Now, what is an RAT? Or the pronunciation goes as RT or RAT. It is a narrow, sharp ridge of rock, okay, formed between two glacial valleys or creeks. Now this is one glacial valley, there is another glacial valley. Erosion happens from both the sides, and because of that a steep or a narrow rock gets formed between two glacial valleys. Such a narrow ridge of rock is called as an RAT or RT over here. Likewise, you have the second land feature that we talk about. The second land feature is a creek. A creek is nothing but a bowl-shaped depression formed at the head of a glacier by erosion. Now, this is the place where you find the presence of a creek. Now, in this image also you can see. It's a bowl-shaped structure. I'm drawing the structure like a bowl only. It is a depression that is created at the head regions of a glacier because of erosional activities that happens again because of glacial only. And the third one is a pass. This is a region very close to the creek is the pass which is present, which is a gap or a saddle between two mountains, often used for mountain crossing. Like I've already explained about a mountain pass through the example of Khyber Pass there. It's a small gap present between two mountains with no presence of any river, or even if a river is present, it's a very small stream that flows, and that pass is used for movement. That is called as a pass over here. And this is a real life image that has been given to you in your textbook. You can see here the presence of arteries, you can see bowl shaped depressions, and you can see the presence of a pass also between the glacial mountains here. Okay, so this is about the glacial, some of the glacial landforms that has been given to you in your textbook in the form of picture. Now let's understand furthermore about this entire concept of glacial landforms. Now talking about the furthermore things is, the first one is a the first one is a hanging valley. Now this is the hanging valley that we are talking about. What is a hanging valley? A hanging valley is that is higher than the valley floor, often with a waterfall. Now this is the region called as hanging valley. Hanging valley means what, which we have already studied. I have explained you while we were going through the paragraph. Let me explain you the concept of a hanging valley once again for you all. Okay, so what is an hanging valley and how it is basically gets formed? Okay, now imagine there are two glaciers that are flowing together. Okay, if I have to draw a diagram, this is one glacial block and this is another glacial block, and both the glaciers are flowing together. One glacier is big and the other glacier is small. The bigger glacier cuts much deep into the land. Now this is a bigger glacier, and this bigger glacier is cutting much deep into the land. And when the ice melts, the smaller valley remains higher than the main valley. Now this is the small valley. Now this is a small valley, and this small valley is looking. This is a small valley. Sorry. Okay, listen. Now these are two glacial landforms. This is the bigger one, this is the smaller one. Now because this is very big, it starts flowing much faster, and while it is flowing, it cuts much deeper ends over here. So the larger ice block creates a lot of erosional activities and goes deeper, because of which this small glacial part what was there, this looks as if it is uh, hanging above the main valley. This is the main valley, and above the main valley there is the presence of this what we call it as the smaller ice block, which has been created as a smaller valley. Now this smaller valley looks as if it is hanging above the other one. That is why it is called as a hanging valley there. Likewise, then we have the second one, which is called as the U-shaped valley. Now we know that whenever glacial erosion takes place, what is considered as a V-shaped valley, that is created by a river between two mountains, because of glacial erosion, the shape of the V-shaped valley converts into U-shape, like you can see over here. And that is why it is called as U-shaped valley. And the third image that has been given to us here is what we call it as glaciers, okay, which is a large ice mass. And fourth part is a glacial ice, which is a frozen water, and this melts usually during the time of extreme amount of heat that generally happens. So this is about the entire concept of glacial landforms that are formed because of glacial erosional activities. There is one yet important feature or a land feature that gets created because of the glacial erosion, and that feature is generally called as moraines or moraines. You can pronounce it anyhow. It is called as moraines or it is called as moraines, as you feel it comfortable. So let's understand about moraines or moraines here. So moraines are landforms created by deposition of rocks, soil and debris carried along and left behind the glaciers. Now, what is this? Let's learn about moraines. As glaciers move, what are they carrying? They're carrying a lot of sediments like rocks, soil, sand, and broken stones and all. And all this mixture of rock, soil, and other debris are called as till. Okay, and when the glacier melts, all this material, the till, is left behind. The heaps formed by the deposited material are called as moraines. I'll show you the picture of a moraine here. They are formed when glacier melts and deposits the material it has eroded from the land. What does this mean? Remember one simple rule here. Moving glacier means whenever the glacier moves, it creates erosional activity. And when the glacier starts melting, it starts the deposition activity. So the deposited material is what we call it as moraines here. Okay, so there are different types of moraines that are usually created by glacial activities. First one is lateral moraines, which form along the sides of glacier, which means that when rocks collect on both the sides of glacier, they form lateral moraines. Think of them as side walls of deposited rocks. I'll show you the picture of this. The second one is terminal moraines found at the end of glaciers, marking their furthest advance, which means when a glacier stops moving forward and melts, all the rocks collect at its front, and that is called as terminal moraine. It tells us that this is the last point of the glacier once it is reached. And the last one is medial moraine, formed when two glaciers meet and their lateral moraines join in the middle. Now, what does this mean? Imagine two glaciers flowing side by side. When they join together, the rocks form their inner sides combine, and this forms a long strip of rocks in the center, which is called as a medial moraine. Now, what are the importances of moraines? Let's understand those points. Okay, so moraines are important for humans because they often create fertile soil for agriculture and can form natural dams and lakes used for water supply, irrigation, and sometimes hydroelectric power also. Now, moraines are also extremely important for human survival. How is that possible? Let's understand that. Now, glaciers usually carry sediments. Okay. Now, these sediments, when they get deposited along the lines of glacier, in front of glacier, or in between glaciers, we call them as moraines. But they are not just carrying rocks, they're carrying sand, they're carrying silt, they're carrying soil over here. And this soil is extremely fertile and it is extremely useful for growing crops by the farmer. So it promotes human settlement. Along with that, they sometimes block the water also, especially the flow of water, which creates natural lakes, and that lakes provide water for drinking, water for irrigation, and in some places it is also used for generating hydroelectric power. So these are the benefits of having moraines, a physical feature created by the glacial erosion, but yet extremely important for human survival and existence. So let's understand the concepts of moraine through the pictures here. Okay. So in this picture, we are going to discuss about different types of moraines that we have discussed previously in the paragraph. The first one is a lateral moraine. If I have to discuss with you guys, the first one is a lateral moraine. Here you can see, now this is the picture of a glacier. This is a glacier. This is also one glacier. Now along the side of glacier, there is deposition of rock, sand, and soil that is carried by the glacier. Okay, now this deposition has happened at the other sides of the glacier, this is called as the lateral deposition. So as it is happening on the sides of the glacier, we generally call it as lateral glacier or lateral moraine, sorry. Then the second one is terminal moraine. Terminal moraine tells us that this is the end point of a glacier. Now you can see this deposition is called as the terminal moraine. This is the place where the deposition has ended, which means that this is the extreme last part of the glacier, the furthest point of a glacier here. And such a deposition of a debris carried by the glacier, which marks the end of the glacier, is called as the terminal moraine. And the third one is medial moraine or middle moraine, which is nothing but, as I've told you, as we know that it is a debris deposition in the middle between the two glaciers. So this is Glacier A and this is Glacier B. In between them, whatever debris they have carried, that gets deposited. And such a deposition which happens in the middle of both the glaciers is called as medial moraine. So these are the three types of moraines that we generally see, which is a glacial deposition landform that has been formed by leftovers of the glaciers which shape the land, and they are extremely important for human survival too. Moving ahead with the next slide, in this one, we are discussing about the image that has been given to you guys in your textbook, okay, which also again furthermore explains the same concept of different types of moraines that we generally have studied in the previous slide. Now here you can see in your textbook, this is the image that has been given of the moraines and with the label parts. The first one is lateral moraine, which is the deposition seen at the other ends of the glacier. Second one is the glacier movement. Third one is the middle moraine. Fourth one is again the glacier that we see here. Fifth one is the terminal moraine. And sixth one is the river that starts flowing. And this is the real life example of a glacier with different types of moraine that we generally see here in the picture. And this is the picture that has been given to you in your textbook, guys. So moving ahead, discussing about the importances of moraine, and this is a very important point that we have to concentrate on. Like we know, moraine is nothing but the deposition of the debris carried by the glacier. And as it carries rocks, sand, and silt, the soil is extremely fertile, because of which it is extremely good for agricultural activities. Now you can see this is the debris deposited by a glacial movement, which has created a natural dam or a natural lake, which acts as a water source, and this can be used for drinking purpose, it can be used for irrigation purpose, and variety of other uses also. Sometimes if a dam is constructed along the lines of this moraine, then it can be used for water supplying, water irrigation facilities, and most importantly it can be used for generating hydroelectric power as well. So these are the points of importances of moraines that I wanted to discuss with you all, guys, which are mentioned in your textbook. So I'm completely going as by the textbook over here. Moving ahead with yet important activity which promotes critical thinking and reasoning and researching to you guys is an activity called as Think About It, where you are supposed to think about a flood that had taken place in a small village called as Chamoli village in the state of Uttarakhand in the year 2021 of February. Okay, so you have been given a piece of information and you have been asked a question over here. So let's discuss this activity of Think About It. A devastating flood struck the Chamoli district in Uttarakhand in February 2021, in which many people and their livestock lost their lives. There was severe damage to building, roads, bridges, and hydel projects, and connectivity to villages was adversely affected. What does this paragraph tell us about the flood? So, in the place called as Chamoli district of Uttarakhand, there was a sudden flood that happened in the month of February 2021, because of which there was a lot of damage that happened, not just to the life of people but even the livestock that they generally had. Like, for example, there was damage to the building, the roads were damaged, the bridges were damaged, even the dams or the hydel power projects that were there, they also got damaged, and there was no connectivity to a nearby village, and that adversely affected the people stuck in the Chamoli district of Uttarakhand. Now, based on the information given to you, there has been a question that is asked, and the question is, can you find out the reason that led to the sudden and unexpected flood? Now you have to understand what is the reason. We have to find what could be the reason behind the flood that occurred in the Chamoli district of Uttarakhand in the month of February 2021. So let's find out the answers to the question. You can copy down the same things or you can research and add extra points to this answer also. Like, for example, let's understand the reason for the sudden and unexpected flood here. The first one is the Chamoli flood was caused by combination of natural and human related factors. So if we talk about the reason and the cause of the flood, it is not only the natural forces that created the flood, it was even human related also. So what are some of the main reasons? I've listed them down. Let's discuss them. The first one is avalanche and glacier break, which means a large mass of snow, ice and rock broke off from the Nanda Devi glacier. And Nanda Devi glacier is one of the most important glacier for Rishi Ganga river here. Second reason is formation and burst of ice rock moraine dam. Now this is yet another reason. The debris blocked the river and created a temporary dam. Within a short time, this dam burst and released a huge volume of water downstream. So there was a large mass of snow and ice that broke down, and with a lot of rock, and that rock blocked the dam of moraine. Okay, and because of which the excessive flow of water could not be controlled by the moraine dam, and the dam also broke off. Along with that, there was heavy rainfall and snow melt that happened. So unseasonal heavy rainfall, rapid snow melt due to rising temperature, increased water flow in the rivers, and glacial melt. Fourth reason is human activities in this region. What is that? Construction of hydel projects, road widening and blasting weakened slopes and river banks, increasing the impact of flood. Okay, so hydel project was not necessary. Hydel project you created for generating hydel electricity, but then the dam had already a great reservoir of water, excessive flow of water. The dam could not hold the water back, because of which the dam had to burst open. And the fifth reason is steep terrain and loose debris. The steep mountain slopes of the Himalayas and loose rocks allowed the flood water and debris to move at a very high speed, causing maximum destruction. So, the reason behind the Chamoli flood was the result of natural disaster triggered by glacial break and moraine dam burst, intensified by heavy rainfall and human activities in fragile economic system or mountain ecosystem. Because of this, what was the impact of the flood? The impact was flood was loss of many human lives and livestock, severe damage to the infrastructure, damage to the hydel power project, and disruption of connectivity to many villages, because of which you could not save life of people also. So that is the entire topic that I wanted to discuss with you guys today in this video of it. So who knew that something as cold as ice could create such amazing landforms and even support human life? If this explanation made glaciers easy to understand, then don't keep it to yourself. Share this video with your classmates to everyone can so that they can revise together. And if you want more chapter wise explanation in simple English for the new CBSE class social sciences textbook, subscribe to my channel, because here we don't just study, we learn, revise, and succeed. See you in my next video. Bye, everyone. Have you ever wondered how sand in a desert can actually carve huge rocks into strange shapes? Or how tiny grains of sand can build giant sand hills that keep changing their place? Sounds unbelievable, right? Well, today we are going to discover the amazing power of wind, one of nature's most powerful artists. By the end of this video, you will understand how wind erodes land, the landform it creates, different types of sand dunes, and why are they important for humans. All in super easy English. So let's revise together. Wind erosion occurs when strong winds pick up and carry away loose particles of sand and soil, gradually shaping the landscape. What does this mean? It means that wind erosion or erosion by wind happens when fast moving winds lift loose sand and soil from the ground and carry them to another place. Over many years, this slowly changes the shape of the land. This process creates several distinct landforms such as yardangs, which are a streamlined rock ridges carved by the winds, ventifacts, which are rocks polished and shaped by sandblasting, deflatation, hollows or blowouts, shallow depression formed where the loose material is removed, and desert pavements, flat surfaces left behind after finer particles are blown away. What are these? These are different types of landforms that are actually created by wind erosion. Okay, the process of wind erosion creates these different types of landforms like yardangs, ventifacts, deflation hollows, blowouts, or desert pavements. Which means that as wind keeps blowing, it forms different types of landforms. So let's understand these landforms one by one. What is an yardang? Yardang is a long, narrow rock ridge. Strong winds carry sand, slowly wearing away the softer rock, leaving behind these smooth, streamlined ridges. Imagine the wind acting like a sandpaper on rocks for thousands of years. Likewise, if we talk about ventifacts are rocks polished and shaped by sandblasting. Now, what is sandblasting? We'll understand it. Ventifacts are rocks that become smooth and shiny because the wind-driven sand keeps hitting them. This natural process is called as sandblasting. It's like the nature is polishing the rocks. Then we talk about deflation hollows or blowouts. Sometimes wind removes loose sand and soil from one place. This leaves behind a shallow pit or hollow called a deflation hollow or blowout. Think of it as the wind digging a small bowl-shaped hole in the ground. Likewise, we have the next landform called as desert pavements, which are flat surfaces left behind after finer particles are blown away, which means that when the wind carries away tiny sand and dust particles, only large stones remain behind. These stones cover the ground like a natural stone floor, which is called as desert pavement. Moving ahead, understanding the importances of wind erosion and the landforms that are created because of the wind erosion. Now, these landforms are important for humans as they influence settlement patterns and agriculture in arid regions. And ventifacts and yardangs attract tourists and geologists interested in unique desert landscapes. So, if you have to understand what are the benefits of this, remember that in certain areas, the landforms helps people to grow crops in dry desert regions, one thing. Second, it helps people to build their homes and helps them to settle down. Along with that, special land features like yardangs and ventifacts attracts a lot of tourists because of its natural beauty. Along with that, it also calls for a lot of geologists and scientists to understand and study the desert landscape and understand how natural forces have created beautiful landforms, especially the wind has created beautiful landforms over the period of time. Let's understand this topic with the help of picture that I have created for you guys. Okay. So in this one, we are going to understand what actually is wind erosion. Fine. So wind erosion is when strong winds pick up and carry away loose particle of sand and soil, gradually shaping the landscape. Now we know that desert region experiences a lot of wind and there are no natural barriers to cut off the speed of the wind. In such times, what happens is strong wind blows over dry, loose soil and sand. Now in desert, the soil that is there, it is extremely dry soil, absence of water, absence of vegetation. Because it is dry, it is loose soil and it is called as sandy soil. Now, whenever wind blows over this soil, what happens is because it is dry, the wind carries the soil along with it. So, tiny particles of sand and soil are lifted and transported by the wind, which means that and now you can see in this picture here, as the wind is blowing, it is carrying tiny particles of soil and sand with it. Okay, and now this sand and soil from this place is going to be deposited in some other place, which is called as deflation and abrasion. Now particles are carried to another place and deposited when the wind slows down. Now whatever the wind is carrying, these tiny particles will be deposited in a place when the speed of the wind will decrease. And over the time, this process shapes the surface and creates different types of unique landforms. So when the wind moves the tiny particles of soil from one place and carries it to another place, it creates different types of landforms. That is why we call that wind erosion reshapes the earth's surface from valuable landforms and also helps in natural recycling of materials. So whenever erosion occurs because of wind, we call it as wind erosion, and it also creates different varieties of landscapes, and wind erosion is commonly found in the desert regions. Okay, moving ahead, talking about the different types of landforms that get created because of wind erosion. Fine. So, like all other agents of gradation, wind also does the same thing: erosion, transportation, and deposition. And because of which different varieties of landforms are generally created. The first one is we are going to talk about is yardungs. Okay. What are yardungs? This rock ridges, what you see in the picture, are called as yardungs. Okay, they are rock ridges and they are carved by winds over millions of years. Okay, and these are elongated rock ridges in the direction of the wind. Now what has happened is the wind has cut across the surfaces of these rocks, creating erosion, transporting and depositing it in elsewhere areas. So when elevated rock structures are found in the deserts, which appear in the cut forms, and in between them there is presence of sand valleys, we call them as yardungs. Likewise, we have the second one, and the second one is what we call it as ventifacts. Now you can see the image of a rock that has been put up over here. Now this rock is extremely shiny, but why is it shining? Because this rock appears that someone has polished its entire surface. But here, the one who has polished the entire surface of this rock is none other than the wind, which is carrying the sand along with it. And that sand, which keeps on hitting the surface of this rock over the period of time, acts like a sandpaper, and it flattens the surface, sharps the edges, and makes the surface shiny and smoother to appear, and this is called as ventifact. Likewise, the third one is hollows or blowouts, which are deflatations. Nothing but you can see in certain deserts, you can find such type of structures, bowl-like structures or depressions, when loose material of soil is removed by the wind. It creates a hollow structure, and these hollow structures are called as blowouts or deflatation hollows. Moving ahead, we have the last uh, landform that is created by wind erosion, which is called as desert pavements. Pavements are nothing but land structures or a kind of a road or pavement of tiles that is created. But in desert, there is nobody paving anything here. It is the wind that is exposing, as if somebody has lined up the rocks in the desert. Now in this picture you can see there are tiny particles of rocks and huge rocks that look as if they have been laid by some human beings, but these are not done by any human beings. This is by the wind. How are these structures created? Let's understand that. So, this is usually seen in the flat surfaces, especially in the deserts, which looks like as if somebody has constructed a road. With that is why that it is called as desert pavements here. Now, what happens here? Now, when wind blows across this land, it carries tiny particles of sand and soil. And what remains behind there are these rocks, which are big and they are pebble in structure or gravel in nature, and when the sand is removed, these structures of stone become visible, and from far if you look, it feels like somebody has laid down the road made up of stones and pebbles, but in actual sense it is the wind that is removing the tiny particles of soil and sand present between these rocks. That is why this beautiful structure of land is created. So these are different types of landforms that is created because of the wind erosional activities. Moving ahead, in the next slide, we study about the in the next slide, we study about the yardungs. This is the image which has been given to you in your textbooks. Okay. Now, when we talk about yardung, what are they? These are rock ridges. Now, this is the yardung which we are talking about here. And this is carved by wind erosion in arid and semi-arid regions. And this is the real picture that you can see. Now, the first portion is wind. So, what is this? Strong winds carry sand and dust blow against the rock surfaces. Now, the wind is moving. It can move in between here or it can move over like this also. And whenever it is moving, The sand and the dust is rubbing against this rock surface. Okay. Then what is the second structure? The second structure talks about erosion direction. So wind usually moves either in this direction or in this direction. And whenever it moves, it creates erosional activities over the rock surface from one side and shapes it like streamlined ridges. So the wind rubs against the rock surface, creating a ridge over here. And then we have the third portion, and the third portion is called as the hard rock. So this surface is called as the hard rock. More resistance rock remains, forming the ridges. This rock is not a soft rock which is going to be easily broken. It's a hard rock. That is why the wind is rubbing itself against it like a sandpaper and creating the structure. And then we have the fourth one, which is called as the soft rock. This is the region where it is called as soft rock. Now, this soft rock erodes very faster, creating troughs, creating gaps between the ridges. Okay. And fifth one is again the hard rock, like I have told you, which has remained behind as a ridge over there. So over continuous wind erosion shapes these ridges into narrow, elongated forms with gentle slope on windward side and steeper slope on the leeward side. So windward side is nothing but the side which faces the wind, and leeward side is the side which doesn't face the wind at all. Okay, so there is a gentle slope in this area and there is a steeper slope in this area. This is the leeward side and this is the windward side here. This is the picture of Yatang in your textbook which has been given. Moving ahead, talking about the depletion hollow, which is a place where you can find the presence of oasis also. So what is a depletion hollow? It is formed when loose soil of dust and sand is removed, exposing the water table, creating an oasis. And this is the picture that has been given to you. The first portion is talking about the wind, which moves in and out, creating a direction which removes the loose sand and dust away. Now, this is an example of oasis. Also, a depression or a hollow is formed in the ground, like I've shown you the picture. Third, blown away sand or dust are removed by the wind, which we know. And fourth one is water table. This is the water accumulation that we see here, which is nothing but removal of sand exposes the water table. Water collects in the hollow, forming an oasis. So remember the process. Wind erosion removes loose material. Ground surface lowers. Water table comes near the surface. Water gets collected. Vegetation grows and oasis is formed. So before the oasis is formed, it's a area covered by loose soil. Because of the blowing of wind, the loose soil is completely removed. The water surface gets exposed, vegetation grows, and that is a source of fresh water for many people in the desert region, which we generally call it as oasis. And not necessarily oasis can be a source of salt water as well. Okay, so moving further, talking about one of the most important structure created by the wind erosion, which are called as dunes or dunes. Okay, now let's understand more about the concept of dunes, which are one of the most important physical features created because of wind erosion. So what are dunes? Dunes are hills or ridges of sand formed by the wind in desert areas or along sandy coast. Sand dunes are nothing but they are piles of sand, and these hills are created by wind, and they're commonly seen in deserts or along the coastal regions of the sea. When we talk about types of dunes, there are several types of dunes, including Bakken dunes, which are crescent shaped and form in areas with limited sand and single wind direction. Second one is longitudinal dunes, which are long ridges formed parallel to the prevailing wind. Third one is star dunes, which have multiple arms and form where winds come from different direction. And fourth one is parabolic dunes, which are U-shaped dunes often stabilized by vegetation. Now, talking about different types of dunes, not all sand dunes look the same. Depending on the wind direction and the amount of sand available, there are nearly types of sand dunes that are mentioned in your textbook. The first one that we talk about is Barkan dunes or Bachan dunes, which are in the shape of a moon, crescent shaped moon, like this. Okay. And they form where there is only one small amount of sand and the wind mostly blows in only one direction. That's the condition. The amount of small sand is less and the direction of wind is only one direction, no multiple directions at all. The second one is, okay, the second one is longitudinal dunes, which means they are the dunes which are long and narrow, and they usually develop in the same direction as the wind blows. If the wind is blowing in this direction, then the longitudinal dunes also blow in the same direction. Then we have the third one, which is called as the star dunes. And star dunes are nothing but the dunes which appear in the form of star with with number of arms. Why does this happen? Because the there are wind which are blowing from different directions frequently, because of which the dune appears in the star shape. And the fourth one is parabolic dunes, and the shape of this dune is U-shaped. Okay, what are these? These are the one which plants grow on them and hold the sand in place, preventing the wind from blowing it away easily. That is why the shape of the dunes is U-shaped here. Okay, it is usually shaped or backed by the vegetation that grows over there. Now, how are these dunes very much useful for human beings? Dunes act as natural barriers against desertification and wind erosion. Now, this is a very much important point to understand. Along with that, it provides area for tourism and adventure sports also. Now, what does this mean? It means that they help in stop spreading of deserts and also reduce the strong winds, and they are very popular among people for activities like camel safaris, sandboarding, and desert tourism. Similarly, in certain coastal regions, they protect settlements from strong winds and waves too. Now, this is very much important. When we talk about the coastal regions, if there are sand dunes over there, they act like natural walls and they protect the villages and towns from strong winds as well as powerful waves. In addition to that, sand from dunes is sometimes used for construction purposes also. Now, this is yet another important thing which we should be understanding. The sand from some dunes can also be used in construction work, such as making buildings, roads where it is suitable and legally permitted. But in actual sense, not all the sand dunes are completely used for the purpose of construction activities. It's very limited because of its characteristics that it generally holds. Moving further, let's understand this concept of dunes through the pictures that I just wanted to show you. Now, in this one, we are going to study about types of dunes and how they are basically formed. So, what are dunes? Dunes are small hills formed by the uh, sand carried by the wind in desert region, and they usually keep on changing their shape and their places also. Now, when we talk about types of dunes, we usually have four types of dunes. The first one is Barkan dunes or Bachan dunes. You can see the shape is like crescent moon. Okay, and the direction of wind is only in one direction. Similarly, we have the second one, which is called as longitudinal dunes. These are the dunes that we are talking about, and they prevail along the parallel lines of the wind. If the wind is blowing in this direction, then the longitudinal dunes are also formed in the same direction. Then we have the fifth one, which is called as star dunes. You can see how the wind is coming from all the directions, and the shape of the sand dune also appears like a star. And the fifth one is parabolic dunes, which are backed by or stabilized by the vegetation or forest that grows. And the shape of this dune is actually U-shaped here. How do these dunes get formed? Let's understand the process. First one, like we have already studied, strong winds carries the loose sand in deserts. Sand grains are lifted, they are transported and carried by the wind by saltation and surface creep. Then, when this wind slows down, sand grains are deposited. Continuous deposition at the same place keeps on building the hills or ridges, which we call them as dunes. And over the time, the wind shapes and reshapes dune, creating different types based on wind strength, direction, and the sand amount of sand supply available in those areas. So, this is about types of dunes and how dunes are generally formed. So, this is yet some more information about the dunes that I just want to show you. In this also we see transverse dunes are nothing but longitudinal dunes, Barkan dunes, and then we have star-shaped dunes that are present
here which have been given, which we have already discussed in my previous slides. Moving ahead to understand what are the importances of dunes for human beings. First of all, we know that it acts as natural barriers against desertification and wind erosion. Second, provides tourism and adventurous sports. It protects the settlements and are also used for construction purposes. So these are some benefits of the sand dunes for human beings and their survival. Okay. So nature doesn't always need earthquakes or volcanoes to change the earth. Sometimes something as simple as the wind can slowly carve rocks, build giant sand dunes, and reshape entire desert over thousands of years. That's the incredible power of wind. If my explanation helped you understand the chapter in easy way, don't forget to like, share, and subscribe to my channel. Keep learning, keep revising, and remember, every small revision today leads to big success tomorrow. See you in my next video. Happy learning, everyone. Can a river flow underground? And can water create giant caves without anyone digging them? Believe it or not, the answer to this question is definitely a yes. Hidden beneath the Earth's surface is yet another most important agent of gradation that is shaping the Earth's surface, the underground water, which is constantly shaping our planet. Let's explore this amazing gradation, agent of gradation, and amazing landforms which are created by it in a simple and interesting way. Underground water, especially in areas of limestone or soluble rocks, creates unique landforms called as karst or cartography through chemical weathering or erosion. Now, what is this and how does underground water create different types of landforms and shape the Earth's surface? Okay, now going by the textbook sentence that has been given to all of us, it means that underground water is water which is flowing below the Earth's surface or which is seeping into the Earth's surface. Now, how does it move into the Earth's surface? It moves through the cracks and spaces in the rocks. But there are certain rocks, especially like limestone, which dissolve easily in the water. Now, whenever rainwater becomes slightly acidic after mixing with carbon dioxide in the air, the acidic water slowly dissolves the limestone over thousands of years. And this process is called as chemical weathering. And what is the chemical here? The acidic nature of rainwater. And how does rainwater become acidic? Because of mixing of carbon and carbon dioxide from the air into the rainwater. At the same time, this water carries away the dissolved rock, which is called as the process of erosion. Together, these processes create a special landscape, which we call it as cart topography. And cart topography simply means a landscape formed by the underground water inside the Earth's surface. Common landforms of underground water include caves, which are hollow spaces formed as acidic water dissolves the rock, then stalactites, acical shaped formations hanging from the ceiling of caves, stalagmites, formation rising from the floor of caves, sinkholes or dolmens, depressions formed when the ground collapses into the underground cavity, and underground rivers which flow through cave systems. So there are different varieties of landforms that are commonly formed by underground waters, which includes cave. Now let's understand what actually a cave is. A cave is a large hollow space inside the rocks. Underground water slowly dissolves limestone. Small cracks become wider and bigger, and after many years, these cracks turn into huge caves. And some caves are so large that people can even walk inside them. Similarly, yet another important landform formed by the underground water is stalactites, which are icicle shaped formations hanging from the ceiling of caves, which is nothing but water dripping from the cave roof contains dissolved minerals. As each drop falls, it leaves behind tiny minerals deposit. These deposits slowly grow downward. These hanging formations are called as stalactites. A simple trick to remember is stalactites hang tight to the ceiling. Okay. Then are the next one, which is called as stalagmites.
Stalagmites are rising from the floor of the caves. The water drops falls onto the cave floor. More minerals are left behind. These minerals slowly build upward. These upward growings formations are called as stalagmites. A simple trick to remember stalagmites is might stalagmite reach the ceiling someday. Sometimes a stalactite and stalagmite join together to form a pillar as well. Yet another important landform formed is called as sinkhole or dolines, which are depressions formed when the ground collapses into an underground cavity. Like, for example, underground water keeps dissolving rocks below the surface. Large, empty spaces are formed underground. When the roof of this empty space becomes weak, it collapses. This creates a deep hole on the ground. That hole is called as sinkhole or doline. Some sinkholes are small while others are very large. Okay. Underground rivers. This is yet another important thing that is found in the cave system. Not all rivers flow on the earth's surface. Some rivers flow inside caves below the ground, and these are called as underground rivers. They continue dissolving rocks and making caves even bigger. So these are different types of landforms about whose pictures I'll be showing you in my next slides. Now let us understand what are the benefits and or how these landforms are beneficial for human beings. Okay, these landforms are important for humans because caves and underground rivers provide sources of fresh water, tourism opportunities, and in some cases cultural and religious significance. Now to understand this, now these landforms, whether it is caves, whether it is stalactites, or whether it is stalagmites or sinkholes or underground rivers, they're very much useful for human beings. Like, for example, underground rivers provide fresh water for drinking and farming. Likewise, beautiful caves are attractions for many tourists, and tourist helps local people earn good amount of income. Likewise, in certain caves, you can see there are presence of temples or they are considered as religious places. And many caves are also historically extremely important also, right? Similarly, when we talk about the next landform, stalagmites and stalactites also attract geologists and adventurers, making them valuable for both the study and recreation. So, stalagmites and stalactites are mineral depositions that come along with the underground water. That is why it is an important place for scientific research, especially for the geologists. And apart from that, it is a major attraction for the adventurers also. So here, stalagmites and stalactites, which are the most important landforms formed under the ground, are valuable for the study also and for recreational activities also, because it helps scientists to learn about the past climates and Earth's history. Adventure lovers enjoy exploring caves, so these landforms are both important for learning as well as tourism purposes too. Now let's understand these entire concept of underground water and the landforms formed through the slides that I generally want to show you guys. Now in this slide, we are going to study about how different landforms are formed. Okay. Then we are going to study about different types of landforms, and I have shared the pictures to you guys also. Now, understanding the first thing, okay, Ka- topography is nothing but the landforms created by underground water. Okay, especially in the areas when there is presence of limestone or there are presence of soluble rocks, and when water acts upon it, the rocks dissolve, creating unique landforms, and those landforms are called as scarp topography. And here, the topography is mainly formed because of chemical weathering and erosional activities. Okay. Now, this is an overall picture of different types of landforms that you can see together. Okay. The first one is the cave structure. Second one is a sinkhole. Then you see a solution pan. You can see the presence of a river valley. Then you can see the presence of stalactites and stalagmites. These are different types of topography created by underground water. How does this happen? As I've told you, whenever the rainwater becomes acidic, especially when it absorbs carbon dioxide, it starts moving through the cracks of rocks, especially in the areas where there is limestone deposition. Now, the acidic nature of the rainwater starts dissolving the limestone and enlarges the cracks, forming caves and underground channels. And over the time, this creates different varieties of underground landforms. Fine. So, what are these different types of landforms? First, let's understand what is the solution pan. Shallow depressions formed when the surface water dissolves the limestone. Now, here you can see this is a shallow depression, not a big depression, a shallow depression, because the water is dissolving the limestone in those areas. What is a sinkhole? A depression formed when the roof of an underground cavity collapses. You can see here. What is a cave? Large underground openings formed by the continuous dissolving of limestone. Stalactite, acidical shaped deposits that hang from the roof. Now, these are stalactites, and stalagmites are cone shaped deposits that rise from the floor towards the upper surface of the cave. Let's understand these different forms of landforms created by the underground. Now, solution pan. Now, this is a clear picture you can see here. Solution pan means what? Shallow, saucer shaped depression formed by the dissolution of limestone. Now, here the underground water, which is or the rainwater that is slightly acidic in nature, slowly starts dissolving the limestone in these areas. So, a shallow saucer like structure is formed, which is called as a solution pan. That means here the limestone is started dissolving slowly, which can later on lead to the formation of different type of structure. Then we have a sinkhole. Now you can see the sinkhole, which is also called as doline. It is a bowl shaped, which is deeper. It has a depression, and here there is a collapse of underground cavity, which means below the sinkhole there is some collapse of the rock that has happened, because of which a sinkhole has been created. Third one is cave, underground opening and passage formed by the dissolution of limestone. So this is the picture of a cave inside the rock. Then fourth one is stalactites. What are these? Now, as we know that whenever the rainwater starts moving deep into the underground through the cracks, it starts dissolving the limestone in these regions. Okay. Now that limestone, that water carries minerals along with it. And when the water starts dripping down inside the structure, it leaves behind mineral deposition, which are hanging from the roof surface of that particular cave. And that is called as stalactites. Moving ahead, we have staglamites. Staglamites are the same rainwater which carries the mineral deposits and puts it on the cave floor and gives a rising structure from the floor to the ceiling of the cave is called as staglamite. And here the mineral deposit is more in comparison to this. And whenever a staglamite and a stalactite combine together, they form a structure which we call it as pillar. And these are mineral pillars. And one more most important structure that is formed because of uh, the underground water or the rainwater, which is acidic nature, is called as the karst valley or cart valley, which is flat flowed valleys with steep sides formed by the interlink of sinkholes, which is not given in your textbook, so you don't need to be worried about this entire last one. Now, moving ahead to understand how are these things formed, what is the process of formation of a cart topography? As we know, there are two important conditions required here. One is acidic form of rain, and second one is the presence of limestone or any kind of soluble rock. Now, because there is chemical reaction happening, we call this entire weathering process as chemical weathering, and then it is carried forward by the water, which we call it as erosion, and then deposition and all takes place. Now, let's understand what is the process of underground erosion. First thing, the first and the most important thing is rainwater should be slightly acidic. And how does it become acidic? By absorbing the carbon dioxide from air and soil, it becomes slightly acidic. And when this rain, which is acidic in nature, falls on the limestone, which is a soluble rock, what happens is it starts dissolving the rock here. Now, that water tries to enter the rock through cracks and joints, and acid water seeps down over here. This acidic water seeps into the cracks and joints of the limestone, which it goes on dissolving as it passes through that cracks and joints. Now, slowly it starts dissolving the rock. The acidic water dissolves the rock by enlarging the cracks. You can see here the cracks are small, cracks are widened, and again the crack is more widened because the rock has started dissolving. Now, as the rock starts dissolving, it forms hollow structures, which we call them as caves and underground channels. So, over a long period of time, larger openings are formed, which we call them as caves, and presence of water and flow of water inside the cave leads to the formation of underground rivers. And within that, there can be the presence of stalactites or stalagmites. What are stalactites? Mineral hangings from the roof surface towards the floor of the cave, and stalagmites are the opposite, from the surface of the cave to the roof surface, which are nothing but mineral deposits along with the rainwater which has come down. Now, many a times this entire structure of cave can lead to the formation of a sinkhole or a dolite. What happens here is sometimes the ground above the underground cavities collapses, forming sinkholes or dolites. Now, see here, the rainwater, which was acidic in nature, seeping under the limestone, has created a cave. Now, this is a hollow structure above which there is presence of rock, and sometimes that rock may collapse down, creating a hole, and that hole is called as a sinkhole over here. So, in short, remember, acidic rainwater dissolves limestone, enlarges cracks, forms caves with stalagmites, stalagmites, sinkholes, and underground rivers, and all together, the landforms that are created because of the underground water, we call that entire thing as what? We call it as cart topography. So that is about the process of formation of what we talk about as landforms of underground water. So this slide shows you about different types of images of different types of landforms formed because of underground water. The first one is caves, stalactites, stalagmites, sinkholes, and underground rivers. I hope the pictures are very clear in your minds. Remember this very clearly. Moving ahead, as we discuss about the importances of these land holes, the first one is, if we talk about caves specifically, provide shelter and natural habitat. Along with that, it is a very important tourism and adventurous activities, and many caves are associated with culture, historic, and religious significance too. If we talk about underground rivers that are found inside the cave, they are fresh and clean source of water and supports ecosystem inside the cave by attracting tourists as well as researchers. If we move ahead to the next one, when we talk about stalactites and stalagmites, they are very much important for geologists, scientists, and adventurers, and helps in studying the environment and climate of the past and the mineral deposition. Moving ahead, if we talk about sinkholes, they indicate whether underground water is found or no, and how it is getting recharged, and what is the process of storing the water inside the cave well. If we talk about the overall significance, water source, tourism, adventure activity, cultural and religious significance, helps in study, scientific research, as well as educational activities. So this is the slide that explains us about the importances of cast or cart topography. Fine. So now you know that underground water is much more powerful than it looks. Even though we cannot always see it, it quietly creates caves, underground rivers, sinkholes, and beautiful caves formation over thousands of years. If my explanation made the concept easy to understand, don't forget to like, share, and subscribe to my channel. Keep learning, keep revising, and I will see you in my next video for class 9 geography. Happy learning until then. Bye everyone. Did you know that the same mountains that give us beautiful views can also cause deadly landslides? Or that melting glaciers can suddenly create huge floods? Nature is amazing, but sometimes it can also be dangerous. Hello everyone, welcome back to Let's Revise by Vidyashri Kadlibuddi, where we learn, revise and succeed. And in today's video, we are going to learn one of the most interesting topics and last topic of your second chapter, Shaping of the Earth's Surface, from CBSE Class 9 Geography, Landforms and Disasters. In today's video, we will understand how different landforms are connected to natural disasters, why these disasters happen, which places are most affected, how can we reduce their impact, and we will also look at some real life examples from India. So stay with me till the end because this video is important for your exams as well as for understanding the world around us. So let's begin. Talking about different types of landforms and disasters. There are several disasters associated with different landforms that commonly occur around us, and four such disasters are presented below. The very first one is landslides, which occur when rocks, soil, or debris move down a slope due to the gravity. These are commonly found occurring in hilly and mountainous regions, especially during heavy rainfall or earthquakes. They can block roads, destroy houses, and cause loss of life too. Talking about the second disaster is avalanches, where we see what is an actual example of an avalanche: massive snow or ice falling rapidly down a mountain slope. This is commonly found in high mountainous regions, especially during heavy snowfall or sudden temperature rise. These can bury people, damage property, and even block valleys too. And the third type of natural disaster that we see associated with landform is strong wind, dust storms, which are nothing but strong winds lift and carry dust and send it into the air. This is commonly seen in deserts where dry sand is found, especially in arid regions. It reduces visibility, affect the health, and damage crops and property. And the fourth one that we are going to discuss is about GLOFs, which is nothing but glacial lake outburst floods, which are nothing but sudden release of water from glacial lakes due to ice or moraine dam failure, common in high mountain and glacier regions, and it causes severe flooding downstream, damaging lives and property and infrastructure. So remember, landforms make our earth beautiful and resourceful, but they can also bring disasters. Understanding them helps us prepare, protect, and build a safer future. Okay, so moving ahead, we are going to study about each of these natural disasters likewise, and then we are going to focus on not just how they occur, but we are going to reflect on the concept of what are certain mitigation measures that we can take and recent examples that have where these have occurred, especially in context to India. So in your textbook you can see they have given you a picture and they have given you some information on landslide, right? Now on the basis of the information given, you are supposed to fill in the blanks that has been given in the textbook, where it includes you have to write down about the areas that are affected because of that natural disaster, what are certain mitigation measures that we can uh, adopt, and then you have to fill in the information about recent examples. So in these slides I have done the entire homework for you guys so that you don't have to worry much about it. If you find my answers easy and convenient, mention them. Otherwise you can note down your own points also, which is not a worry at all. So let's understand the very first um, natural disaster that we are going to talk about. Okay, so landslides are caused by combination of natural and human factors that make slopes unstable. Heavy and continuous rainfall is one of the main natural causes, as water steeps into the soil and rocks, increasing their weight and reducing friction. Earthquakes, volcanic eruptions can also trigger landslides by shaking the ground and weakening the slopes. Steep slopes and presence of loose or weathered rock further increases the risk. Human activities such as deforestation, mining, road construction, and unplanned construction on hillsides disturb the natural balance of slopes, Poor drainage system and improper land use also contribute to landslides by allowing excess water to accumulate, leading to a sudden slope failure. So, what is a landslide? Landslide is a sudden movement of debris, especially like rocks, soil, and all, when they move down a slope because of gravity. Okay, now why does it happen? There are natural factors also, and there are human factors also. One of the biggest reason is the heaviest rainfall that occurs. When heavy rainfalls occur, water is absorbed by the soil over there, and the weight of the water and the land increases, because of which the soil generally becomes heavy and comes down. So the entire slope collapses. Apart from this, yet another important natural factor is earthquake and volcanic eruption that can also trigger the landslides. Other than this, the human activities that has increased the landslides is, one thing is cutting down the forest, second one is extreme mining activities, road construction and building of houses on slopy areas makes the land unstable and triggers the entire uh, concept of landslides here. So based on this information, the next information that you guys are supposed to fill is the areas that are prone to landslides. So talking about that, the first and the foremost regions are steep, hilly, and mountainous regions. So, usually landslides are seen in the mountainous regions or the areas with loose or weathered rocks, regions with heavy and continuous rainfall, or slopes affected by earthquakes or volcanic activity, or area with poor drainage or improper land use. Answer to this you can find in the passage that has been given to you. Talking about what are certain mitigation measures that can be adopted. Now, what are mitigation measures? Measures that we can adopt to reduce that natural disaster. In simple terms, as we are now talking about the landslides, we have to think about certain measures which we can adopt so that the landslide can be reduced. So, the first and foremost thing is afforestation. Plant trees as much as possible, because trees with the roots have the capability of holding the soil, and preservation of natural vegetation. Second, come up with proper drainage system to prevent water accumulation. Third, avoid excessive construction on hilly areas and unstable areas. Fourth one is strengthening the slopes using retaining walls or rock walls and terraces. Fifth one is regular monitoring and early warning systems. And sixth one is follow building codes and land use regulations. Okay, proper land use planning should be should be implemented, that can reduce the impact on the life and the livelihood of the people who are there. Now, concentrating on the third important things that you're supposed to fill is to identify recent examples of landslides that has taken place in India. So I have collected five for you guys. The first one is 2013 Kedarnath landslide that happened in Uttarakhand. In 2018 Kerala landslides. In 2021 Chamoli landslide in Uttarakhand, which we have studied in your textbook. The fifth one is Himachal Pradesh landslides, and sixth one is a very recent landslide that happened in 2026 as well as in 2024 in Wayanad, that is in Kerala, where the landslide happened. Okay, so this is how you have to work on the entire concepts of landforms and disasters. So that's all about the landslides that we were about to discuss. Moving ahead, these disasters remind us of how important proper planning and environmental protection generally are. Going ahead with the next natural disaster is to talk about the avalanches. Okay, now what is an avalanche? Let's read the information that has been given to us. Avalanches are caused by sudden instability of snow on steep mountain slopes. Heavy snowfall within a short period adds extra weight to the snowpack, making it unstable, especially when it rests on weak or loosely bonded layers of snow. A sudden rise in temperature can cause partial melting, reducing the friction that holds the snow together. Strong winds may also pile up snow unevenly, creating fragile layers. Natural disturbances such as earthquakes and vibrations, as well as human activities like skiing, trekking, or construction in mountainous areas, can trigger avalanches by disturbing the balance of the snow covered slopes. So, let's study about avalanche now. What is an avalanche? It's an sudden flow of snow or a ice down a mountain slope. But this ice comes with such a great speed that tons of ice suddenly come down the slope of the mountain, creating a lot of havoc. So, heavy snowfall adds more weight to the snow, and sometimes the snow rests on weak layers. Even a small disturbance can cause the entire snow mass to slide down. And if it is triggered again with strong winds, it can also make snow pile up unevenly. Along with that, earthquakes, vibrations, skying, trekking may also trigger avalanches. Okay, so based on that, we have to fill in the details for prone areas, then mitigation measures, and what are certain recent examples about the avalanches that have taken place. So, prone areas are definitely the mountainous regions that are covered with snow. So, high mountainous regions, steep slopes which are less than, usually greater than 30 degrees, then areas with heavy and continuous snowfall, then slopes with weak layers of snow or ice, regions prone to strong winds and sudden temperature changes, earthquakes, and all other things. What are certain measures that we can reduce or adopt to reduce the damage here? How can we reduce the damages that occur because of avalanches? The first and foremost thing is we are supposed to keep on monitoring the weather condition, snowfall, and snowpack conditions regularly. Second, use regular warning signs and establish avalanche forecasting. Third, avoid traveling on steep slopes during risky periods, especially during high snowfalls. Use avalanche safety equipments, then control snow buildup using artificial triggering when necessary, construct snow fences or barriers protecting structures, and most important thing is we have to spread awareness and provide training for safe mountain travel too. And what are certain recent examples? The 2012 Chadar Trek Avalanche in Ladakh, India, 2015 Sikkim Avalanche, 2019 Gurjar Valley Avalanche, 2021 Chamoli Avalanche, 2023 North Sikkim Avalanche, and 2024 Manali Avalanche of Himachal Pradesh. Now, what is one of the key takeaway of in regards of avalanches? Avalanches can be very sudden and deadly, but with proper awareness, planning, and precautionary measures, the impact can be greatly reduced. So, avalanches can happen suddenly, but you have to have proper awareness and preparedness for saving lives, first of ourselves and then of others. Because if we are alive, then we can contribute greatly in saving the other people too. Moving ahead with the next uh, natural disaster that we are going to discuss is about golfs. Okay. I'm not talking about the golf where you hit the ball. I'm talking about a natural disaster where the full form of golf goes as glacial lake outburst floods. Floods that occur because of glacial outburst. Okay. It is very sudden, it is powerful, it is destructive. You have to be aware and extremely prepared for it. Fine. So let's understand what is actually GOFs here. So glacial lake outburst floods are caused by sudden release of large volumes of water from glacial lakes due to natural and climatic factors. Rapid melting of glaciers because of rising temperature increases the size and water level of glacial lakes, putting pressure on their natural dams made of ice and loose moraines. Heavy rainfall or intense snowfall can add excess water to these lakes. Earthquakes, avalanches, landslides may strike the lake or weaken the dam, leading to its sudden collapse. As a result, the stored water is released abruptly, causing destructive floods in downstream areas. Now, this is a very important thing to understand. We know that glacial mountains are there, but very close to that, we have glacial lakes, lakes that are formed because of glaciers. These are not strong lakes or strong dams that are created. They are abruptly formed because of a shallow or a hollow shaped, dried up glacier that once existed, or because of erosional activities which have been getting filled up by rainwater or melted snow that has been deposited in it. So it is very weak in structure. And in such lake, if excessive water gets accumulated, The embankment that has been naturally created is not strong enough to hold excessive water, and that breaks away in a very destructive way, creating outburst floods and causing being very destructive in nature and causing the loss of life as well as livelihood in the downstream area or the low lying areas here. Fine. So that is about the entire concept of gulfs that we're supposed to study. The main cause of this is rapid melting due to rising temperature, heavy rainfall, earthquake, avalanches, and landslides entering the lake regions that increases the volume and causes a sudden outburst there. Now, talking about the areas that are extremely prone to this type of natural disaster is high mountainous regions with glaciers and glacial lakes, Himalayas of India, Nepal, Bhutan, China, and Pakistan, Karakoram and Hindu Kush range, Andes, Alps, and Rocky Mountains, regions with steep valleys and growing glacial lakes. Now, what are certain measures that we can adopt so that we can be prepared and at the same time reduce the impact of these floods? First thing is keep on monitoring the glacial lakes regularly using satellite images and field surveys. Install early warning signs and alarm networks in vulnerable areas. Remove unstable natural dams, build engineered spillways, restrict activities near glacial lakes and downstream zones, prepare hazard maps and evacuation plans, and create awareness and conduct community training program. These are certain measures which we can adopt to reduce the impact and be prepared and be aware about the entire process about how it is effect, how it occurs, and how we can save ourselves. Certain recent examples are the 2013 Kedarnath floods that occurred because of Gulf in Uttarakhand, which is linked to extreme rainfall and a glacier melt. Then next one is in Nepal in 2016, Imza Lake Gulf, Solukhumb, Nepal, and 2018 South Lokang Lake in Sikkim, India, and 2021 Gulf, especially Rishi Ganga and Dholi Ganga, and 2023 in Sikkim again in a lake called as Thormi Lake, Golf Risk Alert, Sikkim, India. So, what are certain key takeaway? Remember that golf is always triggered by climate change. As climate change increases, glacier starts melting, making golfs more dangerous than before. So they move at a greater speed, causing severe damage to life, property, infrastructure, and the environment. We have to monitor them on timely basis, be prepared, and spread community awareness, and so that we can reduce the impact of golfs. So this is about your third um, disaster that I wanted to discuss with you all that has been given in your textbook for exploding activity. Moving ahead with the most important one that is talking about the dust storms. Okay, so when we talk about dust storms, these are usually found in the desert regions. These are also extremely dangerous here. Okay, so let's go through the information given about the dust storms. Dust storms are caused by strong winds lifting large amounts of loose, dry soil, sand into the air. Prolonged drought and low rainfall dry out the soil, making it easier for the wind to pick up the fine particles. Dust storms are common in desert, semi-arid regions where the soil is loose and dry. Sparse vegetation cover, often due to deforestation, overgrazing, poor farming practices, also leaves the land unexposed. Climate change and extreme weather conditions can further increase the frequency and intensity of dust storms. Now, what is dust storm and what are the reasons behind the occurrence of a dust storm? Dust storms happen. Storms means winds. So they happen when strong winds are lifting what? Loose dust, which is nothing but sand and soil into the air. Where are they commonly found? In desert and dry regions, or any land which has been prolongedly affected because of drought or low rainfall, where the soil becomes extensively dry, or else in the areas where there is lack of vegetation, where the soil is exposed for the wind to carry it out. And moreover, because of climate change also, there is increasing number of dust storms that we generally see. Okay, so what are certain areas that are extremely prone to dust storms? Desert regions. Remember one thing. Talking about that, the Thar Desert region of India and Pakistan, Middle East region, especially Arabian Peninsula, North Africa, Sahara Desert, Central Asia, Australia interiors, southwestern United States, and part of China and Mongolia, where you see the desert condition existing. So, what are certain mitigation measures that we are supposed to adopt to overcome the effects of dust storms? First and foremost thing is afforestation to stabilize the soil, prevent overgrazing and promote sustainable farming, maintain ground cover with grasses or shrubs, proper land management and soil conservation practices, create windbreaks or shelter belts, early warning system and weather monitoring, and public awareness and protection health. Okay, like mask, staying indoors during the time of storms, because storms can create breathing issues and ultimately the death of a person also. Certain recent examples of dust storms, especially if we talk about India, is in 2018 in Delhi NCR, India, in Kuwait and Iraq in 2020, 2021 dust storms in China's Gansu province, in 2022 dust storm in California, USA, in 2023 dust storms in Rajasthan and regions of Gujarat areas. Okay, so dust storms are not so fatal, but at the same time they can be extremely dangerous because they reduce visibility, damage crops, and affect human health also. What is one of the key takeaway from dust storms that if you have to talk about? From dust storms, they harm health, reduce visibility, damage crops, disrupt transport, daily life, and all. So, how can we reduce it? Simple, as we have discussed the mitigation measures. Follow the same thing. Have proper land management, vegetation cover, early warnings, and that can reduce the impact and protect the communities here. So that's about your 4 land disasters which has been mentioned in your text. You can note down the same points or else you can form your own points and write your own answers as per the convenience of your teachers too. Moving ahead, as we are into the last part of the topic, let's have a quick recap about the entire chapter of shaping the earth and shaping our world. Okay, so what did all we study here? We studied about the earth's surface, which is constantly changing, and there are certain internal forces like earthquake, volcanoes, folding and faulting, building new landforms. There are external forces like weathering, erosion, and deposition that are shaping the earth's surface. There are agents of gradations like river, glacier, wind, waves, underground water, which are continuously modifying the landforms. There are different landforms that are connected with different natural disasters. Mountain slopes experience landslides. We studied about major disasters here. Then we studied about avalanches. We studied about GLOFs. We studied about dust forms. And understanding all these processes helps us protect lives, property, and environment as well. So, what are the key takeaways? Remember that Earth is dynamic, its surface is constantly changing. There are internal forces, external forces togetherly shaping and reshaping the Earth's surface. There are agents of gradation that acts as nature's artist, create diverse landforms. Landforms, whatever types of landforms are there, they influence human life and decide the what, and they are the vital resources for us, for our settlements and our very existence. Awareness and knowledge help us prepare for natural disasters and protect our planet as well. And that's the complete explanation of this video where we talk about landforms and disasters. And with this video, we complete the entire chapter of shaping of Earth's surface. That is your chapter number 2, geography, according to the new syllabus set up by the NCERT. I hope my videos on this entire lesson was much easier for you guys to understand. And if you found my videos on this chapter helpful, easy, then don't forget to like, share it with your friends, help them also to prepare through my videos, subscribe to my channel. Let's Revise by Vidyashri Kadlibuddi, and also remember to press the bell icon so you never miss out any other chapters that I'm going to post henceforth. Remember, Learning becomes easy when concepts are understood, not memorized. Thank you so much for watching. Until next time, keep learning, keep revising, and keep succeeding. Bye, everyone.